to
Let me
reconnect and disconnect.
let me introduce to you, then we will start. Okay.
Okay.
Okay, then. Good morning, all. On behalf of Amity University, Uttar Pradesh, Department of Information Technology, Amity School of Engineering and Technology, I feel privileged to extend my warm welcome to one and all for this session during InCITe 2023, the third International Conference on Information Technology. The theme of conference is Decision Intelligence, Transform Your World. We are grateful to have the opportunity to keep this session in a virtual mode and listen to eminent speakers so that our students can reap the seeds from the knowledge gathered in this session. Today, I am profusely elated to take the opportunity to invite our honorable speaker, Professor Dr. Gautam Srivastav. Sir is a professor in Bardon University, Canada. Sir has contributed diligently in the field of big data and data mining. He is man of distinct vision. Sir, you are an idol of knowledge, experience, and inspiration to many in the domain of big data and data mining. Dr. Gautam Srivastav earned his BSc degree from Berar Cliff University in USA in 2004, followed by his MSc and PhD degrees from the University of Victoria in Victoria, British Columbia, Canada in 2006 and 2011, respectively. He joined Bardon University in Manitoba, Canada in 2014 and is currently an associate professor there. He conducts research in the field of data mining and big data and published over 400 papers in high impact conferences and prestigious journals. He has also given guest lectures at universities in Taiwan and Czech Republic. He holds additional adjunct position in Canada, Taiwan, India, and China, and has given keynote addresses at several renowned conferences. Dr. Gautam is a IEEE senior member, and his research is funded by Natural Science and Engineering Research Council of Canada, NSERC. He is actively collaborating on research projects with academics from Taiwan, Singapore, Canada, Czech Republic, Poland, and USA. Sir, we invite you on platform to share a few words with us. Over to you, sir.
Okay, thank you very much. Can everyone hear me okay? Am I audible?
Yes, sir.
Okay, great. So yeah, thanks for the warm welcome. Appreciate the opportunity to speak to you all today. My topic that I decided to speak on today is about data privacy, which is basically one of the main things that I do, and how federated learning may be a solution to that in terms of our learning methodologies that we use for prediction and decision making. As noted before, I'm in Canada. My name probably gives it away. My parents are from India, so I do have connections to India through my parents. They were both born in India, so yeah, I really appreciate the opportunity to speak today. So I have a lot to probably try to get through today, so I'm not going to waste a lot of time talking more about myself, but federated learning for data privacy is basically the topic that I want to cover today. So just talking about just a brief outline. Federated learning is a type of learning system, so it has its basis in artificial intelligence, machine learning, any sort of algorithm that tries to learn from data. And so what I want to talk about today is basically give you an overview of federated learning. And then after the overview, then we can talk a little bit more about some of the issues or weaknesses that federated learning could face, and then talk about some adversarial attacks if we have time at the end that may plague federated learning. So without further ado, when we talk about artificial intelligence challenges, we kind of break things down into kind of four main areas, those being the volume of data, which I'll kind of expand on, the privacy of the data, the integrity of the data, and the distribution of the data. And so these four kind of elements in artificial intelligence kind of make up the, a circular view of how artificial intelligence and data kind of commingle with each other. And so a good artificial intelligence methodology or artificial intelligence technique needs to be able to address all four of these aspects to be effective. And so the one that kind of our talk today is probably going to lean towards is on integrity and privacy, because that's kind of the things that my research focuses on, but we'll also talk a little bit about the others as well. And so when we're talking about the first thing, which is volume, I mean, you'd have to be living under a rock not to realize that walking around the city that you're in or anywhere around the world, you're basically going to see people with mobile devices that are connected to the internet, thus making up the Internet of Things. And so a lot of the applications that run on IoT devices have AI in them, kind of embedded in them, to give recommendations, to make decisions, to tailor systems to your own interests. And so what we're kind of seeing there is a vast amount of data being collected, transmitted, and shared. And so these AI algorithms, if you've done any work in AI, you know that we first have to kind of train the algorithm on a subset of the data, anywhere from 20 to 30%, and then, sorry, the other way around, anywhere from 60 to 70%, and then we kind of test the data on the remaining portion. And so the training data, if the amount of data that we're looking at is large, then by default, the training data is also going to be large. And so, for instance, the amount of data and computational resources for some current models for NLP, like BERT-based and GPT-3, the amount of data for BERT-based is 13 gigabytes, for GPT-3, 570 gigabytes. There's 110 million parameters for BERT-based. There's 175 million parameters for GPT-3. So you can kind of see the volume that's kind of being created there. And so with volume comes one of the main issues in artificial intelligence technologies is the transmission, like the speed of data that needs to be shared with, say, a centralized server for it to be able to make recommendations or be able to create useful information from the data that it's collecting. And so this is almost becoming, for certain applications, not feasible. And so we need to look at alternatives where all of this data that usually gets collected at a central server now maybe is not as possible as it once was. And so when we're dealing with privacy and we're talking about these different sources of data, there's a few things that we need to think about. So data that's being collected by various applications often contains sensitive information. It could be sensitive information about you. It could be sensitive information about some health condition you have. It could be sensitive information about someone else. And so that personal information, we're not necessarily comfortable with sharing to a central server and giving access to a AI algorithm or machine algorithm to process. And so the best way to think about it is that data, that sensitive information, should be kept in their corresponding data owner silos. So basically, what that basically means is the data that pertains to you that you think is sensitive or private should be kept apart and not kind of mixed in with the volumes of data that are collected. So that's called a silo. And so a data silo basically is, you can think of it, the word silo comes from agriculture. Silos basically could collect grain or collect rice or whatever. And so the idea of a data silo would be just a personal data storage repository of data about you. And so what we technically want for different industries, so say, for example, the healthcare industry, we would want data stored in these data silos to be separate from other types of data so that we could protect the data that's in the silo from adversarial or malicious attacks or leakage of information outside of that silo. So that's just one example with healthcare. Now, there's also a type of data that would be protected through legal regulations. So, for example, bank data, like your banking information, telecom information about your cell phone, other personal information. These can all have legal ramifications if they're shared as well. And so these different sources of data altogether kind of create this volume of data, which we somehow need to figure out how to keep private. So that's kind of the motivation here. How do we create information silos that can remain private, thus protecting our sensitive information? And so the use cases from that I've talked about so far, so like banks, healthcare industry, your personal information that's stored, say, at your university, they would all benefit from learning models that don't necessarily depend on a centralized server. Okay, so you can kind of see where I'm going with this. And so one of the possible solutions for this is something called distributed machine learning or distributed learning systems. And so here, what we're looking at is instead of relying on a central server that's collecting a volume of data, now we're kind of offloading some of those tasks off to devices themselves to be able to create the training model locally within the silo, say within your device or within your computer, and thus not sharing your personal information back to central servers. So some of the weaknesses of this sort of thinking as far as machine learning, distributed machine learning go, there's kind of four mentioned here. One is communications costs. And so because of the amount of data that must be communicated over nodes, like nodes that are basically creating these silos in distributed machine learning, that's a major weakness of these models. Latency then, now we're kind of waiting on, due to the volume of data, we're kind of waiting on these nodes that are doing some training within them to communicate those back so that we can get a centralized model. And so that it's not exactly a beneficial environment for real-time solutions. Storage capacity. If all the data that I want to analyze is on my device or my PC, that volume of data may actually exceed my storage capacities on my machine. So that's another thing. And then obviously computational bottleneck. Now, centralized servers that we can consider and assume to be very powerful, now we're basically saying, okay, well, now I'm going to force my cell phone to do some of these machine learning or AI algorithms. What is the computational overhead that my machine needs to take on while it's still trying to do all of its user-friendly tasks that it would need to do in this situation? And so now when we're talking about is distribution, because we're getting into the distributed machine learning, so we need to think about what that model will actually look like. So in artificial intelligence, and we talk about data distribution, there's basically two types of data distribution going on. One is called independent and identically distributed random variables. And so here on the left of the screen, you can kind of see what that looks like. There's an equal probability of each of the numbers occurring in that data set. Whereas in non-independent and identically distributed random variables on the right side here, we don't have that same probability. Data is not necessarily distributed in the same manner, and so we don't necessarily see the same distribution amongst the nodes. So in non-independent, basically non-IID and identically distributed random variables, in a distributed setting or a distributed scenario, we can set an IID distribution if we have access to the data. If the data is distributed in several data silos, kind of like what I'm talking about, or devices, we cannot make the same assumption because we don't necessarily know the data distribution per silo as opposed to knowing what it could be centrally. And so here, just some basic terminology. If we have a set of clients, we can basically consider Q the distribution over the set of clients that own a set of data points, and the probability XY that the local data distribution is from client I. And in some non-IID, what we basically say is the local data distribution of client I and client J will be different. And so the probability distribution of data in silo I or client I and silo J and client A do not necessarily match. They don't follow the same distribution. So that's another challenge, because in a centralized model with more random distribution, we can say, because we have the whole collection of data, how it's distributed. However, with these separate silos, we can't necessarily define each silo to have the same distribution. Okay, so the third thing, privacy. And so this is kind of the crux of what I wanted to talk about today. And so what's happened with people's increase in having mobile devices and cell phones and all that stuff is they're increasingly aware about the relevance of preserving their privacy and the ownership of their personal data. So there's more of a onus on a user to be able to be aware that their data is important, their data is sensitive, and it should be protected. And so any sort of application that's using AI, there's a trust factor there. And so people are demanding more AI-based services. So, you know, TikTok, Snapchat, YouTube, all these things that use recommendation systems to give recommendations based on AI models. They're demanding more out of those applications, and they're reluctant to share personal information with those applications because they don't necessarily trust them. And so likewise, several legal frames have come up, like GDPR in the European Union. We have a similar thing here in North America called FIPA, where we're basically trying to create regulations around how private data can be shared. And so this new legislative landscape and growing concern makes it more difficult to develop distributed models that can basically adhere to these policies. And it's hindered the progress of distributed AI. Integrity. So data integrity, the standard distributed machine learning requires to transfer data among nodes. So when we're talking about distributed machine learning now, we're not talking about centralized server, we're talking about these nodes, so devices or other nodes that need to transfer data among them. And so this exposes data to be used by malicious agents, because if one of these nodes is malicious, all of a sudden they may have access to your personal information. And likewise, any sort of transferring of data between nodes could lead to data leakage as well. So before, in centralized models where we put all the pressure on the centralized systems, now that became the point of failure, the point of security concerns for your data, and it was everyone's data. Now, every node is kind of its own security concern. And so we need to address that in any sort of distributed model that we are creating. So I've kind of gone through this rather quickly, just so you kind of get an idea of the things that we need to work on, the challenges of AI algorithms. And then we're going to talk about how federated learning could perhaps answer some of those issues. And so here in this slide, it's just basically the 4 points: volume, privacy, integrity, and distribution, that I've kind of talked about already. So federated learning, what is federated learning? Well, basically here, before with AI and machine learning algorithms, we were using the centralized server to do all the computation, the training, the testing, everything. Now we're kind of offloading this on what are called local workers. And so these local workers make up devices that collect data, either about the person using it or otherwise. And so at the device level now, what we were expecting of the device is to do some computation, create what are called local models by local workers, share only the local model update with a centralized server or with other nodes to kind of put together and make a global model. So what's basically happening, if I want to simplify it a little bit, is what's basically happening is the local workers are not letting data leave their devices. All the data is staying in the data silo, which is on device. We're now putting a little bit more onus on the device itself to create the local model for the data that it has. And that local model then goes to a central server or some sort of repository where all those local models can be combined and created into a global update, which can then be shared out to all the devices as well. So it's kind of an ongoing process there. And so federated learning, if I was to define it, I would say, just like is on the slide, is a machine learning setting where multiple entities, clients or workers, whatever you want to call them, are collaborating in solving a machine learning problem under the coordination of a central server or service provider. So again, the central server kind of acts as a connecting point, but a lot of the work now is offloaded on devices. And so each client that's collecting data stores its raw data locally and doesn't exchange or transfer it, and instead creates these local models or local learning updates. And those local model updates are the only thing that are shared back to the centralized server. So what do we solve? Raw data is stored locally in the silo in our device, so its privacy is protected. Raw data is not transferred. Since it's not being transferred, there's no data leaks. And the learning local models, aggregation of local models to get a global model, still gives us the same outcome that the machine learning or AI algorithms were before, but now providing an extra layer of security and privacy for the data collected by the client. And so here, just basically a definition here, in federated learning, there are two kinds of nodes or clients. One are called data owner nodes, and they own their own raw data. And so here they're kind of defined as C1 to CN. The data itself are the local data sets that go along with those clients, D1 to DN. And then we have these aggregation nodes. And so what the aggregation nodes do in a federated learning model is they aggregate, basically put together the local learning models to learn it, to create or learn a global learning model from the data kept in the data owner's own nodes. And so the aim of federated learning then becomes to learn a global learning model based on the aggregation of local learning models through several rounds of learning. So it's not a one-time thing that you're just going to create one local model each client. You're going to share it and you're going to create a global model. As data is collected, these local models are created. They're shared with the aggregation nodes. The aggregation nodes aggregate them. And over time, we create a picture that's very similar to what classic AI algorithms used to do. On the bottom here is a reference. This would be a nice paper if you're actually interested in this to read from 2020. It kind of summarizes a lot of the things and gives a lot more background information as to what I'm talking about. So this is actually a really good paper. So the rounds of learning. So I said that things don't happen all at once. So we basically have rounds of learning now. In centralized AI models, we don't necessarily always have these rounds. Here, each client trains its local model, and then the local model sends it to the aggregated nodes, who then collects it and creates a global model. And then over time, we have these collections of global models that need to be aggregated, mostly at a centralized server, but no data is being exchanged. We're just creating these little pieces of model updates and then putting them together to create our end goal, whatever the AI algorithm would have wanting to do. So whether it's recommendation systems or decision making or classification, we're just doing it in a different manner. Now putting the onus back on the devices. Okay. So just, if I was to go through a series of steps, step one, central server chooses a statistical model to be trained. So what is the model that we want to use? Step two, central server transmits the initial model to several nodes. So the central server will then set up a collection of nodes that want to be involved in this algorithm. Step three, nodes train the model locally with their own data. So these nodes are collecting data that we're using for the training. Step four, central server pools model results, those local models, and generates one global model without accessing any data. So that's another thing here that I should mention, is that the central server here never actually gets to hold or touch or see any of the data. All the data stays on the specific clients and those devices. And so even if the central server was to get hacked or have a data leak, it doesn't actually have any data to give out. So, it would be a futile process. Now, I'm not saying that there isn't problems with federated learning. We'll kind of get into that a little bit later if there's time. And so the learning goal then, the rounds of the learning are repeated until we reach the learning goal. So whatever the threshold is for our learning goal, that's where we kind of keep repeating our rounds till we get to that. So we need to set up some sort of an objective function, and then we need to maximize it. Yeah, the font's a little bit funny here. The details of this are probably, available online as well, if you're kind of into the more technical side of what the actual math is behind that. So the key elements. So federated learning is a specific machine learning setting which incorporates some elements to the standard workflow. In particular, data stays on the device in the client, and they follow locally. They usually follow a non-IID distribution. If we know a little bit more about the data sources itself, occasionally you will see some IID distributions as well. But most likely non-IIDs, where you're looking at where you can't actually predict what the data distributions are going to be per client. And so, like just a recap here, the learning model is kind of made up of the local learning models done at the client side, and then the global model done either at the aggregation node or can also be done at the central server, depending how you want to set that up. So I'm just going to skip ahead, and I just want to talk about a couple of things before I run out of time here. So here, just some different examples about you can have cross-device federated learning where devices are sharing with a coordinated server. So, and this is all, you can see here the data sources are all maybe of different types. With the cross-silo federated learning, we may be gathering data from different silos, so say different hospitals or something like that, but we're kind of looking towards creating the same goal. There's three different types of federated learning, which is kind of what I wanted to talk about. Let me get to that. So yeah, there's three main types of federated learning: horizontal federated learning, vertical federated learning, and transfer federated learning. And so horizontal, if you can think about it, horizontal is like this. That means that we're kind of sharing data across the client. So the feature space and the label space is identical across clients. So here they're probably working on creating a model around the same type of data. In vertical, so as an example here, if we have two banks, each having their own silo, they kind of have the same features and labels of their data. So that would be a good example of a horizontal federated learning, because those banks can kind of cross data, both feature space and label space to create their model. Vertical, this way, is kind of thinking of the silos of being different types of data. And so as an example, if two companies share the same users, so say an insurance company and a telecom company, they have the same users, but their data and their features and labels are different. They want to kind of remain vertical with each other. And so they only want to share information after the model updates have happened. And so that's called vertical federated learning, where things are kind of like this. And then transfer federated learning is kind of an offshoot of the vertical, where the feature space is not shared and the label space is not shared. This is when there's a mismatch between the two, and the mismatch is usually quite large. And so here we actually want to train the global model in say silo A, and then transfer it over to B afterwards, just so because the spaces are just too different to be able to combine. So they're not actually sharing anything with each other before we try to combine into the final model. Okay, so the last thing I wanted to talk about kind of in the last couple minutes is weaknesses, attacks. And so federated learning is a type of machine learning, so it is vulnerable to adversarial attacks. If you've been paying attention, you can probably realize that if one of these clients that's in the model is adversarial, they can poison the data, and they can create local models that don't exactly fit or can send the global update in the wrong direction. And so there we need some sort of protection for the clients to make sure that they're authenticated to be part of the system. So here, just as an example, we could probably use blockchain to authenticate devices in combination with a federated learning model to make sure that adversarial devices are not trying to poison the overall global model that we're creating. And so the other thing that could happen potentially is if a group of malicious attackers try to work together, they can completely corrupt these federated learning models. And so that's kind of ongoing research that needs to be tackled. Pretty much all I'll say about that right now. Okay, so what's next is probably what you're wondering. So just as a kind of a summary here, we talked about the artificial intelligence challenges that federated learning is trying to tackle. We kind of defined and looked at a bunch of federated learning definitions, and I talked about a few different models. And we talked about just a little bit about the types of attacks that federated learning hasn't quite solved yet. And I briefly kind of hinted at a solution for malicious clients where blockchain could be used potentially to authenticate and keep the clients honest when they're working on this. Now, obviously, different types of cryptography and encryption would have to come in play here just to make sure that the models as they're being transferred, because there is local model transferring, that that data stays private. So what's next with federated learning, just as the last slide here? Explainable artificial intelligence is getting hot. So combining both XAI and federated learning is very interesting. Vertical federated learning, where we're kind of dealing with these silos that look like this, that's a really hot topic because a lot of companies end up sharing users. And so if they're sharing users, there is some collaboration that can be happening, even though the data itself and the feature space and the label space are a lot different. And then combining NLP models, so natural language processing models under federated learning is really interesting right now, because a lot of the applications that we're using on our phones that could make use of federated learning are collecting natural language type information. And so that's where federated learning could really make an impact when combined with NLP. So you can get not only the added benefits of the learning, but you can also get the added benefits of NLP, sentiment analysis, all that stuff from that side. Okay, I think that I'm out of time, so I'll stop because I know there's other talks today, but I'm happy to answer any questions if anyone has any.
Yes, sir. Thank you so much, sir, for insightful words. You talk about the decision intelligence transform your world and was particularly valuable as our students seek to expand their knowledge for professional growth in the field of decision intelligence. So I have one question.
Yeah.
Yeah. So what are the key factors to consider when selecting a federated learning approach to address data privacy and decision intelligence? Means what?
Yeah. So I think the main decisions that need to be made are, is the data that you're wanting to analyze, does it have security and privacy concerns? So a couple of things. Number one is, are you looking at a large amount of data? And if you are looking at a large amount of data, is there data within that set of data that has privacy and security concerns? So just as the perfect example, let's talk about healthcare. Healthcare data is sharing personal information. It's sharing, if you have illnesses, maybe you want to keep that personal, but there's value you can see in analyzing that data. And so federated learning makes a lot of sense there, because as, say, a doctor's office or a hospital is collecting data, that data never needs to leave the hospital. We can do the local models in the hospital itself and just share the model update with the centralized aggregator. So in those scenarios, we're creating a level of separation from the actual data from where it's actually needing to analyze and create useful information. So those are the two things that I think you need to consider. Is if you do have a large volume of data, federated learning makes sense right away because you're not transferring that data. Number two, is there privacy concerns with the data you're looking at? Then again, federated learning makes a lot of sense.
Okay. Thank you, sir. We are grateful for your time and expertise, and we appreciate your presence at MIT University, Uttar Pradesh. Thank you so much.
Yeah, thank you. Thanks, everyone. Have a good rest of the conference.
Okay, thank you, sir.
Stop.
Good morning. So now I take the opportunity to introduce our next eminent speaker for today, Dr. Avdesh Mishra, Texas and A&M University, Kingsville, United States. Dr. Avdesh is associated with the Department of Computer Science, Texas A&M University, Kingsville. He received a PhD degree in computer science from New Orleans in 2019. He had an experience with bioinformatics and machine learning lab, University of Orleans as a graduate research assistant and software engineer, Bitcraft, Kathmandu, Nepal. His research interests are in artificial intelligence and machine learning, data science in bioinformatics, computational and structural biology, biomedical informatics, evolutionary computation, information retrieval, text mining, and big data. He is interested in supervised, unsupervised, and semi-supervised learning and developing generative versus discriminative models and applying machine learning and deep learning technologies to solve complex cybersecurity problems such as malware, intrusion, and ransomware detection. I now invite you, sir, to share your work with us.
Thank you very much for a nice introduction. So as you already stated, I basically am from Nepal, and I did my bachelor's in computer engineering from Nepal. And then I started doing my master's and PhD from University of New Orleans in New Orleans, Louisiana, in United States. So today, without spending any further time here, because I know time is crucial, so I'll go ahead and share my screen and begin my talk. And if anybody has any questions in between, feel free to stop me. And we can also discuss the questions towards the end of the presentation. Okay, so today I'm going to basically discuss on one of the bioinformatics problem that we recently worked in, and we published this research in PLOS ONE journal in 2022. So a very fresh and new research. So on this talk, basically, I'll be talking about how we applied machine learning approaches for predicting the multivariate performance phenotype. And just to also address that, this is a very collaborative work. We had collaborators from University of New Orleans, Texas A&M Kingsville, School of Biological Science, University of Queensland, Australia, and also some of the researchers from France. So I'll be going over and kind of providing an introduction to multivariate, performance phenotype, and then some basics on machine learning. I won't be going too much into detail, but I'm pretty sure that a lot of our audiences have some experience and knowledge in machine learning. And then I'll be discussing about the materials and methods of the research that we conducted. Essentially, I'll be talking about the nature of the data set, how we handled missing values, because the data set had lots of missing values. And then I'll basically talk about the performance evaluation matrices that we utilized. And then we performed both classification and regression in this problem. So I'll talk about those. And finally, I'll discuss the results that we obtained through the machine learning application. And last but not least, some discussion and conclusion. I'll be sharing that. So to begin with, I'll just describe or introduce what multivariate performance phenotype basically means. So first, to understand multivariate performance phenotype, we need to understand what is performance phenotype itself. So it is basically a quantitative measure of how well an organism's conduct dynamic, ecological, or ecologically relevant tasks, such as running, jumping, or biting, right? So these are some of the characteristics of the species that we basically were looking at, and we extracted, or essentially, these features were extracted in the lab, and we applied machine learning on it. So the key predictor of both survival and reproductive system in animals. And so the performance phenotype basically is very important for animals to basically for their survival characteristics and also reproductive characteristics. So the also the multivariate term, right? Why do we consider, or why are we talking about the multivariate performance phenotype? So in our data set, we had some of these characteristics, for example, jumping, which is which is dependent on more than one other variables. And so we have multivariate features and characteristics that we include in our data set, and these are basically related to the performances of different species in lizard. Now, the next thing that I would like to kind of introduce is the ecomorphological paradigm of performance. So essentially, this ecomorphological paradigm is kind of a statistical framework, which basically states that morphology can actually be utilized to determine the performance. And so we use these morphologies to basically find some relationship between the morphology and performance. And basically we model that using the artificial intelligence or machine learning technique. But modeling the performance as a function of morphology alone is not always straightforward, because we have to deal with so much of complexity within the data. And so essentially the performances of the species that we basically extracted are basically listed in this slide, and the performance expressions essentially can be moderated or enhanced or constrained by different factors. And these factors are behavioral factors. It is also energetic costs, elastic storage mechanisms, likewise the complex relationships among performance and other facets of the integrative organismal phenotypes. So performance can be expressed, with different type of factors that are listed here, right? And so indeed, we can say that the performance phenotype is multivariate because it is not just dependent on one specific variable, but more than one variable. And so in the context of machine learning, essentially, just a basic description of what machine learning is. Essentially, it's a field of study that gives computers the ability to learn without being explicitly programmed, right? And it is often used to identify and analyze the patterns within extremely large and detailed data sets. And it basically is used to fill in gaps in large, complex data sets and to produce accurate predictions for novel data set. So the goal here in this particular research was to build an application using machine learning to essentially predict unmeasured performance values from a large and fragmented data set on lizard species using lizard morphology and performance. So then moving on to the materials and methods. So first, I would like to describe the nature of the data set. Essentially, we had large data set. It consisted of about 2,000 individual lizards from 68 different species. And these samples basically consisted of different type of features. The first set of features were morphological features. And so the morphological features consisted of features such as head dimension, the body size, likewise the individual limb elements, for example, femur and tibia. Likewise, the tail length was another morphological feature. In addition to that, we also extracted some performance-based features, which were sprint speed, which is related to how many steps would individual species takes while the species basically is running. And then the endurance is basically the strength to basically continue to kind of resist something, right? Likewise, we included climbing as a performance feature, and also exertion or distance capacity. Likewise, the jumping characteristics and bite force. Okay, so these are the different morphological and performance-based features that we included in our study. And to kind of give you an overview of how the data was distributed. So on our x-axis, you can see the 68 different species, and the y-axis, you can see the counts of these the samples, right? So from this figure, we can see the important information that the data set was extremely imbalanced, right? So for some of these species, we didn't had like a specific or we didn't have enough samples, and whereas for other species we had extremely large number of samples. For example, this particular species and also this particular species, right? So our data set was highly imbalanced in terms of both species representation and the amount of data available for each of these species that we had. And it was also incomplete in terms of both morphology and performance features. And what that means is basically for lots of these samples, one or the other of these morphological or performance-based features were missing, right? So it consisted of lots of missing values, right? So our problem was double. We are dealing with highly imbalanced data, as well as data with missing values. Now, here is basically a representation of the 68 species and the families to which they belong to. So essentially, they belong to 8 different families of lizard species. But one thing to kind of note here is that we try to include the relationship between the species and their families into our machine learning model, but we were not able to gain any performance improvement by including the relationship between the species and their families. Now, so we had, as I stated, lots of missing values in our data set. So here I'm going to explain what we did for handling the missing values. So essentially, one of these strategies, or basically the strategy that we applied for handling the missing value, is basically the k-nearest neighbor based method, right? So it's a machine learning based method, but we try to utilize it to compute these missing values in our data set. So the first thing that we did is we calculated the Euclidean distance between a target sample. Let's say that sample is represented as S, and belonging to a target feature, which is F. And in this case, it would be basically a phenotype, and also all the other samples that is included in the data set, right? So the first part was to compute the distance between the target sample and the other samples that were available in the data set. Then the missing values for that particular target is computed by computing the average value of the 5 closest samples if we select the value of k to be 5. Now, initially, we applied the KNN method within each taxon, or basically within each species. However, since the data set actually contained taxa, sometimes with no values at all, for certain features, we ultimately ended up applying k-nearest neighbor based on missing value imputation, utilizing the entire data set. So these are the performance evaluation matrices that we actually utilized to assess the classification-based framework that we developed. Essentially, we computed accuracy and Matthews correlation coefficient, and these are the details of the or kind of a definition or formula to calculate the accuracy and Matthews correlation coefficient. To be able to compute those, essentially we compute the true positive, true negative, false positive, and false negative. And once we have that, we compute the accuracy and Matthews correlation coefficient, right? And we obtain these, true positive and true negative, false positive, false negatives from the actual, label of the class and the predicted labels. And so once we have those, we can easily compute the accuracy and Matthews correlation coefficient. And we performed, or utilized tenfold cross-validation to evaluate all of our models. The next type of approach that we utilize is the regression-based approach, right? So for the evaluation of the regression models, we utilize the Pearson correlation coefficient and mean absolute error. And these are also defined, here in this, table with, appropriate, formula. So mean absolute error is computed by taking the, difference between the actual and the predicted value, and then taking the mod of that and then summing it over, dividing it by the number of samples. And also, on the other hand, root mean square error is basically taken by, computing the difference, taking a square root of that, a square of that, and then summing it over for all the samples and dividing it by the number of samples. And finally, we take the square root of that. Okay, so then the actual classification framework, essentially, we utilize the classification framework to predict the taxon or the species itself, right? So given the characteristics of this species, can we say whether this species basically belongs to a particular class or not, right? And so we apply different types of classification model on the overall data set, and these are different classification algorithms that we tried. Essentially, we explored bagging classifier, a decision tree-based classifier, extra tree, gradient boosting, k-nearest neighbor, logistic regression, and support vector machine, and finally XGBoost classifier. So among all of these classifiers, we found that optimized support vector classifier with RBF kernel actually performed the best. And I'll talk about the results in just a moment. But in addition to that, in addition to comparing the performances of individual, machine learning methods or traditional machine learning methods, we went ahead and implemented a stacking-based machine learning model to kind of improve the performance of the overall model. So in stacking, we basically have two different layers. The base layer consists of combination of different classifiers, and the other layer basically consists of a meta layer, which basically usually involves a single classifier. And so this is basically a general framework for the classification. You have your data set, and the data set basically consists of, the features and class label, right? And those are basically passed on to the base layer classifiers. The base layer classifiers, they make predictions, right? And the prediction probabilities from these base layer classifiers are then combined with the features or the original features, right? And those are then passed on to the meta layer classifier, right? And then the final output is obtained from this meta layer. So we then move on to the discussion of the regression framework. So for the classification, we were predicting whether the sample belongs to a particular species or not. But in the case of regression implementation, we were predicting the performance capacity of a given sample. So, we were essentially predicting whether what would be a jumping power of a given species, right? So here we tried different regression models, and we essentially tried extra tree regressor, gradient boosting regressor, random forest, support vector machine regressor, and XGBoost regressor. On top of that, we also went ahead and applied the stacking-based machine learning algorithm. But when comparing, these individual or traditional machine learning algorithms, we found that jump power actually gives the best PCC and MAE, while using R2 and optimized support vector regressor with RVF kernel. So here is the general framework of the regression model that we created. Essentially, again, we start with the data set. We have our features, right? And the class label in this case would be one of those performance characteristics. And then we have several of the machine learning or the regression-based model in the base layer. Then we make predictions, right? And the outcomes of those predictions are combined with the original features. Those are passed into the meta layer. And finally, we obtain the predictions from the meta layer. So, then moving on to the some of the results, right? So the first thing to do was to identify the appropriate value of K, as we were utilizing K nearest neighbor for missing value imputation. So we essentially tried different values of K, ranging from 1 to 100. And basically this table shows the different type of features and the optimum, value of K for these features, and the root mean square error that we obtain for individual features itself. So from there, then, let's talk about the results from the classification framework. So in this table, what I'm showing is the comparison of different traditional machine learning based, classifiers and their corresponding accuracy and Matthews correlation coefficient. So the bold value actually indicates the best performer, and so the SVM was able to yield an accuracy of 86% and a Matthews correlation coefficient of 85%. So as we now understand that we also implemented stacking-based model to improve the performances. Here are basically different stacking architectures or models that we created and compared. So in our first stacking-based model, we used support vector classifier logreg and KNN, as well as XGB classifier as the base layer, and we utilize the support vector machine as the meta layer. And in the other part, we tried, or in the other model, we tried XGB classifier as the metal layer. And then we made some, changes. We used XGB as the metal layer, but we replaced the, XGB in the second model with the GBC in the third model. Right, and we did the comparison, and the comparison basically showed that the first stacking-based framework that we created actually resulted into the highest performance, which is 84% for accuracy and 82% for Matthews correlation coefficient. Okay, and so then the regression-based model, right? So in this case, again, we are trying to predict the performances of these different species, right? So in the first column here, I have, different features. Then in the second column, the table shows different type of classifiers that were utilized. Then the mean value of that particular feature vector, and then the Pearson correlation coefficient and mean absolute error that we obtained for these individual features prediction. So essentially, we saw that we obtained the highest performance for the jump acceleration, and the Pearson correlation coefficient was 0.97, and the mean absolute error was 0.36. And so after predicting these individual features or performances, utilizing individual regression methods, we then went ahead and created several of the stacked-based models. So we created essentially 5 of them with different, configurations. Essentially, we use different, regression models in the base layer and, in the metal layer. So for, model 1, we tried extra tree regressor in the metal layer, GBR in the second one, random forest in the third one, likewise XGB in the fourth, and SVR in the fifth one. Okay, so then we went ahead and tested the performance or assessed the performance of the stacked configurations, and we did it for all the different type of performance features. And from here, we basically observed that overall, in an average, we were able to obtain a Pearson correlation coefficient of 0.973, which is really close to 1. And the mean absolute error was 0.434, so that was quite low, right? And looking at individual performance, we were able to obtain 99% of PCC for several of these performance features. So ultimately, we basically built a machine learning model that predicts the performance with very high accuracy, ranging from 93% to 99%, and also low MAE, ranging from 0.03 to 1.73. But there is some limitation essentially, and the limitation is that our data set is actually limited to terrestrial locomotion, such as walking, jumping, and running, with the exception of the bite force. And we basically did not include the locomotor performances such as swimming and flight in our data set. So the model actually also was only been or has only been formally validated with 68 species of lizard. And so if the researchers are interested in this model, they want to adopt this model and apply it into some other types of lizard species, they should utilize it with caution. and maybe they can utilize the model to kind of do their assessment for the first phase, but they can very easily modify the model that basically would fit to their specific needs. Right. So with that, I just want to acknowledge the authors who actually contributed or helped us with the data set. So I'd like to thank Jerry, Anne, and Jonathan, who contributed and supported us with making the data set available to us. And here's the reference of this journal paper that was published in PLOS ONE. And with that, I would like to thank everybody for patiently, listening to my talk, and I would be happy to answer any questions that the audiences might have.
Oh, thank you very much, Dr. Avdesh, for introducing the audience to such an exciting topic on predicting multivariate performance phenotype for using machine learning models. So I have one question from the audience on that. When we are stacking up these, classification or regression frameworks for predicting, phenotypes for a specific organism, then, how we are choosing these base layers and meta layers for stacking up? Is there a
principle
from you that how you can select the base layers and meta layers?
Okay, so yes, so actually there are two different ways that the base layers, classifiers or regressors can be selected. One of the approach is that you can select the base layer classifier or regressor based on their principle of operation. So usually, you would try to learn different information from the data set, right? And these different machine learning models are based on different principles, right? The k nearest neighbor basically tries to identify the nearest neighbor, and then account for that. Likewise, support vector machine is based on, basically building or creating a decision boundary based on some support vectors that it identifies from the data, right? And utilize that. And basically it tries to maximize the margin. So the principle based on which these different machine learning algorithms have been developed, they are different, right? And they learn different type of pattern or different type of information from the data. So intuitively, it is a good idea to select these classifiers or regressors that are based on different principles of operation, right? To select the classifier or regressor for the meta layer, usually what we do is we try and evaluate the individual or traditional machine learning algorithms and pick the one that gives us the highest performance and utilize that to be the meta layer classifier or regressor. So that's one intuition, and the other technique would also be to kind of study the correlation between the outcomes of these different classifiers or regressors, and then try to pick those classifiers or regressors which are less correlated, right? So if they are less correlated, that means they kind of are learning different kind of information from the data, and it would be meaningful to have those machine learning models be chosen for the base layer.
Thank you very much, Dr. Avdesh, for patiently listening to the question and answering in such great detail. Now I hand over the mic to my colleague, Dr. Monica.
Sure.
Thank you, Dr. Avdesh.
Thank you so much. Thank you for the opportunity again to present my research in the conference, and I hope that you all have a very nice rest of the conference.
Thank you so much.
Thank you.
Hello, Dr. Vidyashri.
Hi, can you hear me?
Yeah.
Awesome. Just in terms of the timing, would you like me to keep it to 20 minutes or 30 minutes?
20 to 25 minutes, it's fine.
Okay,
Okay.
I'll do my best.
Okay, now I will welcome you and then you will start your talk, okay?
Sounds good.
So now I take the opportunity to invite our next eminent speaker who is here with us today, Dr. Vidyashree Nagaraju, University of Tulsa, USA. Dr. Vidyashree is an assistant professor at the 10-day School of Computer Science at University of Tulsa. She received her PhD in computer engineering from InCITe MS in computer engineering in 2015. She received a BE degree in communication engineering from Vishwesaraya Technological University, India. Her research interests are software reliability, reliability analysis, reliability engineering, reliability theory, cybersecurity, and probabilistic risk analysis. Okay, ma'am. Vidyashree, ma'am, over to you.
Thank you very much. Thank you for the introduction. Good morning, everyone. And I'm really thrilled to be here at the International Conference on Information Technology and having this opportunity to talk a little bit about my research and, get you to think about some future possibilities or directions in the context of my research, which is software reliability. And this is work done when I was a faculty at the University of Tulsa, and I'm currently working as a senior software quality and reliability engineer at an organization called Bastion Technologies here, where we are part of the NASA spacesuit design at the moment down in Houston, Texas. So what I want to talk about today is, like I said, about my research, but I want to talk in detail of how machine learning can be applied to this particular research area where the majority of the research is focused on developing statistical models. And in the interest of time, I'm going to keep this presentation very focused on just talking about why just a simple application of machine learning algorithms in this context is important, and maybe give you a little bit of background on the software reliability growth models, or SRGM, or NHPP SRGM as we call it, and go over the machine learning models itself, which is, we will discuss the incremental learning models in detail, and I'll talk to you about why we chose this particular model, and the adaptive incremental learning, which we kind of improved upon to make it applicable to the specific area that we are discussing. And I'll try to provide some examples to show you the application of this concept in the context of software development, and we'll conclude with some future directions. So for those of you who are not necessarily familiar with what software reliability growth modeling is, software reliability growth models essentially is a modeling methodology that allows you to quantify software metrics to assist in release decisions. Specifically, these software reliability growth models are used to characterize this failure data that you collect during the software testing. Before I go any further, just software reliability by definition is the probability of failure-free operation in a specified period of time in a specified environment. And in simple words, it's just making sure the software you're developing is doing what it's supposed to do when you have deployed it. Meaning, if you have a software-enabled system that is plugged in to monitor someone's heart rate, you just want that machine to monitor that person's heart rate, because you want to make sure you're keeping track when things go out of hand, and you provide the necessary care that the person deserves and need at the moment, right? So it's important when we think of safety critical systems, or such as healthcare systems, mission critical systems, such as what we do in terms of defense organizations and information technology and other businesses. So it's important to make sure that the software enabled systems are reliable and available, and they do what they're supposed to do. Otherwise, the consequences can be severe and catastrophic in terms of we could use people there could be loss of lives, or there could be severe economic damage. So that's why, and obviously, we can only test for so long. There have been so many situations where there's always urgency to deploy new methodologies. So we don't necessarily have sufficient time to testing. And that's where the statistical approaches comes into picture. And that's where the software reliability growth models comes into picture. And these models, especially the non-homogeneous Poisson process software reliability growth models, which is a mouthful, or NHPP-SRGM in short, they characterize this failure data that you collect during the software testing. And they fit this data. So you have this like a staircase plot, which essentially just will be incremented every time you identify a unique defect. And you try to fit that using a smooth curve. So you can predict the future faults, which is as a function of testing time or the resources or the effort that you can allocate. And by doing that, you can make certain inferences about your software development, such as, how many faults are remaining in my system, or how long do I have to test to achieve a certain level of reliability? And also you could formulate optimization problems such as, what is the best time to release my software, and how much resource can I allocate in terms of budget or human resources and whatnot. So these are some of the inferences that's enabled by the software reliability growth models, which have benefited the community in many ways, and we still use it in the software development process to know when to release and how reliable or robust our designs are. So needless to say, it's a very important technology. It's a very important methodology, and it's most commonly used. But the modeling itself, the software reliability growth models that I talked about, and fitting that smooth curve, when you are developing these models, depending on the complexity of the system itself, the complexity of your model could increase. And it definitely will, because we have all these software-enabled systems and the dependency is higher. And the systems are getting more and more complex every day. And if you're building a model that would characterize that particular system or particular processes, it can get significantly complicated. So in such situations, you're going to need to have a faster and a stable and an efficient algorithm to fit these models, meaning to identify the numerical values of these model parameters that would characterize this data very well. And also when you're doing testing or assessment or applying these models, you don't want to wait until the end of testing to make these assessments. You want to do this as you're conducting testing and collecting the data, so you can make your decisions, or you can kind of make sure your model is predicting the data well as you're doing the testing. So the online assessment is also very important. But the reality is, it's really hard, depending on the complexity of these models, it's really hard to develop algorithms, statistical algorithms or numerical algorithms, such as expectation maximization, expectation conditional maximization, or even Newton-Raphson method, or whatever other numerical approaches that you want to apply. It's really hard to make them applicable or make them efficient and faster to fit these models. It's going to get slower depending on the number of model parameters and the size of the data that you have. So to address this, some of the existing studies, the past research in the past 2 to 3 decades, have experimented with the application of simple machine learning algorithms on these failure data sets, which is a really amazing approach to take advantage of one of the most efficient methodology that is in our current field and apply it in the context of software reliability or software testing. This is great, but the problem is we don't necessarily have sufficient amount of test data, because not every project involves writing billions of code. Not every project has a proper way of collecting the data, and not every project members know how to collect this data. So because of all these reasons, we don't necessarily have sufficient data. And when we have small subset of data or small data size, that's when the statistical models comes into picture. They're extremely efficient, but obviously for all the reasons that I just described, it's better to maybe modify or apply these machine learning models in this context. But like I said, your machine learning models are only as good as the data you train them on. And if you don't have sufficient data, your models are not necessarily any good. And also one of the other problem that I mentioned is to be able to do online assessment of data as testing progresses, which machine learning will allow you to do, especially with, I'm sure most of you have heard of this, incremental learning, active learning, and all sorts of new learning approaches are coming up in the research field. And one of the methods is incremental learning, which essentially provides you the opportunity or the possibility to applying machine learning algorithms in an online manner, meaning you can apply your model as data becomes available. Instead of retraining your models every single time a new subset of data becomes available, you can use the trained model and just train it on the just newly available data. But like I said, again, data is the issue. So what we did, what we kind of experimented with to see the applicability of machine learning models in this context is what we called as adaptive incremental learning. Because like I said, even especially at the beginning of the testing, we don't have sufficient data. So there is the application of machine learning models doesn't really make any sense. When you have 5 data points, 10 data points, 15 data points, how well can your machine learning perform, right? So considering that, we proposed this adaptive incremental learning model, or AIL model, in which the approach was, well, you don't necessarily have data for your present project or the software that you're developing, but maybe you have data similar to this project, or maybe from the same family, or maybe from a subset of the project. So if you do have that kind of data, the historical data, can we use that to train our model and have our model use that knowledge to predict on these smaller data sets, especially towards the beginning of testing when we don't have a whole lot of data points? The sample size is very, very limited. And that's what this approach is all about. And since we weren't really developing any project, this was more of a study. We selected a bunch of data sets from literature, and just to compare how well they characterize or the similarities or the correlation between the distribution of these data sets, we utilized what's known as Granger causality test, which essentially tells you if training on one data set will enable prediction of the other data set. So that's what we did. And I'll go into details in a minute. And the results were promising, which was a really exciting moment for especially, being a software reliability practitioner and a researcher to be able to use this in real projects. This result and this approach was very promising. So to give you a little bit of their background on NHP-PSR-GM, non-homogeneous Poisson process is a stochastic process that counts the number of events observed as a function of time. And in the context of software reliability, NHP counts the number of faults detected as a function of testing time. And this is a counting process. It's it's that staircase function that I was talking about, which increases as you identify a new unique defect. And you just want to fit that, which is an average of random variable. You want to fit that with that smooth curve, which is your counting process. That average is what we call as mean value function. And most of these models are represented using this form M of t equals A times F of t. And this big F of t is your cumulative distribution function, or the distribution of your data. It could be exponential, logistic, S-shaped, whatever form your data set follows. And if you're able to substitute that distribution here, that gives you the mean value function of that particular model. So if I plug in exponential here, I could say I have an exponential software reliability growth model, and this is the mathematical form of it. And this parameter A here indicates the number of faults that would be detected if the testing was continued for an indefinite period of time. So in the context of, just to give you an example, I took 2 models, which are a generalization of exponential model, and plugged in place of big F of t So the first one is Go-Locomoto, which is simply an exponential model, but these two researchers applied this in the context of software reliability, hence the name Go-Locomoto or GEO. And here B is your scale parameter. This is a very simple exponential distribution. And then we have this delayed S-shape or DSS, where it's the generalization of exponential, but you have this 1 plus BT term, or the BT times e to the power negative BT, which just encompasses or incorporates the delay in detecting that fault and actually reporting it. So as you can see, just between these two simple models, you can characterize the process, the testing process, and just the whole system itself, depending on your understanding. For instance, this was exponential, and here the model incorporates a delay. And once you have these models, you try to formulate an objective function such as log likelihood function, and then you maximize that function to identify model parameter values such as A and B for a particular data set by applying algorithms such as Newton-Raphson method or expectation maximization or expectation conditional maximization kind of algorithms. And some studies have also applied soft computing techniques such as genetic algorithms, swarm optimization algorithms, and many other approaches. So I'm not going to go into detail. You all know what neural network is. You're attending this conference. I'm not going to preach to the choir, but a neural network is a simple machine learning algorithm that's made up of 3 components: nodes, learning algorithm, and size and shape of the network. And the standard equation is usually of this node processing and input is represented in this formulation, very generic. W is the weights, and X is your input vector, and A is your activation function, and B is your bias. And this is another very simple generalized structure of your network comprised of an input layer, hidden layer, and output layer. And you can have as many layers as you want, depending on the problem, depending on the level of training or how you want to train your model. So a very simple representation of neural network, just to refresh your memory. And just for the purpose of this particular example, I use several activation functions, including the exponential linear unit or LU, and a rectified linear unit or ReLU, and sigmoid, as well as CANH. And we also customized one other activation function called as GEO neural network. As you can see, this was derived based off of the Go-Locomoto, which is a simple exponential, which is also a simple generalization of the ReLU activation function. The reason we picked this is because we came across several studies which claim to modify the activation functions with NHPP model formulations, and which seem to achieve a better model fitting or accuracy overall, predictive accuracy. So we were kind of curious to see, oh, well, everybody says GEO model seemed to be the best activation function, so why not throw it in the mix? So we'll see what happens, right? So that's how we modified that particular activation function, and we mixed it up. So in comparison, we're going to see some of the traditional models, such as the GEO and DSS model that I talked about, which are the traditional statistical models. And also we'll see how this neural network, specifically incremental and adaptive incremental learning algorithms that I was talking about, applied with these activation functions. So incremental learning algorithm, what you see here is just one iteration, and you have this term delta, which is the size of the data set or the subset of the data set that's available for you or to you for your study at the moment. And in this case, DS1 indicates data set, and essentially you start from the beginning to the length or the subset of the data, the size of the subset of the data that's available. It's essentially saying that you're just going to train it on a fraction of the data, because in machine learning, you take like 80% of the data for training or 20% for testing, or you break it down into train, test, and validation sets depending on how you do it. In this case, we are only breaking it down into training and testing data. And we are essentially just splitting it, taking small portions, and incrementally doing the data analysis as data becomes available. So this is the traditional approach of incremental learning. And the way we modified and called it adaptive incremental learning is we have two data sets. So you have a model that's initially trained on the first data set, call it DS1. And you have DS2, which is the data set that you're currently collecting, or you're testing your software, you're collecting that particular data. So you don't have full data set yet. You only have parts of data set because you just started your training. So delta is that part of that subset of the data set that you have. So as you can see, we do the model fit DS1 to begin with. That's in line 4 here. I don't know if you can see my cursor pointing. And then you use the model fit DS2 to continue with the way incremental learning was doing. So the major difference is you find a past data set or an historical data set that you were able to fit that kind of helps you predict the failures of your current data set that you're looking at. And these are some of the measures that we use to compare, basic mean squared error, predictive errors, just 5 combination of errors that we used. So to illustrate this, to compare this, we took the CS3 data set, which has about 104 failures. Like I said, we used all these activation functions, and the traditional models that was used was Geo and DSS. And comparing the data sets, give me a moment. So when we compared these models, so you have these NHPP and all these. So this is a very simple application of neural network. And the point here is, as you can see, LU seemed to have a good model fitting and one predictive. And the traditional Goy-Locomoto model has a good predictive measure compared to all of the models. However, when you compare LU and GEO and NHPP, the difference between LU, that's 15, and GEO, 14, is not really that statistically significant. So they both kind of stand in.
Hello, Dr. Vidyashri, sorry to interrupt.
Yes.
Please
Yes.
conclude.
Yes, absolutely.
Thank you.
Thank you. Anyway, so the point is, in this particular approach, the neural network model seemed to fit really well compared to, and as well as the traditional models. So this is just an example of that. This is your training and this is your testing data set. And we also did a quick study to see how well these models can predict. It's not just one step, but can it predict many number of faults into the future? And again, this gray line and blue line, which is the LU and GEO and HPP, seem to be doing really well. It's showing smaller error, meaning better prediction. And then we did the comparison of so many data sets to pick how do we apply adaptive incremental learning to pick the data set. That's the Granger causality test. And we picked a data set which has the smallest p-value. That was CS3 and CS1 data set of 104 and 397. When we compared that, the solid line here is your traditional incremental learning, whereas the gray line here is your adaptive incremental learning. And as you can see, in many situations, the difference between the AIL and IL are significant. Sometimes it's almost 200 difference. Even here, as you can see, the y-axis is 0 to 250, so the error has a significant difference. So this is not an amazing result. This is not revolutionary, but this is promising. Like I said, this kind of gave us a really promising approach to be able to apply, which we're also doing and trying to implement in our current project that's ongoing, which is adaptive incremental learning, which was a really good experimentation in terms of just applying machine learning in the context of software reliability. And that concludes my presentation. I guess if we have time for questions, we can do that. Otherwise, feel free to pass on the questions and I'll try to get back to you with answers.
Thank you, Vidyashri.
Thank you.
Thank you so much. It was wonderful listening to your knowledge words. Thank you so much. And as of now, we don't have any questions. So thank you so much, Vidyashri. Nice lecture.
Thank you very much.
Very informative. Thank you.
Thank you very much. Bye.
maybe where the jacket.
Very hot inside of your. You can be seated. अरे वो वहाँ से finally will share for and these are so they are going to be in investment. एक मिनट ये बताओ वो बताओ जरा वहाँ से सारे फैकल्टी को लोग के अंदर आके यहाँ बैठेंगे ये एक्सचेंज अपॉर्चुनिटी की डिस्कशन हो रही है जल्दी बनाओ सब फैकल्टी के अंदर जो हमारे फैकल्टी ऊपर नीचे बाहर खड़े सबको अंदर बिठाओ हरी आप इस सेशन में मेल करा दूँ हाँ डी वाले पे करा जीमेल वाले का वेलकम वगैरह करना पड़ेगा करो तो We now have two of our eminent speakers for today. Professor Dr. Sean McLoone, Director, Center for Intelligence and Autonomous Manufacturing Systems, Queen's University, Belfast, UK. We welcome you, sir, here. Our next eminent speaker for today is Dr. Nikhil Arora. He is Director, Data Intelligence, S&P Global. We welcome you, sir, here in Amity University. A big round of applause. I now request Professor Dr. Nitasha Hastir, ma'am, to present a sapling to Professor Dr. Sean McLoone as a token of our gratitude. Now I request Dr. Nikhil Arora to please come on the dais. I request Professor Dr. Natasha Hastir, ma'am, to welcome our guest with a Tulsi sapling. I request Sunil and Anjali to join us. Sunil and Anjali to join us. I also request Mr. Sunil Chaudhary and Ms. Anjali Kapoor to present our guest with a token of gratitude from our side. Now I take the opportunity to introduce our first eminent speaker, Professor Dr. Sean McLoone, Director, Center for Intelligent and Autonomous Manufacturing Systems, Queen's University, Belfast, UK. Dr. McLoone directs the Center for Intelligent Autonomous Manufacturing Systems as the Faculty of Engineering and Physical Sciences, QUB. He has a keen interest in autonomous robotics and co-founded RoboArian, a research team that competes annually in the NAO Robot Standard Platform League of RoboCup. Professor McLoone's research centers on intelligent systems and includes database modeling and analysis of dynamical systems. His research includes classical system identification, fault diagnosis, and statistical process control, along with modern artificial intelligence and adaptive learning algorithms and optimization techniques. His research has a strong application focus with projects undertaken in collaboration with industry in areas such as process monitoring, control, optimization, and the time series prediction. Dr. McLoone serves as a member of the IFAC technical committees on computational intelligence in control and modeling, identification and signal processing, and a member of IET Academic Accreditation Committee. He is an associate editor for the transactions of the Institute of Measurement and Control and serves on the editorial board of engineering applications of artificial intelligence. He was also a past member of the Accreditation Board of Engineers, Ireland. I now request you, sir, to share your work with us.
Yeah, that was good. Good. How do you advance? Page up, page down. Yeah, I'm there. Good morning, everybody. Thank you for the kind introduction. So my talk today is on neural networks, asking the question, can they predict the future? And as the answer yes, no, or maybe. Well, hopefully I will give you some sort of insights into how to answer that question through my presentation. And before we get into the particular topic, I thought it'd be useful maybe just mention a little bit about my background at Queen's University Belfast. So I have two roles at the university where I am. I'm the director for the Energy, Power and Intelligence Systems and Control Research team within the School of Electrical, Electronic Engineering and Computer Science at the university. And that's a group of academics working in a range of different areas. So it's very much a multidisciplinary team. So we have people working in power systems, intelligent manufacturing, robotics and automation. And also in biosensing, so MEMS technology, sensor technology for the building new types of sensors for environmental monitoring and biomedical applications. I'm not going to talk about that, but just to mention these topics. So if people are interested in finding out more about any of these areas we work on at Queen's, if they're interested in collaborating, or feel free to come and talk to me after the session. The second area that I'm responsible for, and it's kind of the primary reason at the conference, is that I'm director for the Centre of Intelligent Autonomous Manufacturing Systems at Queen's University Belfast. So we're actually an academic partner for this conference. And this is a group of academics arranged across the different faculties within the school, or the different schools within the Faculty of Engineering and Physical Sciences. So whereas the previous group was all academics within the one school, this is a group where academics are coming together across a number of different disciplines, so mechanical and aerospace, psychology, computer science, electrical, electronic engineering, and applied maths and statistics. And the reason we've done that is many of the world's challenges that we're facing are not solved by any one discipline. This is solved by multiple disciplines coming together. And this particular centre we formed in 2016 to bring together and encourage academics to work together across these disciplines to address the challenges of realising the vision people have for smart factories of the future, the application of IT technologies and into the manufacturing setting. So it's very much a multidisciplinary challenge. For example, if we have humans and robots interacting, the psychology part is very important to understand how humans perceive and interact with automation. So to get the most effective interaction, we need to sort of take account of and engineer systems taking account of how humans interact with those systems. So that's the sort of centre we've established, and it's been up and running now for a number of years. I've listed here some of the technology areas and expertise that we focus on within our team. Again, we're not going to talk about them today, but I'm happy for these slides to be shared afterwards. So if people find topics there that they're interested in, my email address is on the slides. I'm happy to make connections with colleagues within my teams that work in these areas. Okay, so to moving on then to the topic of my talk. I mean, I've been working in neural networks for quite a long time in artificial intelligence, and as I was preparing for this talk, I was reflecting on the fact that it's effectively 80 years is the journey that AI has to bring it today's sort of hot topic of ChatGPT. It all started out with the neuron model first developed by McCullough and Pitts in 1943. So that was the first mathematical model of a biological neuron. And there have been various milestones along the way. I'm not going to call all these out, but I'll just highlight a few. So from my perspective, and this is not necessarily a complete list of all the milestones, they're a personal perspective on this. So we have the sort of the first neuron in 1943. The first neural network with a learning algorithm was in 1957 to 62 by Rosenblatt, the Rosenblatt perceptron. And then we had sort of the big major breakthrough that sort of led to the first wave of innovation in machine learning was whenever Hewlett, Hinton, and co developed the backpropagation training algorithm to train multi-layer perceptive neural networks. So that was the first neural network that was actually capable of doing useful things. And that kind of was developed just before I started my career. So I studied engineering at Queen's from 88 to 92, and then did my PhD after that. So it was just at the right time. So my PhD and focus on my research was on improving on the backpropagation training algorithm with more advanced algorithms, so it could be trained more quickly and more effectively. So that was kind of led to lots of very, very important and useful applications of neural networks in engineering domain, some of which I will be talking about today. But that wave of innovation then sort of petered out for a while. Until then, we had another major breakthrough then was the deep learning neural network and the deep learning technologies that enable people to work with networks with many more layers. And perhaps the sort of quietly in the background, there were a number of researchers developing LSTMs and convolutional neural networks as the basic topologies. And then others were then working on how to train those networks when they had deeper layers. And the big sort of milestone that people talk about is whenever a deep learning convolution neural network called AlexNet won the image competition, ImageNet, that was set as a challenge for people working in this field. So they won. It was won in 2012 by AlexNet, and it had state-of-the-art performance, far superior to anything had been done before that. And that created a renewed interest and a new wave of innovation in the AI field, which has been over the last decade, really. And people then developed generative AI models that are behind the technologies that were mentioned yesterday in the keynote from John Paul Pereira. For example, the DALL-E 2, which generates automatically generates images based on text descriptions, are some of the outputs of the system, and obviously ChatGPT that we have heard so much about. Other milestones have been around the development of deep reinforcement learning, and again, the big breakthrough there was demonstrated around the use of deep reinforcement learning to learn how to play the game off a game Go. So the DeepMind company developed a solution where they had two versions of the AI playing against itself, and it learned by playing against itself how to play properly to the level that they could beat grandmasters, human grandmasters in that particular game. So that was a huge breakthrough in terms of showing how you could get AI to learn challenging problems. Then there were other developments around this concept of attention, self-attention mechanism that was developed, and those were the technologies behind, or the concept behind, transformers and BERT neural networks, which you've heard mentioned today over the last few days. So all those breakthroughs have accumulated to end up with a system which is now to enable people to develop ChatGPT, which is the current sort of hot topic, shall we say, that's exciting everybody at the moment. So that's the span of the last 80 years. Within that, there have been a number of what's called AI wonders. The one that I've highlighted here is, let me see, have we got a pointer at all? Point of the screen. So we have an AI wonder here. But some people would say that between the late 90s and to the 2010 period was also a bit of an AI wonder. The enthusiasm for it delayed a bit. But the reason for some of these AI wonders was that a lot of people talked up neural networks, talked up AI, and made major promises about what they could do, and they overpromised and exaggerated their capabilities. And then whenever they were found out that they weren't that good, people then lost interest, the funders stopped funding the research and so on. So one of those exaggerated claims in the early days was that the neural networks could predict the future, they could predict anything. So there were a lot of false claims made in those directions. And that's the claim that I'm going to sort of explore a little bit today, based on my own experience over about 20 years of doing research in this area. So before doing that, just because ChatGPT is particularly topical, I thought I would like to make the connection between that and Alan Turing and the Turing test. So Alan Turing is a famous UK scientist, famous initially for being involved in breaking the Enigma code that was needed to crack the code being used by the Germans in World War II. So he was largely responsible for that breakthrough that led to the Western Allies eventually winning that war. But he also was a mathematician and a computer scientist, and he's very much considered as the father of computer science by many people. And also some people see him as the father of machine learning and AI as well. In 1950, he came up with this test that would be able to use to determine if a machine was intelligent or not. And his test was simply a very simple one. If you have a person on a terminal and a computer interacting through the terminal to a human in one room an AI agent on the other room, if the AI agent can fool the person into thinking that they're talking to a human, then he would say that AI agent is intelligent. So that was the test that he postulated in 1950. And it's been a challenge for the AI community since then to try to sort of develop systems that can do that. So essentially, we're talking about chatbots. If chatbots can fool you into thinking that they're a real person, then they're an intelligent system. And the first time that was been done in a way that there's some controversy over it, but in 2014, a chatbot, I think with the nickname Eugene, was developed that convinced 33% of the judges that were evaluating these systems that was a human. So that was deemed to be the first sort of real demonstration of AI systems that could convince you that they were human. And the ChatGPT is essentially the evolution of that process. We now have the state-of-the-art ChatGPT systems, which can be viewed as systems that are effectively answering the challenge of the Turing test and actually surpassing it. And if you remember yesterday's talk, John Paul made the comment that ChatGPT is an extraordinary capability. It even produces bad jokes. And as it happens, I got it to generate a joke for my presentation, and you can see it here. I thought it was relevant to the audience today. You can judge for yourself if you consider it to be a bad joke or a good joke. Okay, so that's a little bit of the context. Like I said, the reason that I introduced that is that in that whole history, there's been a lot of hype. And one of those areas is around whether neural networks can predict the future. I'm not sure that I have the impression that most people in the audience are already a little bit familiar with artificial neural networks, but I put the slide in just in case there are people who are relatively new to the field. So the key thing you need to understand about a neural network is that it's basically ultimately a model that tries to model the structure and learning from experience capabilities of the human brain. And it starts out you start out with a biological neuron, and then you map that onto a mathematical representation of the biological neuron. So you have dendrites that they bring in electrical signals into the nucleus of the neuron. And in a biological neuron, if those electrical signals exceed a certain level, then the neuron fires an electrical pulse down its axon, which then connects to other neurons through the dendrites of other neurons. So the first step is the mathematical model of the neuron. But then to get the power of that system, it's about connecting many of those small mathematical neurons together into a structure. And depending on the neural networks, there are different structures: feed forward, feed back, and you can have different types of layers. So the original neural networks were all similar layers. So multi-layer perceptrons were basically layers of multi-layer neurons with sigmoidal or tangential activation functions. But then more recently, convolutional neural networks, for example, have layers of different types. And that was again reflecting work done by Jan LeCun and others on the modeling of how the eye does image processing to recognize and classify patterns in images. So looking at the sort of specialized structure of neurons related to the eye and vision, they arrived at the CNN as a structure, and clearly that has proven to be a very powerful topology. Okay, so what can networks of that type predict? Well, can we predict the roll of a dice? Or can we predict the lottery numbers? And certainly in my early days, when I was working in neural networks, I naively tried to train a neural network to predict our lottery, more in hope than in expectation. The reality is of these systems, if they're truly random, then it's not possible to predict them. So the only way you could predict these things is if there was some bias in the system that there's not supposed to be there. So if you trust the system to be truly random, then there is no pattern in that data, and therefore it's not possible to predict those things. What about sports? So I believe these are quite popular sports in India, the cricket and hockey. But people have tried to predict the outcome of sporting matches. Betting and all those areas it's a big issue. But the reality is that there's a combination of predictable patterns and then random patterns in these sort of activities. So generally speaking, teams that are are in form or good teams will generally beat the weaker team. So you can have an expectation there's more likely a certain team will win over another team. But randomly, the weaker teams can often beat the better teams. So there's a combination of information that maybe that's predictable, and then also random aspects that are not predictable. So that's the reality in all these things. There's essentially, we need to consider the world as being a combination of random and deterministic characteristics. And the kind of framework for dealing with that randomness is to rather than ignore it, to model that uncertainty, to work with the probability distributions and propagate the uncertainty through your models to get the most accurate prediction. So you maximize the likelihood given the uncertainty and all the information that you're using to make your decision. So there's a lot of work done in that area. I'm not plan to talk about that sort of stuff in detail today, but just to make you aware that there's a structured way we're dealing uncertainty and a mathematical framework, Bayesian frameworks and so on that allow you to do that in an effective way. Okay, so before we go into some examples then of how neural networks can predict the future, in my experience, I thought I would just formulate the sort of the forecasting problem. Ultimately, when I talk about predicting the future, basically the term is forecasting. One formulation of the problem is to assume that we have a dynamical system with internal states and some inputs, and that based on the inputs and the internal states of the system, then it produces a particular output at a given point in time. In terms of the inputs, we can what I've defined as deterministic inputs. These are ones that we decide what they are, and therefore we know them exactly and can control them. There's also stochastic inputs that we can measure. For example, if it's based on the temperature or the one speed, then we can measure those and we know them precisely, but we don't control them. We have and they're generally randomly generated, so we probably might be able to predict them. We don't know them precisely. So those are the two types of inputs. And then there's a third type of input that we don't want to talk about too much, is that there are also then things that impact the output that we cannot measure or cannot observe. So we define those as disturbances. So that's the sort of the real world model. And then the prediction or forecasting problem is we would like to know the future values of that system, given the information we know up to this point in time. And I'm assuming we're doing a sample system here, so this is discrete time. So at future samples, what are the values of that system? If we can determine that or predict that, then we're basically predicting the future. So that's how I define predicting the future. It's a forecasting problem. And it's a very well understood problem, and a lot of research done in a number of different domains. The two primary ones is in the area of time series forecasting. There's a lot of models have been developed and a lot of techniques for forecasting the future of time series. And then the other area then is coming more from the control community and is the area of system identification. And the goal here is to build a model by looking at the input-output relationships that exist in a system, to identify the model that allows you to explain those patterns. And once you have the model, then you can predict the future. So the goals are slightly different. And one of them is about actually doing predictions, and the other is about building the model of the underlying system that's producing those predictions. But essentially, they used much the same models and techniques. And I have three examples here. I'm not going to go into the details, but just to give you a flavor of the structure of those sort of models. So the kind of the starting point would be, well, if I have a signal over time, can I predict the future values of that signal based on what it's done in the past? Then that's known as an autoregressive type model, where you're autoregressing on past values of the signal you're trying to predict. A step up from that then is to realize that many systems, the output depends not just on itself, but on some other input signals or external signals or exogenous signals. So then we have a model type known as an ARX model that then takes account the inputs and the past values of the signal itself to make a prediction. And there are many other types. The other one I mentioned then is ARMA, which is known as an autoregressive moving average. And now the extra term in this is the moving average of the previous errors in the prediction. So you look at how the errors are changing over time and use that to improve your prediction. So that's the ARMA concept, and there are many others, different structures. I have a link there. There's a kind of a high-level introduction to them if people are interested in finding out a little bit more. But basically, that's the topology. And I'm arguing that topology, if you're able to produce predictions of the future values, that you're actually predicting the future. And the F function here can be linear. They're linear models, but the more powerful models you get when you use neural networks to do the non-linear mappings. So in many of the applications, basically the F is implemented with a neural network. And in that context, I'm arguing that a neural network can predict the future. So let's look at a few real world examples now that I've worked on over the last 20 years. So this is one of the early day examples. And the challenge here is that we have a practical application which involves controlling the viscosity of a chemical that's been produced. And the chemical actually is a local company that produces Lycra, which is the stretchy material that's in tracksuit bottoms. That's a very fine thread, and it's basically it's very critical that the viscosity of the chemical is just that's produced, or the polymer is just right to get the thread to form. Otherwise, if it's too thick, it doesn't work, and if it's too thin, it basically breaks and basically flows like water. And the way you measure viscosity now we're not, when we say the old days, we're talking 1990s, that sort of time, was that a technician would take a sample of the polymer, run to the laboratory, do tests, and come back with the answer 30 minutes later on what the viscosity was. If it was too high, then you reduced the amount you would stir the tank, because the stirring basically affected how viscous the chemical was, or the polymer. And then if it was too runny, then you would increase the stirrer. So the problem was that there's a 30-minute delay there between actual what's happening and getting an answer on. So those of you who've studied a little bit of control, the delay is a major problem in achieving stable control of systems. So what we did is we worked with the company on a project to develop what's called a soft sensor to predict the value of viscosity instantaneously based on the current measurements of the process. And the key idea here was to recognize the fact that the stirring of the tank, if the chemical is very sticky, then it's much more difficult to stir it. So it requires more torque from the motor. And if it's runny, it's much easier to stir. So you had to stir it at a constant speed, and more current or more torque was required of the motor if it was more viscous. So there was a direct relationship between viscosity and the effort required by the motor to stir the tank. So we built a model then basically based on those values of current and torque from the motor and also the motor speed, and build a relationship between that the neural network trained from data to predict what the viscosity was for that system. So by using historical data of the lab measurements and measurements of the motor speed and the motor torque, which is inferred from the current, we were able to build a neural network model to predict viscosity very accurately, and allowed us basically to essentially predict 30 minutes into the future compared to what was done previously. So that's the first application in neural networks, and I'm arguing that that's an example of it predicting the future, because in the old world, there was a 30-minute delay in giving this measurement, and with the neural network, we were able to eliminate that delay. The second example is a similar sort of idea. It's this idea of a soft sensor, but this was work I did with a semiconductor manufacturing companies more recently. And in their world, they call it virtual metrology rather than soft sensing. And the idea here is to you have a process which is called a plasma etching process that etches away the surface of a wafer. And the bit that they're interested in is how deep the trench is performed after that plasma etching process. But to measure that trench, you use a piece of equipment called a scanning electron microscope, which is very, very expensive. So it's typically they only have a small number of them on a manufacturing site, and many processes need to use them. And typically you measure this step after a number of other processes. So it wasn't uncommon, and still isn't uncommon in a manufacturing environment, that the trench of the depth produced by the process would not be determined until several hours later, and sometimes days later, because of the backlog of using that machine, which created a huge delay in controlling the performance of the process. And the other thing they did was, because there's such a demand for that particular machine, they would typically only measure maybe one wafer in every 25. So there'll be 24 wafers they wouldn't take a measurement from. They just sample the product. So what we did for them was we demonstrated that by using a special sensor that added to the system, we could monitor the light emitted by the plasma that's used to etch the process. And one of the interesting things about plasma is the light produced by the plasma is a function of the chemistry of the plasma. So if those of you are not familiar with plasmas, you heard of the Northern Lights or the Aurora Borealis, and there was on the news quite recently that there were very spectacular Northern Lights in the last few weeks in the UK in particular. But those lights, they glow red and green because of the composition of the atmosphere, nitrogen and oxygen. And it's the same principle used to basically monitor the chemistry of the plasma in an etching process. And what we did is we built a model then that, based on the spectrum produced by the plasma, predict what the resulting trench depth was from that process. So the history of the plasma chemistry variation over the process cycle was able to allow us to predict what the trench depth was quite accurately. And that then again allowed us to get an instantaneous estimate of what happened at the end of the process, rather than to wait hours and days. And in addition to that, we were able to get it for every single wafer rather than only just a sample. So that's what I'm trying to depict here in the graph. If you're monitoring the process, in the past, we just had the blue dots, which would be delayed measurements, whereas now we have instantaneous measurements at every sample, and we can actively update the process and do run-to-run control of the process in real time, rather than maybe making adjustments once a day or once every second or third day. So great improvement in the quality of the production process as a consequence of this. Okay, okay, so I'm going to skip over that example. I think I might have sent the wrong version of the slides. I deleted this slide. So moving on just to a slightly different example. So this is again work we did with a company looking at, they manufacture plastic parts by using extrusion processes. And they do parts, for example, like the molds, the plastic molding in the mirrors for cars, or the plastic used in ink cartridges and printers. So those are the sort of products they would produce. And they manufacture and bid for business with lots of different companies to produce plastic parts. And they would produce maybe 400, 500 different types of parts a year. The challenge they had was that they had to bid for business, and they would often say bid for 20 different products and get one of them. And the big key factor in bidding for business was how much time it would take to manufacture the process. So when you're doing a plastic part, you melt the plastic, you inject it into a mold, then it cools, and once it's cold, solidified enough, then you can pull the mold apart and extract the part. So how long it would take to cool was a key determining factor on how quickly you could cycle the process. So if something took 10 seconds versus a minute, then that's 6 times the production. So you need to know how many machines you need to invest in and how much you should charge for your product to meet the demand of the customer. So if your cycle time is wrong, you could be overcharging for your business and lose the business, or end up making a loss. But the difficulty is to accurately estimate that cycle time required a lot of expensive design and expertise using mold flow analysis and so on. And as SMEs, but this was an SME, they didn't have the financial ability to basically employ somebody that's a dedicated expert in that area. So what they did was back of the envelope calculations from their process engineer based on previous products. This is similar to this product in the past. I think it's the rough back of the envelope calculations make an estimate. So we said, that's a human process can be automated in an AI system. So what we did is we developed an AI model. We did 2 things. We looked at a number of standard measures you could basically quickly read off a design diagram, things like the thinnest part of the product, the longest distance to travel from the source of the melted material to the furthest way point in the product, the type of material that was being used, and so on. So we had a candidate set of variables, and then we identified a subset of those, and then a neural network model to make a prediction of the cycle time. And the graph that I'm showing here is an example of the results we got on test data. So again, when you're using neural networks, you train it on training data, and then to evaluate its performance in the real world, you keep a separate set of data that you don't use for anything other than just evaluate its performance. So what I'm showing you here is an example of, I think it was about 80 products that we kept just for testing. And I've ordered the performance from the small, with the neural network performance is in red. So the one on the left is the best performing prediction product, and the one on the right is the worst performing for our particular model. And then the blue is the performance of the actual system the company was using, which is the back of the envelope calculation based method. And you can see that our system was substantially better across the board. Or sometimes they were lucky and did better than our model, but on average, we were looking at a relative error to reality of about 8% compared to over 20% with the back of the envelope calculation. Now you can say, where's predicting the future here? Well, the argument I'm making here is that we're predicting the cycle time of a product before they actually even make the machine to actually create the product. So you're probably talking maybe a 6 months or a year ahead prediction of what the reality is going to be. So I'm arguing that's an example of us predicting the future with a neural network. That's quite a long time scale prediction. Okay, final 2 examples. These are probably much more believable and more directly forecasting. So the first one is electrical load forecasting. And this is something that all power system operators across the world have to do. Whenever you're producing power, you need to generate the amount of power that is needed for every instant in time. So you need to have a precise match between the load being consumed and the power generated. And in order to make sure you can generate that power, you need to have a prediction of what's required ahead of time. And depending on the scale, you can have long-term, short-term. So we were looking at this example project for Northern Ireland at short-term load forecasting, which is the period of 24 hours to 48 hours into the future. The challenge that the system operator in Northern Ireland was having was that their old forecasting models were starting to deteriorate over the last 20 years. And the main reason for that was a complete change in characteristic of the power system with loss of renewable generation, solar power, and one power in particular in Northern Ireland. And it's not the large scale stuff, because the large scale stuff they measure the output of and are able to predict. But there are many incentives to encourage people to put small turbines or solar panels on their roofs, and that would reduce their electricity demand. So the way the power system operator would see the impact was that all of a sudden on a sunny day there'd be a lot less demand for electricity from a particular area because it was sunny in that area, but they couldn't predict that ahead of time and therefore couldn't plan for it. So their forecasting models were deteriorating. So we did a lot of work using machine learning tools. We tried a whole host of different models, including deep learning models. And this particular piece of work that's referenced in this thesis, what we did in the end was combine the best performing models of each class using what's a technique known as ensemble modeling. And the idea in ensemble modeling is that you can often get much better predictions by combining the prediction of a number of diverse models. So if you build models of different type, they all can do better in different areas of the prediction. And if you combine them in the right way, you can generally do better by an averaging of their predictions or some other combination of the predictions. And we used a neural network to learn the best combinations. And the example I'm quoted there, the best performing individual model was a CNN deep neural network for our problem and achieved an error of about 3% in terms of mean absolute percentage error in terms of prediction. whereas the best ensemble model achieved a reduction to 2.6%. So it's not, the percentage are changes don't sound like much, but when you're talking about hundreds of thousands of pounds in terms of electricity, because we're talking megawatts here in terms of output. So again, this is an example of real world. This is genuinely predicting the future. You're predicting what the electricity demand will be for 24 hours to 48 hours into the future. And one caveat here is that this model is based also on other predictions. In other words, it relies on a forecasting of the future weather conditions. So somebody else is doing a forecast of the weather for us. So we rely on the predicted temperature and wind speed over that time period into the future. And generally speaking, weather forecasting over a few days can be quite accurate. Once you go past 2 or 3 days, because of the chaotic nature of those systems, it's much less predictable. But certainly over the short horizon, things like temperature and wind speed tend to be relatively easy to predict. Okay, final example. And this is hot off the press. This is my PhD student's work who passed his Viva exactly 1 week ago. He was in the hot seat this time last week being evaluated for his PhD. And his work was on human-robot collaboration and looking at how to improve the interaction between human and robots. And at the heart of the systems he was developing was the idea of when two humans interact, we can read the various visual cues, not just the task being done, but we can sort of anticipate the emotion of the human or what they're about to do because they're, eye gaze and various things like that. So in our work, in fact, I have an ongoing PhD student working in this area as well. What we try to do is build models that anticipate and predict what the human's going to do into the future. Now, the time horizons we're talking about is 1 second. So what the work that Dan Ho did in his PhD was 1 second into the past, track the human motion, and then using that 1 second of history, predict what the next 1 second of motion would be. And using that predicted motion, we feed that into new types of control structures that can take advantage of that predictive information to get better quality interaction between the human and the robot. So the system, basically, I'm not going to go into the details. I have a reference to the paper on this work. Basically, what we did was we used motion capture systems in this work to capture the skeleton outline of the human. There are 23 joints in the human body. So you track those joints using motion trackers in this system. In my current PhD work, we're actually using a non-invasive method. So we're basically using direct images. And Google have developed a model using deep neural networks called a media pipe that allows you from just direct video images to map the skeleton points in the body and track them over time. So you can, in this original work, we had to wear a motion capture suit to get the data, but we can now replace that with basically just basically video monitoring of an individual. So we track those skeleton points over time, over 1 second. And then we've used deep neural network architectures, and there's a combination of various LSTMs to look at the relationships over time in the motion. And then we use graph convolutional networks because the joints are all connected together. There's a graph type structure there. So the natural thing to use then is a graph convolutional network structure. And then within that, we also then use this attention mechanism. I hinted at earlier on, because different parts of the body, the joints here relate to the joints here. So you have to pay attention to different joint combinations at different times to get the best outcome. So by combining the attention mechanism, we were able to get the focus on different joint combinations, both in time and spatially as appropriate. And we found that actually improved the performance of our system. So that was basically where we did it with the neural networks. And this is a sort of representation. It's not very clear, but hopefully you get the sense. The color lines, sorry, I don't know if it's shown very clearly there, but the color lines is on the top is a baseline system that we were comparing our work with. The black dotted lines are the reality, and every so often you can see the black dashed line appearing. That's when there's a divergence between the predictions and reality. And hopefully you'll get a sense up there that our predictions were substantially better than the baseline models that we're comparing with, and it was state-of-the-art performance in terms of that type of problem against. There's a number of benchmark data sets that have been out there that we were able to test our system against. And if you're interested in that work, it was published in 2021 in IRIS. And shortly, the thesis that the student will be made available online. The source for the previous work will also be the source for the thesis once it's finally submitted. So the normal process of Queen's is you pass the Viva, you typically have some minor corrections to do, and maybe 2 months later, then the final thesis is submitted. So hopefully by the end of the summer, this work will be available for anybody who's interested in reading about it, and particularly around the control architectures to go with it. Okay, so just to wrap up as a final slide, I thought I would give ChatGPT an opportunity to answer the question I asked: can neural network predict the future? And the answer is that ChatGPT is there. I'll leave it for you to read it for yourselves. But basically, the summary is it kind of depends how you interpret the future. you can basically, after deterministic patterns in the data, then yes, you can develop models that can predict that information, but it only can predict things that are predictable. It cannot predict random events. So there's no point trying to predict the lottery unless somebody is trying to cheat on the lottery and modify the system to generate random numbers. Then they're generally random processes, and you can't predict those. And the other key thing is that quality of your models is down to the quality of the data. If you have bad data and you get bad results out, if you have biased data in, so if you focus on the biased view of the world in terms of your data, then you'll get a biased model as well. So it's a very important aspect of neural networks these days in AI, particularly the whole area of ethics, because you can, if you don't train them properly, you get biased neural networks, just the same as you get biased humans. You could also bias networks. So it's a very important thing to take away from maybe from my talk today. Is the most important thing for you heading to the future is that you need to be very cognizant of the ethical issues that surrounding the technologies that you're using, and be very careful that you don't sort of accidentally end up creating systems that are have the same flaws as humans have, shall we say. And just as a final takeaway note, I note here, this is work done by a blogger. They asked the questions from people to interpret what they meant by different words like sort of rarely happens or highly likely, and put a probability measure on it. And the takeaway message from this is that humans have a very broad range of interpretations of what uncertainty is. So while some humans are very good at predicting the future and making good decisions on uncertainty, many people are not. So in reality, if we train a good neural network system with the proper methods, it's all generally will always be more reliable and more trustworthy than humans making decisions going forward. So there's no question AIs will compete with humans in many different areas. The most obvious one at the moment is in the medical diagnosis. They've already shown in many areas that an AI system can often be more reliable than a human specialist in diagnosing cancers and tumors and images and many other areas. And the same will be true going forward. Okay, thank you for your attention.
Thank you very much, sir, for introducing us such a complex topic with such a great simplicity. And I hope all these insights will help our students and audience to work further and explore the area. Now we are open for some of the questions. So those who want to, ask questions, they can proceed.
Good morning, sir. Actually, I have one question that you talked about neural networks. So I just wanted to know what are some real life applications in the neural network, and how can they be related to decision intelligence? Like, and what are their effectiveness in the real world?
Well, the applications that I gave there were all really about enhancing the quality of the data. So if you take the soft sensing applications, the earlier examples, ultimately they were used to provide higher quality data to the decision-making systems. So in a sense, it's a key part of the decision-making is having good quality data. So in the case of the viscosity measure, you're getting an instantaneous high quality measure of what was actually happening. So you're using the machine learning tools to enhance the quality of the information that you have to make decisions. Then on top of that, then you can build solutions that are based on that. And again, AI tools are increasingly being looked at for handling those complex data sets. I don't work directly on that aspect of it. I tend to be using the machine learning tools for enhancing the quality of the information extracted from systems. But once you have high quality information, the decision making becomes much easier. Tools then like reinforcement learning are the ways to self-optimize the system over time. So, the layer on top of the work what I would be doing would be to add a reinforcement learning layer to help to learn the optimal decision making on it. And in fact, the current page station I have working on human robot interaction, the final part of their page is exactly that. If you have enhanced information about what the human is going to do, how should the robot respond to achieve optimal interaction? And one good framework for doing that is the framework of reinforcement learning. But in terms of real world applications, I mean, arguably, the example of learn and play Go. I mean, that's decision making at the highest level. Path planning in robots is the kind of application that we're most actively involved in, and some of my colleagues are working in this area as well. So, optimal decision making for the robot when interacting with a human. Now, it's very critical in a human robot interaction that the robot remain safe. So there's a lot of constraints around how you do that, and you get machine learning are very good tools to factor in those complex constraints. So I think that's probably the best example I can give at the moment from my own experience.
Thank you, sir.
Good morning, sir. Thank you for the wonderful and informative presentation. That was really great. Actually, at last, in the conclusion, you said about that AI can be biased also. So I just want to ask that if we are training a AI, then how can we make sure that it won't be biased? It will give us a accurate, means a non-biased result.
Yeah. Well, but because neural networks are based on the data you use to train it, so the responsibility is on the designer to make sure that they provided with an unbiased data set. So at the very simple, I mean, it's not biased in the sense of human bias, but it's a standard type of bias in neural networks for classification is that you typically might have a very large number of examples of one class and a very small number of sample of a second class. So I mean, you might have, say, 4 or 5 classes and you're categorizing different objects. And if you only give it 2 or 3 examples of a particular class, if you just train it in the normal way, it'll essentially ignore that class because say that's not important. I have 80 examples of this class, I have 2 examples of this class. I can get, if I just predict everything as the 80, I'll have a very high accuracy at the expense of just 1 or 2 examples. And that's a common challenge, is this unbalanced data sets lead to biased classifiers. And the same happens if you're doing face recognition in humans or classifying humans. If you just train it in all one ethnicity or one sex or whatever, or an unfair distribution among those, based on just the data you have available to you locally. And it's not, this is not done intentionally. I mean, just the reality is if you're doing it in a particular lab, you will make available, you'll use the resources available to you locally, but then that model will certainly not work very well if you go to another country where the facial features and so on are different. Then you're going to get a bias in that. And the same with audio systems. In the early days of speech recognition, you know, systems couldn't handle many different accents because it was trained on one class. And unfortunately, in the early days of AI, it was, you know, white males, middle-class white males, in terms of that kind of demographic, were particularly in the US, were behind a lot of the early work in AI. So those systems in the very early days were very biased in terms of their abilities, and they could only do things that were relevant in that context. So it's not that people deliberately go out to make them biased, but just through not careful design of the data sets, the systems can only learn what you give them. So you give them biased data, they will produce biased output. So the answer to that problem is very simple. Make sure that you have given a lot of thought and consideration of how you generated the data to train your models. If you do that, then the neural network will naturally do the right thing. But the responsibility is on the designer to make sure the quality of the data is appropriate and that the data doesn't have any inherent biases, and it just by not being taken due consideration about the application. If the application is only for your local region, then that's not a problem. But if you want it to be general and be applicable across a number of different contexts, then that has to be reflected in the data set.
Okay, thank you, sir. Thank you so much.
Hello, sir.
Yeah.
So AI right now is working mostly on a pattern-based approach, right? Given bias. So in future, are we going to have a completely self-aware AI?
That's a difficult question to answer. Certainly, I mean, there's a need to make AI more and more self-aware to actually make it useful, because the big bottleneck in most of AI applications at the moment is the training and the generation of data sets, labeled data sets, and supervised learning. So unsupervised learning is a big area of research, because that then automates a lot of the learning for AI. So if you can achieve that, then there's a potential for AI to become sort of self-aware. So if it recognizes a gap in its knowledge, it'll try to find and learn the information for itself. So that certainly is an area of research. And I don't know much about that area. It's not an area I work in myself, but from my own perspective, I think it's needed because it's a barrier to the growth of AI at the moment. The human effort required, if you take ChatGPT, the resources required to achieve that are huge. Not just the energy resources, but just the human resources. I mean, there's human in the loop and training and getting those systems up to the level that they're at, because at the moment AI systems can be kind of trusted to learn the right information, and they can get biased very quickly, and partly because they learn from data that's flawed. So human auditors basically monitor what goes on and correct errors in the training. So later on in the future evolutions of these tools, the more they can automate that learning process for themselves, the more they'll become self-aware, because ultimately that's the awareness of your own weaknesses and trying to address those is a big factor of human improvement. And it'll be the same for AI systems. There's that ability to recognize when they're not performing well and to take actions to address that. And that might be, for example, do the current AI systems, ChatGPT, I think one person described it as they're effectively like a well-educated humanities professor. They have a knowledge of language and learn from the language models and the information that's in language patterns. But to become a scientist, you have to conduct experiments to validate your hypothesis and stuff. So for an AI, are able to sort of interrogate and analyze data. So they have the core capabilities already there in terms of analyzing images and so on. But being able to do that to enhance his learning of other concepts, so linking hypothesis to experiments and then verifying and updating their hypothesis accordingly. That's the next wave of innovation. My sense is that that'll happen in the next 10 years because that people are already working on that. And I think that then will be much closer then to self-aware systems when we achieve that.
Thank you, sir.
Thank you so much, sir, for answering the questions from the students. Now I request Professor Dr. K.M. Soni, sir, to please present a memento to Professor Dr. McLooney as a token of appreciation.
Yeah.
Thank you very much, sir. I now take the opportunity to introduce our next eminent speaker for today, Mr. Nikhil Arora, Director, Data Intelligence, S&P Global. Mr. Nikhil Arora has more than 17 years of experience in delivering solutions, products, and services in banking, financial services, and insurance domain for Bank of America, Barclays Bank, and Royal Bank of Scotland. Currently heading the operational data intelligence team in S&P Global's Market Intelligence Division, where they source, slice, and dice data to build smart analytics and provide actionable insights into the data. Prior to S&P Global, he was Global Head of Change Management in Financial Services Division in RBS, where he was taking care of release and environment management for approximately 500 products. I now invite you, sir.
Good morning, everyone. Hi. So, thanks to Dr. K.M. Soni for inviting me for the session today. And I thank Dr. Natasha for getting me here. Thank you so much. And yeah, I would, why I'm standing here is because of my distinguished professors who have taught me in my Galgotias University, Galgotias College, Dr. K.M. Soni, Dr. Vivek, and Dr. J.K. Rai. So thank you, sir. So yeah, I mean, just to, I know that many of you are on your mobiles, but yeah, just for next 30 minutes, if you can just lay stress on whatever I'm talking, I'm pretty sure it is going to help you in the future. So what comes to your mind when it is, when somebody tells you data intelligence? Anyone in the room? What exactly is data intelligence? Okay, let's take a step back. What exactly is a data? What exactly is a data? Okay, information. Yeah, someone else at the back. Facts and figures. Okay, information, facts and your classes, you give attendance, that is also data. Uh, what your professors are teaching you, that is also a data. And it's in the intelligence language, you may call it as a structured data or an unstructured data, right? So that's the theme. We'll just talk about data, how data can provide you insights, what it can do for you, what it can do for your management teams, what it can do for various audiences. Okay, so before I proceed, that's about me. Nikhil Arora, Director Data Intelligence for S&P Global. So yeah, I've been doing data intelligence for quite a while. But yeah, as far as profession is concerned, yeah, that is for me a sort of a secondary thing. But yes, the primary thing is my love for the sport, which is cricket. So that's my first and the last love, which is cricket. So I just want to let you know that never lose your passion. Be passionate about whatever you are doing. So yeah, I'm an avid cricketer. I still I'm playing cricket. So yeah, just follow your passion. However you want to do it, that's up to you. And yeah, I've run marathons for about 7-8 times, 21 kilometers every time. So Airtel Marathon, Vedanta Marathon. So yeah, just to talk about a bit of my journey. So yeah, 2001 was when I sort of started my engineering career. So specifically, I put the building photo on your left that you see is the Galgotias College. So the moment you enter into the college, you see that yeah, कि ये college की building है. How will I study? But yeah, coming from there to what Galgotia is right now and why I'm standing here, I think speaks for itself that these things are all secondary. I think the onus lies on you and your professors, what information they are passing, what education they are passing on to you. Okay, yeah, my professional career started. So yeah, I'm an electronics and instrumentation engineer. People may be wondering, electronics and instrumentation, say how I sort of shifted into the IT field. Simple and straightforward answer, I was not getting any jobs in electronics. But that doesn't mean that, yes, people who are from electronics and instrumentation or electronics and communication will not get jobs today. Aisa kuch nahi hai. So yeah, you will definitely get a job. It's about the right time and taking right decisions. So yeah, 2005 is when I started my professional career with one of the major IT giants, Infosys. Everybody wants to work for Infosys just to get the kind of exposure. And yeah, I was there doing application development and support for Bank of America. Yeah, one of the sort of companies where I literally was slaughtered to work about 16-17 hours in a day. So, I mean, this is the kind of sort of dedication and commitment that you need in your early careers, so as to get fruits in your later career. So yeah, Barclays, RBS were sort of setting stones for my career. That is, they provided me the right platform to look into release change and environment management. I'll not talk about what release change and environment management is. You may get bored about it, but yeah, from 2017 is when I started doing data intelligence. So it is about 5.5, 6 years that I've been doing data intelligence. And it has changed my sort of perception about the data, about how people perceive an information that you see on a newspaper, that you see anywhere. There are so many research papers that are being published these days on data, on intelligence, on analytics. So yeah, that's my true love right now, which is data intelligence. Okay, moving forward, as I was just talking about, someone told me that, okay, what is data intelligence? What is data? So let me just talk about data intelligence. What exactly is data intelligence? It's basically collection and analysis. So I've sort of highlighted few keywords in my presentation so that it registers in your mind. Collection and analysis. Anyone can talk about what is collection of the data? Anyone? Anyone in the room? What is data collection? Anyone? Just don't hesitate. Just speak for it. Anything. Yeah, just be a bit louder. Okay. Yeah. So that means different sources of data. Okay. Anyone else? What is collection? Yeah. Okay, fine. Okay, moving on. What is analysis? Why do we do analysis? For what? Anyone? Understanding the data. Okay. What do you want to understand out of the data? I'll give you a small example. Okay, let's talk about the websites that you are hitting. You are getting a data that, okay, these were the page load times or whatever it is. So what is it that you will analyze in that? Yeah. Good, very good. Yeah. Sorry. Very good. Yeah.
So basically, we get all types of data sources we do analyze so that we can separate where we can use that data. How do you use it?
Yeah. Thank you for the great answers. I think you all are aware about what collection is, what analysis is. So why we do collection and analysis is we want to provide a sort of a background about what it is in the data, right? So if you want to give a sort of a point, there are two types of data when you're talking about when you're doing analysis, which is a sort of a historical information and point in time information. Historical information is something which has happened in the past. Point in time is something which is there in the present. What is it right now? And something which is a sort of a hindsight or a sort of a foresight. It is you are doing a prediction of the data, right? So yeah, what exactly is data intelligence? It is more about collection and analysis, presentation and aggregation, uncovering the hidden facts. As somebody was telling me that, okay, when you are given a website data, you want to cover the hidden facts about a website's sort of usage, technology, number of hits, or be it the advertising analytics that you would want to do. And obviously you want to extract value and relevance from the data, and how we can bring it back, a sort of a loop back kind of a thing, which is how we can bring in innovation strategies into our process to improve the data and to improve the analytics. Fine. So just to talk about what are the basic 5 main components of data intelligence. It's your data sources, the collection and storage, the analysis, the visualization, and obviously the last is making decisions. So that's the theme of my presentation. That is how data intelligence can be used for better decision making. Now, just a very basic architecture as to how data intelligence is done, right? So if you see right at the top, the funnel, different sources, as one of my friends was talking about, that, okay, you want to collect the data, you want to connect to different sources. So this is how the data intelligence is happening. Sorry, did I miss something? Okay, fine. So connecting to different data sources, right? And what happens is when you are connecting to different data sources, you want to load that data somewhere, right? And if you want to load that data, obviously either you can have so in today's world, what we call it as a sort of a database that you need, and it is all cloud-based, right? So cloud-based, it can be a sort of a AWS, you've got a relational database system that is there, or you can have a file storage. You can store files into, I don't know whether you know this terminology of AWS, which is S3, or you can have AWS, or you can use Azure containers to store the data in blobs. Blobs, I'm pretty sure you would be knowing, it's the large object data that you can store into your containers, right? So that's the second layer, which is the storing of the data. And then what you want to do is transform that data. I mean, previously we used to talk about ETL, which is extract, transform, and load. But nowadays we are talking about extract, load, and transform, which is ELT, right? So you can do transform in the earlier stage. Now you can do transform once you have stored the data, and then you want to do the aggregation and presentation. So, and finally is the presentation layer. So here I'm using an example of Power BI because that's my bread and butter these days. I'm using it to do the visualizations, and my team is also doing the visualizations. But yeah, that's how you consume the information. That's where you will find out what the data holds and what are the kinds of decisions that I need to make, and what do I need to do right at the start to connect to different data sources now. I mean, you may say that, okay, you have found an anomaly in the presentation layer, which is your Power BI, and you want to connect to another data source. So what you will do is just loop it back as a sort of a feedback, and you connect to a different data source, and then you do the analytics. So that's how this whole loop works. Okay. Just don't lay stress on the right-hand side architecture. That's my kind of architecture. But yeah, that's how this is what is the scale of the data is. You may see about 8-9 sources, but there can be about million sources right at the top. So I've just tried to explain it in a very so just to relate it with the previous slide. So obviously your funneling part, which is sourcing data, right at the top, you see these are the different sources. The storage part of it is done via when you want to source the data. So if you see those orange icons right in the middle, that is the Lambda functions that have been written. AWS Lambda, you should be aware, it's something which will be talked about once you enter into the corporate world. Everybody will be talking about writing AWS functions, and those functions are the Lambda functions that are written, and it can be your Python code, or it can be your Java code, or anything. But yeah, those, and it has got various sort of advantages that everything is running on the cloud. You don't have to run it on a hardware machine, be it your laptop or be it somewhere in the data center. The next layer that we are seeing is a transform layer, where we are transforming the data in the database. You may be writing different, so you may be knowing about views in the database, the table storage, or it may be files, unstructured files, structured files, aggregated information. So you do that in your sort of transform layer. And final layer is obviously the presentation layer, which is the Power BI. Any questions, anyone, till now, before I proceed? Anyone has any questions, anything? Sorry? Yeah. Extract, load, and transform. So these are three terminologies. Extraction is sourcing the data from your different sources. Loading the data is storing the data into your storage devices. And transformation is running your sort of codes on the data to transform it. So you may have, say, for example, 1 million rows on a sort of a website, which is you have got a traffic, too much of traffic that is coming in, right? And you want to see an aggregated information that, okay, what is it that is coming from Delhi? What is it that is coming from Pune? What is coming from Bangalore? Or what is coming from Mumbai? So you aggregate that particular information and look at the hotspots, which city in my country is giving the maximum traffic. And based on that, you can sort of enable your decision making based on those cities. Does that answer your question? Anyone else? Any question? No. Fine. Now I think we are just I've tried to keep it very simple. That okay, how can data intelligence drive decision making? Is when you have different types of analytics, right? Now the analytics are of 4 types. One is descriptive analytics. One is diagnostic analysis. So descriptive and diagnostic is something which is descriptive, says what happened. What happened? I mean, you want to find the cause of that data, right? You want to find the cause of the anomaly. So you will say that, okay, I'm doing a sort of a historical kind of an information that, okay, what has happened in my system in the past? Say, for example, you want to find a CPU utilization over a month into a report. So what you will do is you will connect to the CPU history logs and get that data. So what exactly happened? Were we seeing any sort of peaks in the CPU, or were we seeing anything that was sort of which we can correlate to? So that is mostly like a sort of a descriptive analytics. Now, diagnostic analysis is when you start doing some sort of correlation of the data, that what happened you have already noted down, but why did it happen, right? So CPU utilization maybe because that too many users were concurrently logging into the system, or you may be sort of downloading or uploading too much onto that. And what happens is you get to know that, okay, because of this particular reason, I faced this issue, right? Now, these two, I mean, what happened and why did it happen, or diagnostic and descriptive, are basically your historical information or the present information, what you are seeing. But based on your historical information, whatever the data that you have captured, whether you can do a prediction on that data that, okay, I may see a CPU utilization going up in next 2 hours, and I need to take some sort of steps to ensure that I don't see that CPU utilization to go up till 90%. How can I stop that? So that is basically predictive analytics. Everyone with me? I mean, is everyone clear about it? What is the basic difference between, so as one is hindsight data and the other is the foresight data. And the last one is the prescriptive analytics. That is, prescription is like, so when you go to a doctor, aap apni problem batate ho and he gives you some sort of medicine and prescription. So this is what somebody will give you as part of the data, that, okay, I am seeing a CPU utilization, or my CPU utilization in next 2 hours is going to go 90%. Now you are going to do a prescriptive analytics and say that, okay, there are about 5 hotspots that we are seeing in your CPUs. Now you can reduce it down to, so that you don't see the CPU utilization to go up by 90% in next 2 hours. Right? Everyone with me? Okay. So yeah, that's the different analytics that we do or we should be doing to provide a sort of a hindsight data and foresight data. Okay, some basic principles. So which is very close to my heart. I mean, knowing your audience. I have been laying a lot of stress to wherever I go and talk about data, is you should know your audience, for whom you are preparing the data for, or for whom you are providing the insights for. Until and unless you don't know your audience will not be able to relate to what you are trying to showcase, what you are trying to do an analytics, or what you are trying to provide an insights on. The other is, yeah, I know that, yes, you all may be sort of going through a lot of textbooks. And what happens is when in a textbook you see a picture that registers in your mind, rather than the text, sometimes it's the image that gets registered. So it's the impactful visuals which can present a story. That is what we should be sort of laying stress on. And how you can bring comparisons between the data. Correlation is something like you are tying one data with the other data and seeing, okay, why my CPU went up. It was because of certain users hitting too much on a particular server. And why we do sort of data insights is to provide what is the true picture of my data, which is what we call it as consistency and transparency of the data. Right. So these are certain things that we do. It is just 0.1% of what I do daily. But just to let you know that this is what you are seeing on the screen is somewhat like what are the good or bad indicators, or what are the things that I need to be focusing on. The ones you see in red, don't worry about those. But ones which you see in an amber color or a red color is something which you should be sort of laying stress on. And people can just go into it and just click on it, and yeah, they'll get the drill down information. And if you see a sort of a time series kind of a sort of a graph that I have put in, it is telling me that, okay, there were too many projects that were there, and slowly the projects came down, and we may have to reduce the employee strength on a particular project because the scope is going down as we go into the cycle of a particular project. On the left hand corner, I mean, on the left is a sort of a tree map, right? So it tells me, say for example, MIT University wants to sort of build a tree map of different different courses that are running, and how many students are registered on these courses on a daily basis. Sorry, on an yearly basis. So what happens is somebody like a sort of a chairman of MIT University will look into this tree map and say that, okay, computer science batch is having the maximum number of people in various various departments that is there. So it can be CS, IT, or whatever it is. So I'm just trying to sort of build some sort of correlation with whatever you would be able to relate to. Okay, moving on. So what exactly is data-driven decision making? So first and foremost thing that you see on your screen is defining a goal. What is it that I want to achieve? What is it that I should be doing? That's my objective, that's my goal, and that should come from a sort of a top level management saying that, okay, this is the problem that we want to solve. Okay. And for that, what you do is you start collecting the data, analyzing the data, you start doing the presentation. And then what happens is once you start seeing the data, that's when you start taking actions. Okay. And based on, so as I was talking about, there is a loop back that has to happen. That, okay, when you have taken some actions, obviously what you want to do is you want to loop it back that, okay, because of certain data that is getting presented to me, I am not finding it right. Then what do I need to do? I need to update my goals, do a sort of a data collection, and that cycle starts repeating. Okay, so just taken a sort of an example of defining a goal. So that's my example, which is increase website traffic by 20%, right? So that's a goal. You may have built a new website and you are not seeing a lot of people coming into those websites, right? And you want to just increase your website traffic. So obviously that is a goal that has come from a sort of a CEO of the company and says that, okay, I want my website traffic to go up. So what you will do, I mean, as a data intelligence engineer, is that you'll start gathering the data of the website, the CPU usage, the number of users, and you'll start doing some sort of analytics and find what are the various trends, what are the sort of times in which the traffic has gone down, and what are the times when the traffic has been up. So it can be during a day, or it can be during a festival time, or it can be something. So Amazon website, Amazon.com, you may want to see that, okay, what are the hotspots, what are the peaks? And then somebody like Jeff Bezos comes and says that, okay, I want to increase my website traffic by 35% on it. So that's when you start doing the trends and correlation. And what exactly, when you have presented the data, then what you want to do, what are the different actions? I've written a sort of a A/B testing. Is anyone aware about A or B testing? What does that mean? Though I've written a sort of a pointer, but anybody knows about it? Yeah, you may call it as alpha beta, but it is not alpha beta, it is A or B. So it is the two versions of the same thing that you want to ensure that, okay, what is it that you want to, so you are giving options to your end user saying that, okay, either it is A or B, decide from it. Now A or B testing means that, okay, A has been put into sort of test, B has been put into test, whatever is giving you good results is what you will be selecting as a sort of a the thing to go forward. And the actions are something like, it comes out that, okay, high quality content should be available, there should be mobile friendly pages, and obviously there is you can bring in the advertising, Google AdSense and all that. Okay, this is more kind of a sort of a ground reality kind of a thing. So if you see out here, can anybody sort of look at this screen and tell me what is it that you look at it as a sort of a first thing? Anything? I mean, it can be very vague, it can be, yeah, just anything by the looks of it. Yeah, sorry. Okay. So does that color means, obviously we are very much aware about our signals. So what is it telling you? Anything? I mean, don't have to be very specific, don't hesitate. Yeah, just speak your mind out. Yeah. Yeah, this is more like a sort of an executive kind of a dashboard. Somebody like a sort of a chairman of the company wants to see what are my focus areas that I need to focus on. And what we do is we put in the sort of indicators over the period of time that, okay, so if you are seeing here, we are doing a sort of from a comparison from December 22 to March 2023. And when you see on those red dots is when you start going into those deeper details. So you don't have to worry about what those, because green indicators are something which the things are happening right. The things which are not happening right is a sort of a cross red mark that you see. So this is what it is that you are highlighting, what are the problematic areas. That's the kind of insight that is provided. And obviously it tells you, when I have written down a word visibility and transparency, now what is making that as a sort of a red indicator, or what is making it as a green indicator, is what you see on your start month or end month kind of columns, which tell you that this is my actual data. I am not the one who is fabricating any data. but I am just giving you a true picture of what the data is, right? Okay. Fine. Yeah, so now as I was talking about that, okay, you see a sort of a red indicator, and so yes, you have highlighted what that red indicator is, but you want to highlight why am I red? So this is what it is called as a sort of a drill down information, that you see something at the top and you want to drill down to the lowest levels and see why am I going red. So it is a sort of a anomaly that has been found in the data, that Red Hat Enterprise 7.9 version is being used in most of the servers, and this is what we want to sort of get away. Again, these are some sort of examples that, okay, you don't have to focus if you are seeing a sort of a donut chart. You just need to focus on the red things, and what happens is it becomes a sort of an objective for the higher level teams, the lower level teams, and the business teams to sort of build and give you some sort of budget on getting the improvements done as well. Fine. Once you have done it, I mean, what you want to also show is a kind of a progress over the period of time. Now, if when you are showing a progress, obviously you want to show that, okay, over the period of time, this is how my progress looks like. But because of the progress, or what is my point in time, what is it presently right now? You may have been doing very well in the past, but suddenly in your current time zone or presently you've gone down. So that is why you see a sort of red boxes, amber boxes, and green boxes are something which you can just ignore and yeah, move forward. Now I'll just explain, because things which are sort of closer to my heart, which is in the IPL, as you know, that there is an auction that happens, and there are player profiles that are built. Neeta Ambani picking up the sort of hand up and saying that, okay, I want this player, and they start bidding. Now, what is the idea behind that bidding is important. That this is what you see. Sort of, I mean, the data analytics are the data analytics people are sitting alongside Neeta Ambani and telling them that, okay, if we are going to bid for this player, this is what the past performance looks like, and this is how much we should be spending on a player, right? So I've just taken an example of Chris Gayle. So as you know that he had a sort of a good sort of graph between 2008 to 2015, but after that his performance went down. So so on your left hand side is the player profile, right? So the circle ones are the good indicators. And what happens is you start correlating the data that, okay, how many matches this player has played from the inception of IPL till date, right? So if you see the top right, I don't think so that is visible, but yeah, sorry for that. But there is a sort of a peak that is being shown that, okay, he played these many number of matches in those years. And obviously, when you start correlating the data, then you make a decision that, okay, whether this particular player will be a good buy or not. And suddenly what happens is this player gets unsold. So that's the kind of decision that happens then and there in probably less than 5 minutes, that a player gets a sort of a 20 million contract for next 45 days, or he doesn't get it. So that is where I just want to highlight what are the skills that you want to develop to become a data intelligence engineer. So yeah, coding essentials, Python, NumPy, Pandas, cloud essentials, AWS and Azure. Database essentials, everybody may be aware about Oracle, SQL Server database, but something which is on the cloud is what you should be sort of focusing on. Snowflake is something which you should be sort of reading about it, learning about it, because that's the next big thing that is coming in, that processes your data very fast. So I can just give you an example that our process used to take 47 minutes to process 2 million records. we have brought it down to 3 seconds. So that's the scale of Snowflake. Everything is running on the cloud. It assigns CPUs right there and then to understand what the scale of the data is. And yeah, this is again a sort of a big thing that is you're going to hear in the near future. Visualization essentials. Yeah, Microsoft Power BI. I mean, you can just, on the App Store, you can just find it out. On my phone, I have got a Power BI application, and I can just track all my dashboards then and there. You can also sort of register on the Microsoft site, and you'll be able to just start playing with the data. CI/CD essentials, very much necessary to do continuous integration and continuous delivery. So Git is something which is very important. I know that, yes, the time is up. So thank you so much. That's all from my side.
Thank you very much, sir. And I now request Professor Dr. K.M. Soni, sir, Dean Engineering and Technology, Amity University, Uttar Pradesh, Professor Dr. Vivek Kumar, Head of the institution, Amity Institute of Technology, and Professor Dr. J.K. Rai, Head of the Department, Department of Information, Department of Electrical and Communication Engineering, to present a memento to Mr. Nikhil Arora as a token of appreciation. Sir, please. Thank you very much, sir. I now take the opportunity to introduce our next eminent speaker for today, Professor Dr. Sardar Amin Islam, Professor, Victoria University, Australia, who is joining us in an online mode. Dr. Sardar Amin Islam is a professor and director of the Decision Sciences and Modeling program at Victoria University, Australia. He is also a distinguished visiting professor at InCITe for Artificial Intelligence and at AURAK. With extensive experience living, studying, and working in various countries and regions of the world, Professor Sardar Amin Islam approaches his research and academic works from a global and humanistic perspective. He has received numerous honors and awards, as well as visiting and adjunct professorial appointments in different countries, editorial appointments for journals, and keynote speeches at international conferences. He has authored 31 scholarly academic books across various disciplines that have gained international recognition, as well as published over 250 articles in top journals. I now invite you, sir, to share your words with us. Thank you. Sir, you are not audible right now.
Thank you, ma'am. So my talk is for 1 hour.
Sir, it's around 25 minutes.
Only 25. Yeah, I had wrong impression. Okay, thank you. So I will then proceed very fast.
Thank you, sir.
Can you see my PowerPoint?
Yes, sir, it is visible.
Okay, that's good. Ladies and gentlemen, this is my topic. It's a bit complicated, but I will try to make it simple and proceed very fast as I have limited time. So the summary form, what I'm going to say, the talk actually prepared in these different parts, like generally robots and robotics, artificial intelligence playing roles in health informatics. And in that context, we can use game theory to address some of the issues, how to manage the roles of artificial intelligence and robots. and then issues of cybersecurity in health informatics and how can we do Python programming, and the emerging technologies in these areas, and the the issues of risk and benefits of using artificial intelligence in robots in health informatics area, and briefly making some comments what is some of the future developments and what is our future in this area. And it's actually very important area for academic work, and I am happy to give questions and comments if necessary following my presentation. So I think I probably let me go through the summary of my presentation, and then I can go very quickly through the individual slides. The robots are being created, that we know that robots are being increasingly used in all areas of life, including health areas, and we know that robots are created by artificial intelligence to automate many activities, operations, and processes in health area. And the robots are also being used in health. So the use of robots in health, that is the area in the in science we call health informatics. So the problem of using robots in health or in area, one problem is that the robots are actually many situations they work in a team. So then we need to have a team for robots in health area also, from diagnosis to treatment to operation, nursing, and so on. So in that area, we need to have collaboration, coordination among those robots in a robotic team. So what we know, what we see in that case, these robots also are characterized by what is called multi-agent systems. That means in health informatics area, in health area, there are different robots that need to cooperate or collaborate. So this system is multi-agent system. So in this multi-agent system, how can we make sure that different robots will cooperate with each other, or they will coordinate, share information? So this is so we need to therefore bring the issues of multi-agent system in the context of health informatics if we want to use robotic teams for doing different tasks in health informatics. And in that context, what we need is to use game theory, because game theory is the mathematical analysis of multi-agent systems in general and multi-agent systems in health and health informatics. So why we need to do game theory analysis modeling? Because game theory helps us to specify and then formalize and then formulate and mathematically represent multi-agent systems, and game theory then can be used to analyze and make decision in multi-agent systems of robots. So therefore, we need to use game theory to formalize or characterize robotic teams in health area. And then, because in many real life, the multi-agent systems have problems of information asymmetry, there may not be any incentive to cooperate. they may not have an incentive to cooperate, collaborate, and so on. And there are also conflict of interest, all the sort of problems that exist in real life multi-agent systems. So if we use game theories, and we can mathematically specify and develop a model for the multi-agent systems in health, and then we can solve the game theory model to find out a better multi-agent system, so where the problems that we have said do not exist. So we can better multi-agent systems, or we can develop better robot teams, so that they can perform better job collaboratively. So and when we develop this sort of game theory model for robotic teams, robot teams, then we need to find, we mathematically we formulate, and then we need to find some algorithms, and then you develop programs and solve the game theory models for robotic teams, robot teams, so that we can find how the problems of multi-agent system can be solved, and we can find the better strategies or better systems, these multi-agent systems, where different robots will cooperate, collaborate, share information, and perform the task cooperatively. So that's why we can use game theory in health and related bioinformatics area, so that we can develop the algorithm, strategies, computer program, and platform or artificial intelligence for robots, so that robots can perform better tasks for doing health activities in a cooperative or coordinated form. So that is the simple form, the summary of my presentation. So I will go some of the technical slides also, and then at the end I will say some of the problems that we may encounter using these robots in real life health sector, doing different medical diagnosis, operations, prescription, and so on. So as I said, since the time limit, I will proceed quite fast, like health informatics. So we essentially, because this is a multidisciplinary topic, so some of the important concept I will just briefly define, so that for people outside the topic area may be able to understand my presentation better. So health informatics, we know the health informatics essentially is the application actually of computer technologies in health areas, and IT, artificial intelligence, and computer science, information systems, and their application to health, and that is what we call health informatics. Because as the previous presenter has said, the data, usage of data is very similar. Information, we can also use the word data in a similar sense. So health informatics, this because why we need to use data or technologies, IT, computer science, or data science, because there are different sort of information data we need in healthcare areas, and these type of data are different forms and complexities, and we need to use data science or technology, IT, computer science, or technologies for making better decisions or performing tasks in a better way. in healthcare area, in the area of treatment, general healthcare, diagnosis, health care management, planning and policy, and etc. So some of the areas where health informatics application are used in health are listed here. It goes from, generally the general analytics and like other machine learning and artificial intelligence technologies can be applied actually all areas of health. But some of the specific areas of health and healthcare are some of the examples are electronic prescribing, clinical decision support system, and although we know that hospitals and clinic all are being digitalized, we are being used IT information system extensively. So another area is telemedicine and medical imaging and so on. And but then the another aspect of my presentation is artificial intelligence and robots. And I think this is a computer science area conference, so most of the people will be familiar with the concept of or the phenomena of artificial intelligence. But for just to make the things a bit more clearer, we just define artificial intelligence here. Artificial intelligence is a computer program involving algorithm, also mathematical modeling and computer software, and its application and deployment that helps a machine to work like machine, computers to work like human beings, to perform tasks, think, understand, feel, and sense. And in this presentation, we'll be actually talking more applied side of artificial intelligence and its application. Artificial intelligence application is currently the main technology is machine learning. So machine learning is used to implement artificial intelligence in real life application. And so one of the areas of the manifestation of artificial intelligence is robotics. And that means we are developing robots that can perform many humanly tasks. So this is, and this in robots, the robots do perform tasks, make decisions, and be using artificial intelligence. So the artificial robots are a very important form of manifestation of artificial intelligence. Generally, we think that a robot is just a machine or a hardware, but in computer science area, robots are also can be also computer program software like chatbot and the other computer program they give information. Those are also technically called robots. So so in this presentation we'll be actually covering both type of robots. So in health informatics area, artificial intelligence is being very extensively, as you can see, I have listed here. So when you say artificial intelligence, we also say robots are also using extensively in this area as well. One also a particular area of concern in health informatics is cyber security. So why do we use artificial intelligence and robots? Because artificial intelligence and robots help to make things automated, and so doing things automatically, conveniently and easily, and many of the things that were not possible before can be done now better way. So as I have said, the robotic systems are also multi-agent systems. So there are problems of multi-agent systems, like different robots may have different information. Different robots may have different interest, or they even have different robots can even have some perception, even feelings. So then if that is the case, then how can we make sure that we form a robot team that can cooperate and collaborate and share information and do tasks jointly? So in as I have said before, to do that, to form an efficient collaborative robotic team, we need to use game theory. So game theory is actually game theory. Game theory is actually mathematical study of strategic interdependent and interaction among different agents or robots for making optimal decisions, correct decisions, or taking actions or strategy formulation. So if we use game theory in health informatics to develop a robotic team, then we can develop the mathematical model and solve it, and then we found the action, the strategies and decisions, or the strategies of different robots that will help to develop a better system of multi-agent system for robots doing different tasks in the health sector, in health area. So that is one area of health informatics. And the game theory can be different forms. So I will not go into discussion because of the time. And so this is an example where the game theory can be used, a sort of a simple, very simple possible example where the game theory model can be developed for cyber security problems in healthcare areas. So if we develop a model like that, and then we solve the model by this problem can be solved by hand because it's a small problem, but generally for bigger game theory model for health care area, we need to develop big models, so where we need to use mathematical algorithm and Python programming and so on. So from this example, what is saying that if we have a cyber security attack problem in a health informatics system, we can develop a game theory model, and then we solve the game theory model by computer program like Python, and then we can find out what is the best action by the security manager in, for example, say in a hospital. What is the best action the security manager in the hospital should take in the context that there are possibilities of cyber attack. So game theory can give the best action to be taken by the security manager. So this is another more mathematical, simple mathematical model of game theory. And some of the algorithms that can be used for solving big game theory models are listed here. And when we develop this game theory model and for robotics, and this sort of game theory models can be also actually developed in many areas of computer science. So not only one particular area, so not only robots, but many other areas. So what it means that if we can have game theory models for robots in one particular area, and then these sort of models can have can be applied in many other computer science areas, and essentially that will help different computer science technologies and algorithms and programs to apply extensively in different areas of healthcare and healthcare and health informatics. So some of the areas of where this artificial intelligence or robots have been applied are discussed here also. So some of the areas which maybe many of you are probably familiar with are genetic engineering, genetic manipulation, exoskeleton, virtual augmented reality in health, wearable technologies, like if somebody has a knee problem, that can be replaced by another robotic or artificial intelligence based technology. Some of the other areas are bionic and one important area that I will also, some of the areas of applications are also listed here. And so why we are using artificial intelligence and robots? But as I said, we have many benefits. And so the benefits are improving efficiency, productivity, convenience, supports all areas of life and living, especially in health area. And they improve medical processes, technologies, medicine, diagnosis, treatment, and so on. There are some profound issues in this area. I'm finishing soon. One of the areas, for example, some of you are probably familiar with the issue of anthropomorphic agents. That means that we can probably develop robots. Some people think that it's possible to develop robots which will probably behave and work or act like exactly human being. So this is an health issue also. So there are many risks of artificial intelligence. Some of the risks are like a possibility of the possibility of robots overtaking human being and so on. So what we are suggesting is that we have to develop and deploy and use a robot and artificial intelligence in health areas, but we have to do it prudently. Otherwise, we don't know what will happen in the healthcare sector and for the human being as a whole. So as I said, that was my presentation. I had to rush. If you have any question and comments or any sort of ideas to improve the literature or knowledge in this area, you can send it my email to send email, or you can connect me through LinkedIn and so on. Thank you.
Thank you so much, sir. Thank you for sharing your views and sharing your knowledge with us. Thank you so much for this session.
Thank you.
Okay, sir. Thank you, sir. Sir. अभी क्या ज्वाइन करना है? अभी ये ऑफलाइन सेशन है जॉब वाला होगा। अब क्या करूं फिर इनकी पीपीटीज? पल्लवी पीपीटीज हाँ एक मिनट। यही है हाँ जी। Now I take the opportunity to invite our next honorable speaker, Dr. Adish Budri, University of Cape Town, South Africa. Dr. Adish Budri is an associate professor in information systems and using technology to aid developing economies. His research aimed in identifying the critical success factors that have been discussed in current academic literature and bringing them together to understand their overall impact on the economic value. A business derives from its management reporting system and present a statistically tested conceptual model to enable companies and government bodies to understand the return on investment of the system of organizations. Now I would like to request Dr. Abhishek Srivastav to present a sapling. Now I request Dr. Abhishek Srivastav to present a sapling. And I request Dr. Adish Budri, please come on the dais. Dr. Adish, now I request him to just share his knowledge with us. Thank you, sir.
Okay, good afternoon. My name is Adish Padri, and I'm an associate professor at the University of Cape Town. And I think I'm also the guy that stands between you and lunch. So I'm going to try and make this as quick as possible. Can everybody hear me without the mic? Fine? Lovely, thank you. So let me ask you a question. How many of you here want to be multi-millionaires? Okay, how many of you are thinking of starting the next Flipkart? How many of you are thinking of starting the next Uber? Anybody want to be an e-commerce entrepreneur here? So what do you guys want to do then? Come on, shout out to me. What do you want to do? If you don't want to be rich, if you don't want to be an e-commerce entrepreneur, what do you want to be? Prime Minister. Prime Ministers don't get paid enough. What else? I can't hear you. Come on, tell me what? A what driver? Did you say Zomato driver? I didn't catch that one. So start your own e-commerce business. Money. Networking. Execution. No, why not? Because you can find another platform down here. So what do you actually need? And that's the big question that we're trying to answer here. See, the thing about entrepreneurs, is this one connected? See, the thing about entrepreneurs is they tend to actually create a very, very nice economic situation for the rest of us, right? So whether you want to be an entrepreneur, whether you want to be a Zomato driver, that's awesome. It doesn't matter. The fact is that we all require entrepreneurs. How do you think the US was actually built to become the economy it is today? How do you think China built itself up? How do you think India got to where it is today? It wasn't on multinational corporations. It was on entrepreneurs. And you mentioned quite a few things here. You mentioned passion. You mentioned an idea. There's little bits of all of this that you're gonna need in order to become an entrepreneur. So, entrepreneurship is not just about business. This year is 75 years since independence, am I right? Okay. Independence from what? From who? The British. Okay, so it's independence from the British, but from what? What do they do to India? They oppress them. How do they oppress India? They took rights away. What else? What's that? Making decisions for them. Yes, exploitation. All of this we refer to as colonization. So colonization is the idea that one country benefits off the back of another country. And that's exactly what happened here. It's exactly why I am of Indian descent and I'm fourth generation South Africans. There were no Indians living in South Africa, but we were taken there as slaves to work on the sugarcane fields by the British. Same as Suriname, same as Reunion and the French. So what do we need to do now? There's a very, very big movement globally to decolonize. And it's not about just removing the impact of colonization. It's about removing the mindsets of colonization. And guess what? Entrepreneurs are at the forefront of that. You guys are at the forefront of that. You are responsible, not our generation anymore. I'm getting old now. It's not our generation anymore. It's your generation that's responsible to take the torch and run with it, right? How do you actually do that? You do that by challenging existing power structures. Why are things the way they are? Is it because the British left it here? Or does it actually work for India? Promoting local industries and cultures. How many websites have you come across that are in, let's say, Devanagari? How many websites you've come across where they're native Tamil or in Kannada? Why not? If those websites are targeted at a Malayali population, why is that website not in Malayalam? Why does it have to be in English first? It can be both, but why is it built in English first? To target the mass audience. But who's the audience here? Think about it. The audience is who we think the audience is, which is based on what we're told the audience is, right? It's a very global north situation. It's a very global north perspective. So what we got to do is we got to create new economic opportunities. So when we talk about entrepreneurship in India, what are we talking about? Guys, look at these figures. Look at a simple figure here. Before COVID, entrepreneurial activity was sitting at 5.3%. It's now sitting at 14.4% in India. Is a massive, massive push towards entrepreneurship. India has the highest fintech adoption rate in the world, right? The opportunities are sitting right here. So how do you take advantage of them? Think about all the people that are unbanked in this population. Think about all the people that don't conform to the normal structures that the West tells us that we should be conforming to, right? Immediately they left out of everything. Think about your grandparents. Think about people sitting in villages. Are they part of the economy? Are they part of the economy that we know? The economy of sitting here and talking about entrepreneurs and talking about data science and the likes? Or are they being more and more excluded? The Digital India project accelerated the adoption of fintech massively in India. It is a work of absolute art. So my personal experience of it is I love Royal Enfields. I ride Royal Enfields. I've got a Royal Enfield here. I'm riding a Himalayan at the moment. What an amazing bike. And I've ridden up in the Himalayas in Leh Ladakh. And when you're riding up there, I think it's called the Moor Plains. It's about 4,000 meters above sea level. There's absolutely nothing. There are no trees. It's just stones and rocks and mountains. And while we were riding, there were guys laying cables. So I speak Tora Hindi. So we tried a little bit of broken English, broken Hindi, trying to understand why are they laying cables? What are these cables for? And the guys go, so it's digitizing India. And I'm like, yeah, but it's the middle of nowhere. Why are you putting this? Every village should be connected. And you look at it, a population of 1.4 billion people. You look at the cell phone penetration in this country. If I compare it to the country I'm coming from, there's 60 million people. We can't do a tenth of what you've actually been able to do. Yet that opportunity still lies totally untapped. So some of the success stories. Oyo, Make My Trip, Flipkart. Okay, don't get me wrong, some of these people are terrible people, but the businesses that they built are absolutely phenomenal, which is why we need to be having this discussion, because it's not good enough to just build a business. You actually have to build as a human being as well. So what are the skills required? Okay, we know about this. We know about digital literacy, right? Definitely business acumen, communication and collaboration. Somebody spoke about networking, customer service and support, adaptability and flexibility. If something's not working, you got to change it, right? The famous story of Kodak. Kodak were the first people to have a digital camera. This was back in 1995. The board of directors looked at it and said, no one will ever use a digital camera. Kodak is now non-existent. Analytical and problem-solving skills, and creativity and innovation. So yeah, we mentioned all of these things. But what about the hidden stuff? What about the stuff deeper than just business, right? And this is where we're talking about that set of values and attitudes, those norms that are not explicitly taught. You're not going to learn that sitting in a classroom. You're not going to learn that from my speech. You're going to learn that from getting out into communities. You're going to learn that from finding out who your target market is and getting immersed in your target market, right? That's the only way you're going to be able to experience those things. They can be conveyed through education. They can be conveyed through a broader social and cultural context, but that's about it. You can get the very, very basics walking out of university, but that's only the starting point, right? The one thing I learned about walking out with a university degree is I actually knew nothing. It's the starting point. It's a piece of paper that granted me a license to learn. So this can shape e-commerce entrepreneurs' approach to work and interactions and impact success. Take something as simple as Oyo. Why was Oyo successful? Anybody have any idea? Why was Oyo successful? Why? Louder. Affordability. Affordability for who? Let's put it this way. Okay, fine. I now have an OCI status. So I can actually book an Oyo room. Before this, I wasn't allowed to. It was very, very specifically for Indians. They knew exactly that, you know what? Indian travelers are seeking adventure. You've got this massive, amazing country. They want to go check it out. Foreigners are doing it more than local Indians. So how do we make it affordable? How do we make it easy for Indians to move around? So he immersed himself in that and he came up with an idea. So this includes that entrepreneurial mindset, as I said, adaptability, but also social responsibility. And this is the important one, right? Think about how you give back, because right now it's not good enough to just be rich. How many of the rich people you see on the news are actually happy? So think about your gross domestic happiness. So what's the future of e-commerce? Look at that top diagram there. Mobile phone internet user penetration in India from 2010 to 2020, those are actuals, and estimates until 2040. You're going to be sitting at 100% mobile penetration, 100% internet penetration before 2040. It's actually going to stabilize at that point if you don't take advantage of it. It's just silly, honestly. So how do you do it? Use your education as a basis. Education doesn't finish here in the classroom. That's a textbook that I've actually just finished editing with a group of people in South Africa. I've sat with entrepreneurs, I've sat with other professors. We haven't looked at it as just an academic exercise. It's much, much more than that. Okay, so that was as quick as I possibly could have gone. That's 15 minutes. So I'm going to wrap up with a very, very absolutely unshameless sell of my own e-commerce, which is my book that I've written. It's another book. It's a fiction book. So if anybody is keen on checking it out, I hope you get to check it out because some of the characters are from Amity College. So, and it's based in Delhi. So hopefully you get to check it out. So just go to my website, adishpadri.com. And yeah, that's about me. So if you have any questions, you're welcome to drop me a message, drop me an email, or catch me in the corridors. Let's have a chat. Thank you, everyone. Hope you have a wonderful afternoon.
Thank you, sir. We are grateful for your innovation and for your informative words. Thank you so much. Now I request Dr. Vivek Jangra, please come and please present a memento to our guest, Dr. Adish Badri.
A very energetic afternoon to everyone. Good afternoon, students. Good energy. Can we have it once again? A very, very good afternoon to each one of you. Bad. Good afternoon. Let the energy flow in, my dear students. Chat GPT. I think every one of you are totally into it, getting onto it, right? So we have this very relevant session about to start. So please pay attention. We have the stars of the industry out here, and we are highly privileged to have them. May we begin, sir, with your permission? Yeah.
One machine can do the work of 50 ordinary men, but no machine can do the work of one extraordinary man. A most splendid afternoon to our esteemed industry leaders, distinguished conference attendees, respected faculty members, and dear students. It is with great honor and deep reverence that I, Shaurya Mathur,
and I, Siddhi Gautam, students of BTech IT,
representing Amity University, Uttar Pradesh, Department of Information Technology, Amity School of Engineering and Technology, extend a heartfelt welcome to each one of you. Today, we gather together for the CXO Forum to engage in a stimulating discourse on a highly pertinent and intriguing topic, ChatGPT, a threat to human jobs or tool towards excellence. This technical conference will provide a platform to share knowledge and apprise of opportunities and initiatives that will substantially benefit professionals, academicians, researchers, and enthusiasts in the field of decision-making.
Amity University is a unique blend of modernity and tradition. Keeping up with MIT tradition, we would like now to welcome our industry guests with saplings as a symbol of new beginnings.
May I request the Amity leadership team to present the saplings to the industry leaders. Mr. Sameer Nigam, Chief Executive Officer at StratBeams Consulting. Mr. Amit Narola, Global IT Senior Director of Cloud and Infrastructure at Boston Consulting Group. Mr. Kirti Lal Kala, Vice President, Elcom Innovations and Senior Advisor, Sun Group Global. Mr. Rohit Bharadas, Partner of Cyber and Data Security Protection at Grant Thornton Bharat LLP.
Artificial intelligence is changing the world we live in, how we interact, allowing us to solve problems in creative and powerful ways. With the introduction of ChatGPT, we need to ask ourselves, can this technology be seen as an opportunity to achieve excellence rather than a threat to human jobs? On that note, I request Professor Dr. Madhuri Kumari, Deputy Director of Placements and Industry Relations, MIT School of Engineering and Technology, to extend her gracious welcome to the esteemed industry guest. The stage is all yours, ma'am. Over to you, please.
Thank you so much. Dear students, a very, very good afternoon to all of you. What a great gathering. One side of the table, we have stalwarts of industry. On the other side, we have been joined by both of our head of the institution along with the head of the department. So it's going to be such a balance and such a great session on ChatGPT. Without taking much time, may I request our head of the institution, Dr. Manoj Kumar Pandey, sir, to kindly welcome our guest.
Thank you, Dr. Badri. And good afternoon to all. And this afternoon session always is a challenging one. And first of all, on behalf of our respected Honorable Founder President, sir, our Chancellor, sir, Vice Chancellor, Madam, and on behalf of the whole MIT family and my own behalf, I would like to welcome our all industry leaders this afternoon. I would like to welcome Mr. Sameer Nigamji, CEO of StatBin Consulting. Please, with a huge round of applause, please. They are the industry leaders, those who have spared their valuable time, and they have decided to come and to be among us and to share a lot of experiences, knowledge, and many more. I would like to welcome Mr. Amit Narula, Global IT Senior Director and Boston Consultancy Group, with huge round of applause, please. I would like to welcome our Mr. Kirti Lalji. He is Elcom Innovations. We had a long association with Elcom. I would like to welcome Mr. Rohit Bharat Dasji, who is the partner Cyber Trans Bharat LLB. And we have to join one more gentleman, Mr. Sakun Khanna from Oracle Corporation shortly. And dear students, this industry session is always very interesting and for very much informative for everybody. And now, as you know, that the topic chosen for this afternoon is again interesting for all of you, being the students of information technology, computer, and the related technologies. It becomes more important for everybody to understand and to have a debate on the topic that has been chosen by our CRC. And I must congratulate them and I must appreciate them for selecting this important topic for today's discussion, because whenever I'm going to some of the classes, their demand is, let us talk and debate on this particular topic, ChatGPT. And now, this is surprisingly, if I ask someone, what is the full form of GPT? Normally, I used to ask the question from the last rows, but if the first row can try without seeing their mobile phones, what is GPT in chat? Yes. Quickly, this time is only for 1 minute. Yes. No. Now it is done. So the chat GPT is generate again. Yes, now you have seen perhaps. And it's a great AI tool. And we have never thought about the AI will go up to that extent. And even more to come, because when we are developing the artificial intelligence, our own intelligences have its limitation. Our brain have a limited number of cells where our memory is being stored and being processed. However, the artificial memory do not have, or artificial intelligence do not have any boundaries. It's endless. I wonder, I don't know what extent it will go. And ChatGPT is one of the live example of where the chat process is going on right now. There are a lot to debate on the pros and cons of this particular technology. However, technology is never good or bad. It's up to us how we are taking advantage of it, or how we are going to get disadvantage of it. So this session is going to be wonderful. But yes, in every machine, in every technology that we are developing, one thing we cannot mix into it is the emotions. I will just finish with, because we have limited time, just to finish with one small example where chat GPT, how the chat bots are doing wonders or wonderful task is one man was flying from Delhi to Mumbai, and that flight was finally has to go to Chennai. And the person was got down at Mumbai and his luggage went to Chennai. And he has written a very emotional text to the flying the company where through which he was flying. Thanks for devoting me to Mumbai and my luggage to Chennai. Then immediate response came, "You're welcome. Give us next chance once again." So that emotions, I don't know how we are going to enter into it. So with this, thank you very much. And once again, I would like to welcome everyone.
Thank you so much, sir. So my dear students, the context is all set. But to take it forward, may I request Professor Dr. Abhay Bansal, sir, to kindly share some views on this, whether such tools are taking away from us something or is it going to lead to an excellence. So over to you.
Thank you, Dr. Madhuri. Professor Pandey has already told about ChatGPT, and even, if you are in class 10th or 12th, even in iCard also they have printed that ChatGPT is not allowed, right? So if it has been allowed, it will be taken as a UFM, right? So it has become so popular, and we have called a lot of professors to have debate on this topic. As Professor Pandey has also mentioned, AI does not have any limitation. And you're going to find that within 1 year, 2 years, it is going to have some capability which are more than human brain, because human brain has limited number of neurons. So it is going to be a challenge, and we would like to listen from all learned industry guests who has come, what they want to say about it. But one thing is very clear, technology has unlimited scope. It is up to you how you're going to develop that. And I'm sure we are going to see a lot of things. We have already seen driverless cars, which are operational in many countries. And we are going to see a lot of revolutions. Even when you go and buy a car, they are saying it is AI enabled. If you go and buy a bike, it is AI enabled. So technologies are playing very important role. And it is expected from each and every industry that disruptive technology must be used, and technology like AI, data science, cloud computing, they have a lot of applications, and they have changed total customer experiences. So with this, thank you very much. And I welcome all the distinguished guests for sparing their valuable time. And it is a topic should not be 1 hour. I'll request Dr. Madhuri and our CRC team to have a lot of such debate from industry, so that you all can understand right perspective and can understand and can do something big by having your own startup, so that we all can proud, rather than job seekers, you all can become job creator. And in India, our Prime Minister has already put it his vision that we all have to work on Make in India. So we'll look forward that through deliberation and through collaboration with industry, we would like to make a difference. And together we all have to work to make world as the best place to live. Thank you very much. And we welcome, please put your hands together for all the guests. Thank you.
Thank you, sir, for setting the context of the forum. To start the session, I feel great privilege to introduce our first speaker, Mr. Sameer Nigam. He's the Chief Executive Officer at StratBeats Consulting, which provides technology platforms for driving customer success through digital transformation. With over 20 years of experience in strategy formulation and implementation, Mr. Nigam has been focused on driving growth and investor returns. Before his entrepreneurial journey, he worked with Genpact, where he was responsible for managing transition projects of finance and accounting functions of large US MNCs in the retail, defense, aerospace, and engineering sectors. With Tata Consultancy, he has spent over 10 years in various geographies, ensuring the development and management of large projects in several business domains, such as housing, banking, finance, taxation, hospitality, and many more. Mr. Nigam is an alumnus of IIT and IIM. Sir, I invite you on the dais to address the session.
Okay, so thanks a lot. And so this is 10 minutes I get, right? 8 minutes. Oh, 8 minutes. Oh, okay. Okay. So let me set my timer for that.
So 8 minutes, you got that. So guys, you look all very shiny and nicely dressed and ready. And I tell you, I just love this. You guys are pretty smart. I've seen this campus many times. But I must tell you that I also remember my college days. So the moment Dr. Manoj, he said, you know what, you usually ask that question to the first row, I thought I should duck under the table because I didn't know the answer. So anyways, I think, so thanks a lot for joining here, Amit, Rohit, and Kirti. So I will try to give you 2-3 takeaways only, so that you can possibly get the same topic in a debate somewhere and you have something to talk. Because I understand your time is at a premium and I have to really do some justice to this. So let me tell you this. This is not the first time that great technology has come into the picture. Fantastic, perhaps even fantabulous, you could call it. It's really good technology. But this has happened in the past also. So long back, 90s, so computers were there, and you may not believe it, but they were also very dreaded at that time, that, you know what, they will take away jobs. So they do something like that. So jobs go away. But what also happens is the jobs actually move from a place A to place B. It doesn't really totally go away. Later on, the same technology that gave rise to an IT industry. And hopefully, some of you are from IT. Are you some of the students of IT also? Okay. So I'm looking to hire some interns. How's that for a little bit of attention? Huh? Okay. No. Okay. Okay. So now let me tell you this. I was talking to a very bright student of BITS Pilani. They are possibly equally bright. And I said, what do you do with Chat GPT? Tell me something, I have to talk about it. So he said, you know what, I tried it last time. When I was submitting an assignment, I prepared a few assignments using that. So I said, whoa, man, really, you can do that? So, I mean, this is good. But what happens is, look at it this way. I have an executive assistant, pretty smart lady, and can do a lot of things. Now, if she has Chat GPT, she is probably a brighter person. So the job is not going anywhere really. The use of technology is always favorable to smart people like you. So my sense is some of you will utilize technology to your advantage. And my sense is already you are using a lot of technologies more than us. So that's one thing. The first takeaway is that, you know what, the jobs actually don't disappear. They actually shift hands. So someone else will get hired. So that's what happened. The second thing is a little more macroeconomic. If you see, now, what's the unemployment rate in India? I'm not pretty sure, but maybe 5.9%, something like that, isn't it? Now unemployment really depends on much more on macroeconomic parameters than anything else. And you know, if there is more investment coming into the industry, there's more funding available. Now, those are the parameters which drive the employment a lot more. And that's why you might read some subtext somewhere that, you know, interest rate went up and therefore inflation did this and the employment did that. So those things are connected. This is how actually it works. So if you really want to take away here, go and study this thing, maybe just Google it a little bit, called Phillips curve. So whenever you're talking about something like this, the employment is actually directly related to inflation somehow. So you would see that whatever leads to that also ends up helping in employment. So that's a second takeaway for you. I only have 4 minutes left, so I really have to bring it back to the third takeaway. No, ma'am, don't be sorry. It's important. I'll lose their attention if I talk more than that anyways. So the third thing is that why don't we do one thing while you're there, because, you know, your profs will like it if you look a little more disciplined. So why don't you look at the person on your right hand side? Can you just quickly flip that way? Can you see that? So do you understand what went on right now? You are looking at your competitor perhaps. Now this is the person you really have to be scared about, but the person on your left was looking at you too. So let me tell you a simple thing which you'll probably relate to. A simple story of Little Johnny. Now, it's a very popular joke series. You must have heard about it. So it goes like this. So Little Johnny was walking with his friend and they sort of went inside a wood somewhere and they saw a grizzly bear. Now what happens is the friend, he starts panicking. while Johnny bends down, starts tightening his shoelaces. Now the friend was panicking. He says, okay, so dude, are you going to outrun the grizzly bear? So Johnny says, no, I just have to outrun you. So the idea is that, you know what, your competition is not from ChatGPT. It's possibly in the room here. Important thing is, now if I take you back, possibility is you have forgotten the key takeaway one, which was about that, you know, the technology enables people and, you know, it shifts from A to B. Many of us in this room, at least on the dais, we have carved our careers out of that situation only. So in last 20 years, the IT has been a big boon for us. And, you know, just the way I started my company, and IT is actually a big paymaster, you have to really understand that what you have to work on, if that is the last takeaway for you. You have to look at your work ethics. So though I am from startup community, but I'm going to tell you something contradictory here. So have you heard this? Anybody, if you raise your hand just like that, so that I know that you should work for your passion. Have you heard about that? Yeah, I mean, you should find a passion, work for it. Okay, so junk it. This is probably not going to help you. Why? Why? The reason is pretty serious. I don't need to teach you to work for your passion. You know what? You're hardwired to do that. Now, when you play with the reels or whatever videos, short videos, your professor say, don't do that. That's your passion. You're enjoying it. The bigger thing is, can you work on grunt work? Okay, so if you practice that a little, I'm not saying do it the whole day. It's pretty boring. But okay, allow me to say this. This could be grunt work for you today. Like, you know, you're sitting in a conference like this. So, but if you can train yourself to do some of this, maybe pick up a tough subject, even try it for 10 minutes. This is really going to create that differentiator, and you will become Johnny, not the friend. So this is my last takeaway for you. Thanks a lot for being very nice audience. See, your professors were not telling me the truth. You guys are pretty enthusiastic. You look pretty well groomed. Oh, they're still here, so I shouldn't have said this. So thank you very much.
Thank you. That was an enthralling talk, sir. Now, I feel honored to call upon our next speaker, Mr. Amit Narula. He is the Global IT Senior Director of Cloud and Infrastructure at Boston Consulting Group. Sir is a trusted technology leader with over 18 years of progressive technical leadership experience. He is in charge of developing and implementing the growth strategy for the ops engineering, database operations, cloud, and DevOps teams across all global offices. He is recognized for his ethical and value-based leadership style, as well as for enabling and driving the organization's core strategies implementation. His people skills in team growth are guided by an inclusive approach and proactive collaboration with stakeholders. His current role includes hands-on involvement in database engineering, product solutions, and I&O management for critical business-facing products, as well as driving efforts on CI and CD concepts for DevOps and production support releases, AWS cloud-based integration and support. With this, I would like sir to please take the lead.
So hello, everyone. First, I would like to thank the faculty members over here for inviting me, and to the panelists also. Thanks a lot. If I can request for a quick raise of hands from all of you, is there anyone in the room whose parents don't own a smartphone in these days? Anyone? Okay. Is there anyone in the room who has not used ChatGPT for his assignments? You can be great. So that's like 50%. It means 50% are still referring to it. So I'll just start by mentioning that with any technology revolution, there are always apprehensions which come in. So if I come from Meerut, which is just like 70 kilometers away from here. So in the 90s, we started with this banking revolution wherein all the ledgers, your bank accounts were digitized. At that point of time, there was a big thought in the market that all these bank jobs would go away. There were bankers, unions who were going on strike. But look what, if you cut to today, we still have that banking sector thriving in the market. We can't imagine like without having fintech or without having banking sector in our economy if we would be able to survive. And I can go on with a lot of other sectors that have already seen that kind of transformation. If you look at it, even in the recent times, in the past decade or so, with all these apps that were coming on board, they have only provided and transformed the last mile connectivity. When Uber was coming in, when these taxi hailing rides were coming in, there was big concern in every, in the transport sector that the drivers would not be able to make that much money, that you would not have more jobs created in the market, but the outcome has been completely different. So just take a pause and think that technology has been a big enabler. And I'll give you an example. If we stay out of that curve, it becomes really difficult to survive. So I'll just take a personal example. Like 10 years back or 8 years back, I requested my father that, can you please buy a smartphone or maybe just like a mobile phone? It would help us to stay in touch. When I'm going to office, you'll be able to call me. And he was like, you're just wasting my time. I don't even want to do that. But somehow, thankfully, he bought a smartphone a few years later. And today, he's the one who is saying that, hey, you need to stop doing this e-commerce shopping because you're not striking the right deals. And he's the one who is managing all the groceries and getting the best out of those e-commerce platforms. So you can see the tangent through which all this has changed. The best factor around this is that instead of ignoring technology, we should look towards the option of embracing technology. That's how we can survive in this digitized world. Coming to ChatGPT, ChatGPT is just a product. Artificial intelligence has been in the works now for more than 15 years. And then if you look at traditional AI was having use cases which were not touching you. And that's the reason maybe we were not aware of the advancements that were happening in artificial intelligence. But now with ChatGPT, what has happened is that instead of traditional AI, we now have this generative AI, which is so easy to use, which is so flexible to adapt to your requirements, and then it helps you generate value. So right now, a lot of content that is being created through ChatGPT, that's primarily related to just use it as a personal assistant. Even now, there is a fundamental shift. Let's say if you have to do something, or if your teacher asks you to do a big project, you would still go to maybe Google, you would still go to the websites, to authentic websites to get the sources and references for your projects. Not that you are not using internet in this day. What ChatGPT does is it only transforms that understanding, and it becomes your personal assistant because it crawls the web, it crawls the Reddit websites, it crawls the books it has been trained on, and then it will provide you with a very concise view of your question. If you look at the next 5 years, this is going to fundamentally change the market because this has so many implications. The generative AI and ChatGPT is just one product of it. So there are 3 major areas wherein it would have an impact. The first one is on the language model, which is how you generate code, how you are going to debug the code, how you are going to edit the content. Then on the sales and marketing fields. So this will have impact on those areas. Second one is on audio, the way you will convert audio to text. The third one is on video, which is on how you generate content, which is more suited to a wider audience. And ma'am, if you can just keep me on time. Sure. Okay. So there are 3 fundamental areas wherein generative AI is going to have an impact. And then this impact is not going to be superficial. This impact will be on areas which will have a clear impact on the last mile connectivity, where it will democratize the availability of resources to every person or every individual in the world. If you look at it from a healthcare perspective, the amount of time this technology is going to help us in cutting down on the research and development. And to a decent extent, a lot of this data, this algorithm has already been used in when we did the vaccine creation in the wake of the corona pandemic. So one is it will cut down the research and development time when it comes to healthcare. You will have more personalized healthcare plans. You will have more personalized treatments. You would be able to find solutions to the communicable and non-communicable diseases faster. And then the second area is on content editing. You will not have to now go to 20 different sources to fetch the content. You still have one place. So generative AI has been transformed because of the availability of computational power, because of the availability of easy learning model and data that has been available. And the last one is the high requirements that are there from the business perspective. So my only advice is that instead of ignoring most of these technology evolutions which are happening, go ahead and learn. I think that's the most important factor which will help you to survive in this digital economy. Whether you want to get into a job, you want to be an entrepreneur, or you want to have different options that are available to you, it is critically important that our talent of today starts learning on it. And I think the government of India in the last budget has come out with a focus on artificial intelligence. I think there are specific funding that has been done on that. There are other countries which are little ahead in the game. China already has the Beijing AI Institute. So same way, I think it's right time that our government is also planning on it. So I think it's going to be a big tool for excellence. That's a viewpoint that I share very fundamentally. And then this will help us to produce a lot more innovation in the market. I think it's going to turbocharge the innovation. So as Mr. Nigam mentioned earlier, you need to ensure that you are evolving with that landscape and you are not missing out on that journey. So that's my take on that. I think these are very exciting time. You are at the cusp of the next revolution, actually. And then there is no need to escape. I think the only thing that we have to do is to just embrace. And with anything good, we have to ensure that we are doing it responsibly. Otherwise, it becomes a Frankenstein monster. It will come back to hit you. So responsible AI and a lot of those things are evolving, which means your IP rights, your rights around data, the authenticity of data. So all those things are going to evolve, but please start learning in most of these, with most of these technologies that are there. So that's my take. And then, yes, definitely, Mr. Nigam, a very talented bunch of individuals, students over here. And I truly wish you all a great and bright future ahead. I represent BCG. BCG has some partnership with MIT, and then we do have extensive partnership with a lot of other academia. So we work across, we hire talent from the institutes in India, and we provide them with a platform wherein they can continue to aspire and nurture their talent. So thank you again. Thank you so much. And thanks for the invitation.
Thank you, sir, for that wonderful address. We have a lot to gain from that. I feel honored to introduce our next speaker, Mr. Kethi Rarkala. He's the founder and CEO of Art Labs, the senior advisor at Sun Group Global, and the vice president at Elcom Innovations. Mr. Lar is a strategist and a technocrat. In a career spanning of 18 years, he is an entrepreneur, has worked with offices of Prime Minister of India, with leading industry bodies, and as an advisor of global conglomerates, and VC offices in investments, merger and acquisition. He has wide and global experience across traditional, high-tech, and emerging industry verticals. He has been a member of various government working groups and is a recurring jury member of global entrepreneurship and innovation challenges. He is now following his passion, climate change and climate adaptation, and has recently set up a venture and studio for climate tech startups and is building an environmental footprint management solution for industries. Sir, if you could share an enlightenment towards the student body, please, the floor is all yours.
Thank you for that very, very generous introduction. Next time, ma'am, I think I'll just make it one line and give it to you, right? Good afternoon to everybody, including my co-panelists slash speakers. But before we jump in and say anything about Chat GPT or whatever that turns out to be, I have two quick questions for the entire group of audiences here. Who understands what F equals MA is? Who understands what F equals MA is in this entire audience? Right. So since you understand force equals mass into acceleration, if I think it's okay. So if I ask you guys to start computing the thrust required for a 200-ton rocket to be launched into space, will you be able to do that? Yes or no? You understand forces mass into acceleration. Will you be able to compute the thrust requirement for a 200-ton rocket to be launched into outer space? Yes or no? I can't hear a thing. Some say yes, some say no. Can I have a show of hands for yes? A show of hands for no? Okay. Something on a different track. How many of you have been learning mathematics for more than a decade? Right? So you understand addition, multiplication, subtraction, all of that. Correct? Right? So if I ask you a question, what is 1979 times 2038? How many can give me the answer right away? 1979 times 2038. How many of you can give me the answer in the next 30 seconds? Without using a calculator, please. Right. So what am I driving at? Why am I asking you these silly questions? Now, since we are talking about artificial intelligence, what we just saw is a demonstration of how natural intelligence works. Correct? You understand the basic principles, but for you to be able to come up with a relevant, contextual, appropriate answer to the question that has been thrown at you, after 10 years or 15 years of learning mathematics, you're still thinking. It's not necessary that you have the answer immediately. What does that teach us? It teaches us that natural intelligence also has to evolve over a period of time to give you the right responses in the right context. Right? An example that the professor was giving us. Someone said, "Thank you for misplacing my bags." And the chatbot said, glad to have been of service. Correct? That is the problem that will arise as these these are the kind of problems that these technologies are beginning to address, so to say, or the developers behind these technologies are beginning to address today. And where do you come in? You have the opportunity of improving upon what previous fools like us have built. Right? So your chance is to make sure that the technology evolves, make it better, make it more useful, make it more productive, make it more contextual, make it more worthwhile, make it more socioeconomically beneficial, and take it forward from there. That's the first thing that I wanted to kind of put out in front of you, that grasp the technology, understand it inside out. You need to know what is right and what is wrong with it to be able to take it to the next level. We were just given an example of someone using ChatGPT for an assignment, right? Now, there are multiple problems with that. One is, of course, you're cheating. That's that apart. The answer that ChatGPT gives you might not necessarily be the right answer to your assignment because it's not there yet. I mean, the technology is not that correct yet. Right? So be aware of that, which means there are issues that people are trying to resolve as more and more people are using it, more and more people are testing it. New and new concerns are being thrown out. There are people talking about what is right, what statements are right and what statements are wrong, and people are trying to correct them. Correct? So bear that in mind when we talk of new technologies. And like everybody has been saying, this only provides you an opportunity to learn something new and be ready for the next job revolution in that sense, or the next skill revolution in that sense. So be aware of that. That's broadly what I wanted to kind of put in front of you. But then also think of it this way. I don't know how many of you have been introduced into AI in general as part of your curriculum, but I would broadly put AI into 4 different buckets. One is narrow AI, as they call it, right? Narrow AI in the sense something that is trained to do a specific task. For example, speech recognition or the facial recognition system that I saw while we were entering the campus. That's narrow. It's only looking at faces and is trying to recognize them. That's narrow AI, right? ChatGPT
kind of falls under the generic AI bit, which means it's trying to be the jack of all trades. Correct? An example of that. I think of myself as, let's say, a decently fit and someone who was an athlete previously. I used to play basketball, but can I be a F1 Formula a race driver? No, I'm not. I'm still an athlete, but that guy is also an athlete. Or can I compete in a 100 meters race against Usain Bolt? No, I'm not that fit. Correct? I'm still an athlete, but then there are my limitations. So generic AI also has such limitations. It's good AI, but it will have its own limitations on what it can deliver. That's the second vertical. Narrow, generic is the second vertical. Third is super AI, which is beyond generic AI, which can actually work like a human and think like a human and give you inputs like a human. Pretty close to what a human being can adapt and, give you contextual answers in different scenarios. And the last space is what is sentient. Sentient is omnipresent. You're literally God. You can think of anything under the sun and you can talk about anything under the sun. Doesn't matter whether you have known about it before or not, because AI has to be trained previously to give you the right answers, right? Sentient learns itself. It observes and keeps learning the way you and me do, right? That kind of broadly put, these are the four levels of four classifications of AI that one can think of. We are at the cusp of going from narrow to generic and perfecting it. Next will be from generic to super. Hopefully within your lifetime, it will happen. Within your lifetime, not mine, by the way, within yours. Okay, that's the evolution curve that I want you to keep in mind. And all of us are very, very happy to take any questions that you have as part of this. Thank you very much for hearing me out.
Thank you.
Thank you for such a profound talk, sir. Before I request our next speaker, Mr. Rohit Bharadas, to lead the session, I take this opportunity to introduce him first. Mr. Das is the partner, Cyber and Data Security Protection at Grant Thornton, Bharat LLP. He's a risk consultant professional with over 17 years of experience. He holds an MBA in Finance and Marketing, as well as a degree in Electronics and Telecommunications Engineering. He has extensive experience in leading and delivering projects in the IT, ITES, BFSI, and public sectors, including cybersecurity and strategy, project risk and vendor risk assessments, ISO-based risk assessments, and organization risk maturity assessments. He is also knowledgeable in control and vulnerability assessments, configuration reviews, business continuity planning, and disaster recovery projects. The stage is all yours, sir. Please, if you could shed some light on studenthood.
Thank you so much. First of all, it's a real pleasure to be back into the campus, and I must say it's lovely to be here. And afternoon sessions are very, very tough, and I do understand why we say that time and again. But with the limited time that I have, I want to sort of first congratulate the entire faculty to be conducting such a session. It's a brilliant initiative to ensure there is a constant interaction between student community and also the industry bodies. And I think it should be done more frequently, which I'm sure you already have as part of your overall curriculum. Coming to the topic, right? So first of all, last session, so I just want to give you a quick question from my end. Who and all have seen the movie Terminator? Quick raise of hands. Okay. I'm surprised that quite a lot of you have not seen Terminator, but yeah, I'm sure the reason I asked this question is simply because I'm trying to correlate what artificial intelligent or artificially intelligent system could really do in an environment which is getting advanced as we speak, right? So as we already know, you are already we did talk about the assignments being tried from ChatGPT to start with, and we already know that you are familiar with ChatGPT. My next question to you is that how many of you are aware that starting from January to as we speak, there are 200 plus books being co-authored by ChatGPT, which is sold in Amazon bookstore. very interesting fact. And I think that's the kind of, traction that we are having using ChatGPT, right? So, content generation, we talked about marketing, we talked about strategy, we talked about analytics. So if you really look at it from that way, what is really happening, right? You're all technology students. You know Java, you know C++, you would know, C#, all of that. But mind you, where we are going towards is English is going to be the new programming language, right? So when I say that, what I'm trying to say is that, it's becoming far more artificially intelligent systems being connected to each other. And we have to be cognizant of the fact that things are going to be connected, right? So we are, as we know, 5G is already here. Things are going to be far more interconnected. You already use a 5G mobile phone. You have your, Apple smart TVs. You have your system within your home, your office premises, and also in case, even in your universities. So things are far more connected in our environment. In such a situation, how are we ensuring that we are safe, secure, at the same time, all the data controls and other things are being handled from all the sides? So the reason I bring in a different perspective is I lead cybersecurity for Grant Thornton, and it's important for us to be talking specific areas of ensuring that the transformation in artificial intelligence is also being taken from a different perspective of ensuring that the security related aspects are considered from all the angles, right? How can we ensure that we use ChatGPT or similar AI technologies for ensuring national security? It's a very pertinent question, right? I'm sure the defense is already into it, and they already have their own sort of AI driven tools to ensure that we are much ahead of our, neighboring countries or any other competitors, and for anyone for that matter. So it's important for us to be ahead of the game. So that is one of the fundamental premise which is sort of driving the technology. On the second side, what we also see is that we time and again ensure that we are using things to advance ourselves. But at the same time, we have to be cognizant of the fact that what are the associated risks and controls which are really being put into the systems, right? I'm sure all of you would have used ChatGPT to even write a small code, right? At least a small, hello world or something of that sort. I'm just giving a random example, but you would have used ChatGPT. But with the same ChatGPT, you can also generate a malware or a ransomware. You would have heard about ransomware attacks being happening on XYZ organization, all of that, right? And it is a live use case. One of my team members has already done it. You can use it. So basically the idea is it's all can be used in both the sides. While you can use it ethically as an ethical hacker or an ethical attacker to ensure that this can be used and ensure that sufficient controls have been put into it. At the same time, can also be used in the other side, right? Now, another perspective I also want to bring in is threat intelligence. As we are proceeding, we are getting into a far more connected world. It is important that we are aware of what kind of threats are hitting our, nation or organization or any other, perimeter for that matter. From that angle, it is important to be updating ourselves, our systems, configuring our systems, and so on and so forth to ensure things are far more secure. And that's where systems or AI-driven tools like ChatGPT at the moment is not really capable of that, but eventually they will be, right? So I think so those are the fundamental premises that I've come across, and of course I would like to conclude with a statement that post-COVID we've all come to a situation that you would have worked from home for a lot of time, or you studied from home, and geography had become history for and it still continues to be. But at the same time, what we have time and again realized is we have to responsibly use technologies. That applies to ChatGPT as well, right? And when I say responsibly, ensure that what are the capabilities, ensure that we use it in the right sense, use it for our advantage, and use it as an enabler. And of course, it can't take away jobs. It's all, we have been time and again saying it will generate jobs, right? So as Mr. Samir has been already talking about, Mr. Narula already talked about. So it will lead new jobs, right? 1970s, 1980s, computers came into the picture. We shifted. All of us had this apprehension. Now, newer technologies will come into picture. So this all paradigm will shift time and again, but it will generate newer jobs. And that's where the humans who are really trained to use AIs will be more relevant than humans who are averse AI. Right? I think that's all I had. Thank you so much. It's a real pleasure to be in the campus, and thank you.
Yeah, students. So I think there were a lot of points that came in, and obviously everyone has pointed out that we are going to be staying relevant in spite of the technology moving ahead with leaps and bounds. We will still be there, right? So with that, I would now like to open this session for 1 or 2 questions, as we are slightly short of time. Valedictory is about to start, but then can we have 1 or 2 questions if someone has? Yeah, please go ahead. Can you pass the mic there? We'll take another question, so someone can be ready with the next question. Okay, good. So we have the other student also.
Good afternoon, guests and faculties. Myself, Raj Krishna, from student of 4th semester, computer science department. So I have basically got 2 questions. I had a couple of questions, but to cut it short, 2 questions. So are you, as a CEOs and heads, are you allowing your employees to use ChatGPT inside your company, or is there any relaxation, or companies are not allowing in that perspective? And the second question is, there is a constant fear among all the students of different years that continuous layoff is happening in all the major companies. So what is the main reason behind those layoffs? Is that the ChatGPT or things like that coming on, or is there any other reason? So I want to know your point on those layoffs. Thanks.
I could probably start, and then I'll request my fellow panelists to also chime in. So yeah, so I think as far as the restriction goes, right? So we are not restricting anyone to use anything for that matter. But we really encourage everyone to start using newer technologies. The idea is that we have to ensure that we know what is happening and be prepared for it, right? And when it comes to professional services for firms like ours, we are one of those pioneers, or we create these cutting edge technologies on one side. So we have to be ahead of the game. So from that standpoint, we are not averse any technology, right? So that I'm talking from my standpoint. I'll request others as well. And probably we can take the first question first and then go to the second, or?
Thanks. So for us, we are not allowing our employees to use ChatGPT. As Kirti mentioned, that it's still evolving. Right now, when you don't have the clarity that when you are using it for assignments, if it is giving you the right data or not, how can an organization like ours, which is betting billions of dollars for our clients and producing very quality work for them, it's not being allowed. It doesn't diminishes the value of ChatGPT. It has other use cases, but we are not allowing that. That's one. Second is to your question of layoffs happening. Layoffs are not happening because AI is evolving. Layoffs are happening because of different market dynamics. And that should be the last thing that should play on your mind, because you are all fresh talent. The more you learn, let's say doing certifications, ensuring that you have practical learning, the more relevant you will be to the market. For people like us who are getting older, I think those are the people IT industry is saying that, look, give room to this fresh talent which is coming in the market now. So don't fret over these layoffs which are happening in the market. I think this is a very interesting time. This is a very exciting time for the IT engineers, because one is your learning platforms have evolved so extensively. Everything is now available at a click of a mouse. So please be mindful of that. There is a bright future ahead for everyone. Only those who will not find a job in the market would be the ones who are just very, very basic, who do not have the professional skills, who do not have the communication, and who do not possess an edge over the next person. That's the only thing. And if you are putting focus on learning, I don't think so you will. I think organizations have a very strong campus hiring strategy, and they are coming to campuses to hire more and more people. So that's my take. I'm sorry I took a little longer. Maybe you want to add anything?
Just to your point of whether organizations are allowing use of ChatGPT or not. I don't know if you have read the news. There is recently a class action lawsuit in the US for solutions which were developed using ChatGPT violating copyrights. Right. So if you are a business who's putting out, as you know, Amit ji mentioned, if you're a serious business and you're interested in making sure that your product does not violate any copyright or infringe on anybody else's IP, today ChatGPT is not ideal. Maybe tomorrow it will become, when people like you come in and remove all the problems that a solution like ChatGPT has. That's the simple take on that. And I echo what Amit ji was saying. Job loss is not because of technology coming in. Job loss is because the way market and businesses have been for the past decade plus. I passed out in 2001. There was a dot-com bubble in 2001 when there were no jobs. I've seen another recession in 2008 where there was job loss across the spectrum. And this is the third such time I'm seeing that. So don't worry about job losses as such. If you know the right thing, people are always happy to pick you up.
Okay, I think your question is sufficiently answered. So I'll just try to actually appreciate you, because, you know, it's very important to stick out your neck and ask a question and be visible. And, you know, if you're a person like that, you can walk up to us and be that visible, then you're not worried about the job loss as such, you know, because these are the qualities every organization looks at. Then the second thing I'd like to comment on where this question is coming about. So you have a worldview on what an organization is. So let me turn it around and try to give you some kind of a stretch question here. So you could have asked me, is it allowed that you can laugh in an organization? So you know what, we're not against all of that. It's just that we're trying to do a serious business. If it is not coming on the way of that, then everything is allowed. Of course, I remember the same person, me. I mean, I was much against allowing YouTube and Insta in the earlier days, and we had put some IP routers and stuff to not let it work. But today, as we speak, just on ChatGPT, my R&D team has told me that they were actually working on it for last some 3-4 months, and they have a product demo that they're going to give me utilizing ChatGPT. So you know what, don't see this relationship as an employee-employer relationship. It's become much more like, you know, you are a gig worker, you think like that. So anything which makes sense, you should actually stick out your neck, talk to someone about it. Okay, don't look at the older rhythm of somebody asking you to do a certain job. My take is that.
So do we have any other questions? Because now
One
we really have
last
to- one
question
last
we will
question we
take.
can take.
Can you be very crisp, Peter? Yeah. Can you just stand up?
And also say who from the panel you would like your question to be answered.
A very good afternoon, everyone. I'm Shashwat Sharma. I'm a second year undergraduate student at BTech IT, Amit University. I have only one question here, and that is that somewhat we relate this particular advancement to the earlier advancement, but rather it be the .NET revolution, or before that, the banking revolution. But what I think is that, like as you said, that new jobs will be created if some jobs will be gone. But I'm not kind of like identify or figure out or list some jobs that which can be created, because not everyone will be that much compatible to, you know, learn AI or beyond the higher tech side. And in addition to this, as we see the technological advancement curve, it is kind of e to the power x. It means like kind of slope is continuously increasing with time. So the time is less, and the advancement is much high. It means adaptability is quite low. The normal person will not be able to adapt at that much pace at which the technology is being growing. So what's your views on that? Because I think that in the .NET revolution there was time, but as soon as the technology advances, the time will become shorter and shorter.
So may I request Mr. Nigam to please, if you can answer this question.
Looks like another heartfelt question here. So, okay, now, so the gist of your question looked like that, how can you as a person flex yourself into everything IT while it is moving at a fast pace? Okay, so, and then jobs may not be lost, but how do you participate in that? You're probably saying that, yeah. So, okay, so let me try to tell you what you can do here. And it's a very clear formula. The first thing is that the initial stage of job competition that you will get into would be more of a rejection round. It's not a selection round. So we're just trying to find 5 good people, I mean, some companies looking for 100 good people. So you'll have to perform in something which is a skill, anything, what I'm hiring today. So I'm hiring you today for a Python doesn't mean you're not my next business development manager. Now that's how the jobs are morphing. So if you work for a company where, and you know what, within the company work for a relevant boss, then you will see that he will have something. And you remember that quote I gave you, the grunt work. If you are able to perform that, then you develop what is called trustability and then some transferable skills. So I'm sure you might not have understood the full question. If not, then feel free to connect with me on LinkedIn and we'll talk about it. Small thing is that all of us who are sitting here, especially, I mean, I can talk about myself. So I wanted to, I was working in TCS, pretty sensible role there, but I was not rising beyond where I could. So I was trying to compete. So I used to go to my boss and he saw that I'm coming daily to him asking that, give me some extra work. So one day he told me that, you know what, I'm going to give you a very, very important work. And what was that work? So he said, we were in London office. So he said, you know what, take this document. It's a very important document. Go to Brick Lane, get it printed. And that's really very important. So, you understand the printing is really not that important, but to gain his trust, you have to work on all the parts. Now, one thing led to the other. And, he started giving me more meatier assignment, which are not really relevant to an IT person. I was an IT person. So I learned all my business development under him. So you have to think a little lateral here. And the first round is rejection. So better compete with someone on one skill, do well in your academics. That's the easiest advice I can give you. And keep talking just the way you are. You're already a little differentiated, So many of us know his name already, isn't it that?
I'll just add one last thing to what Mr. Nigam mentioned, and I think you have mentioned some critical points, that from an industry perspective, earlier we were looking at SMEs, people who had good experience and how they would evolve. But now we are looking at versatilists, people who do not have deep understanding of one technology, but they have understanding of different technologies at different levels. So you do not need to be 10 out of 10 on each and every area. So don't worry about that. Even if you are 2, 3, or 4 out of 10 in different areas, so you have that versatility. So that's also going to help. That's where I'll stop. Yeah.
So unfortunately, we cannot continue the session for long now. We have to cut down on the question answers. However, you are most welcome to get in touch with them on LinkedIn. And with this, I always keep saying it's 1 hour is too short a time for all of you stalwarts to be in the podium and to say whatever you wanted to say. One hour for 4, 5 speakers is too less a time. We look forward to invite you again in person, but probably for a longer session or online for a longer session. So would like to thank each one of you, Mr. Nigam and from BCG and from Kirti and Mr. Das, all of you to have taken time off on a weekday afternoon, being here with us, addressing our students. It has been a wonderful and power-packed session. And with this, of course, thanks to the students, you have been a wonderful audience, and thanks to team members for helping to put this show together. With this, I would request the panel members to please step forward. We'd like to present you with the mementos, and then we will have one group photograph before we close the session.
Can we have a round of applause?
May I request the Amity leadership team, Professor Dr. Pandey, Professor Dr. Abhay Bansal, Dr. Natasha Hasteen ma'am, to kindly join us while we want to present the token of appreciation. Mr. Rohit. Mr. Samir, Mr. Ramit, and Mr. Kirti. We are so thankful to you for sparing your valuable time.
will have Dr. Sean McLean. VC ma'am agar aayi to we will have VC ma'am. Or we like हाँ सर आप
Hello. Huh. Hello. Hello. Yes. Hello.
Hello, sir. We are
Oh,
about
hi.
to start soon.
All right.
So Dr. Jang, we are going to start within a couple of minutes.
Okay. All right. Thank you.
Warm greetings, Dr. Mark.
Yes. Hi.
Hi, thank you. Thank you so much for being here. We are just starting the proceedings and we'll invite you whenever there is your time. Warm
All
greetings,
right.
Dr. Schuler. Thank you so much for being here.
Yeah, my pleasure. My pleasure.
Thank you. Thank you, Dr. Schuler. We are so happy to have you here.
Same here.
Thank you. We will just begin the proceedings of the closing ceremony and you will be hearing us all. And whenever, there's time, we'll extend you an invitation for invite. Thank you so much.
Thank you so much.
Warm welcome.
Thank you.
A very blissful afternoon to all the respected guests, dignitaries, scientists from India and other nations, faculty members, and students. I, Harshita Moga, and my co-host Siddharth warmly welcome you to the closing ceremony of the Third International Conference on Information Technology, InCITe 2023. The theme for this year's conference was Decision Intelligence, Transform Your World. On behalf of the entire MIT family, we are honored to have you all with us.
We welcome all the distinguished guests. InCITe 2023 conference kicked off with great enthusiasm as leading academicians and industry experts came together to create an ambience of knowledge. As the day draws to a close, we approach the conclusion of this event, yet the inception of new relationship forged on the bedrock of extensive, profound educational knowledge. We would like to extend our congratulations to all those who through their tireless efforts made InCITe 2023 a resounding success.
Saraswati Mahabhage, Vidya Kamal Lochane, Vishwarupe Vishalakshi, Vidyam Dehi Namastate, which means, O great goddess Saraswati, you personify knowledge. Shower me with all the powers and glories to assimilate the knowledge. Gathering here today to invoke the blessings of the divine, this symbolic gesture serves as a constant reminder of our unwavering dedication to the quest for knowledge and the pursuit of excellence. I now request the dignitaries on the dais to kindly step forward to light the lamp.
Thank you, everyone. Amity University values the importance of diversity and culture, and we take immense pride in our hospitality. As a symbol of our gratitude and commitment to sustainability, we have the unique tradition of welcoming our esteemed guests with a sacred Tulsi sapling. This small yet meaningful gesture not only reflects our appreciation for our guests, but also embodies our pledge towards promoting a green environment. It's a beautiful way to express our respect and gratitude towards our guests to make them feel special. I request Professor Dr. K.M. Soni, sir, Deputy Dean, Engineering and Technology, to present our sapling to a guest of honor, Dr. N. Ranjana, ma'am, Scientist G, Directorate of System and Technology Analysis, DRDO.
I request Professor Dr. Manoj Kumar Pandey, sir, Joint Head of MIT School of Engineering and Technology, to present a sapling to a guest of honor, Dr. Sean McLoone, sir, Director, Center for Intelligent Autonomous Manufacturing Systems, Queen's University, Belfast, UK.
I request Professor Dr. Balvinder Shukla, ma'am, Honorable Vice Chancellor, Amity University, Uttar Pradesh, to present a sapling virtually to our guest of honor, Professor Bjorn Schuler, sir, Imperial College, London, UK.
Yes. So, thank you very, very much for giving me this honor of being your guest here. It's very fortunate that I can't be here in person. I would really enjoy very much to see the campus and the great place of MIT University in Uttar Pradesh.
Thank you so much, Dr. Schuler. We will soon be inviting you for your address as well after we, welcome all our guests with the sacred Tulsi sapling, which is a custom here in India. So we'll soon invite you for your address. Yeah, thank you. Thank you so much.
I request Professor Dr. Manoj Kumar Pandey, sir, and Professor Dr. Abhay Bansal, sir, Joint Head of MIT School of Engineering and Technology, to present a sapling virtually to our guest of honor, Professor Dr. B.K. Murthy Sir, GM Projects, InCITe CSC Data Services Limited.
I request Dr. Natasha Hastir ma'am, Deputy Director Academics and Head of Department of Information Technology, to present a sapling virtually to our guest of honor, Dr. Zhongfei Mark Zhang Sir, Binghamton University, United States.
Thank you very much.
Thank you all. Now, we are honored to have with us today the distinguished presence of Dr. Natasha Hastir ma'am, the Deputy Director of Academics and Head of Department of Information Technology, who has also served as the Conference General Chair of InCITe 2023. With a wealth of experiences spanning over 23 years in both industry and academia, ma'am has been an inspiring figure for all of us. Her tireless commitment, exceptional attention to detail with all her endeavors are truly commendable. We extend a warm welcome to Dr. Natasha Hastir ma'am, who will be sharing with us the highlights and delivering her the welcome address.
Thank you. Thank you so much, Siddharth. So, a very good evening, ladies and gentlemen, and all my dear students here, esteemed guest on the dais, and one and all present here. At the outset, on behalf of our most respected founder president, sir, Dr. Ashok K. Chauhan, the founder of Ritnan Balved Education Foundation, an umbrella organization for MIT Group of Educational Institutions, it is my utmost privilege to welcome you all to the valedictory session of the 3rd International Conference on Information Technology on the theme Decision Intelligence Transform Your World. IT has become synonymous with the growth and development of the nation. Those with the greatest and the newest technologies are the people who grow, and those who are stuck in time are left behind. Through AI and decision intelligence, technology has enabled us to become more and industry experts from across the globe for this two-day international summit. It has been a great experience and equally laudable to kindle the literal flame of knowledge, which will act as a powerful lighthouse for all of us who aspire to do something prolific in the field of IT. We are extremely humbled to have the august presence of our distinguished guest for the closing ceremony of this two-day international conference. I extend a very warm welcome to Dr. Bijon Schuller, Professor, Imperial College, London. Sir, we are extremely honored by your kind presence in this valedictory session and your insightful talk around deep learning-based audio processing that has highlighted several innovations and breakthrough in the field. It is indeed an honor to welcome Dr. Zhongfei Mark Zhang from Binghamton University. Thank you, Dr. Mark, for being here. You have always supported us in all our endeavors, and we are grateful to you for that. We warmly welcome you. We extend a hearty welcome to Dr. N. Ranjana, Scientist G, Director, Directorate of Systems and Technology Analysis. Thank you, madam, for accepting our invitation and being here with all of us. We warmly welcome you. It is my proud privilege to welcome Dr. B.K. Murthy Sir, GM Projects at InCITe CSC Data Services, who has been a strong pillar at Ministry of Electronics and IT. Sir will be joining us online very shortly. We warmly welcome Dr. Sean McClune, Director, Center for Intelligent Autonomous Manufacturing Systems, Queen's University, Belfast. Dr. McClune, we strongly believe that once an Amitian is always an Amitian. And we are glad to welcome you as our honorary professor to this closing ceremony. Now, may I request all present in this hall to please put your hands together for all our esteemed guests this afternoon. We extend a very warm welcome to our most respected and honorable founder president, sir, Dr. Ashok K. Chauhan, sir, who will be joining us shortly. We welcome our respected honorable chancellor, sir, who's watching us live. And we also welcome our honorable vice chancellor, Dr. Balwinder Shukla, ma'am, who's watching us live. A very warm welcome to Deputy Dean Engineering and Technology, Dr. K.M. Soni, Joint Heads of ASSET, Dr. M.K. Pandey, and Dr. Abhay Bansal, and all the head of the institutions and departments who have joined us today. It is such a pleasure to welcome you all to the valedictory session of InCITe 2023. We are proud to share with all our guests today that MIT Education Group, being a leading global brand in education, has a focus on quality research innovation and has established 12 universities in India and 17 campuses abroad. Amity University has been ranked 22 among universities in the India Ranking 2022 as per National Institutional Ranking Framework, Ministry of Education, Government of India.
Please put your hands together for your own university, which is doing so great wonders. The stupendous achievements of our university has been possible because of the vision of our most respected founder president, Dr. Ashok K. Chauhan, the founder of Amity Education Group. At Amity, we are passionate about educating young minds to take new initiatives and to build a strong foundation for national development. Dr. Chauhan has given us a mission to transform every student of ours into a success story and to strive for outcome in every endeavor. And we are very happy to have the presence of one of our alumni today from us, among thousands of alumni who are so successful in their lives. Ms. Kritika from Narcotics Control Bureau. I request Kritika to please stand, and I request all the students of IT here. Kritika is a BTech Information Technology student from 2005-9 batch. So she is coming to her campus after 14 years, and that calls for a huge round of applause. Thank you. Thank you so much. We are sure your coming back here today is adding a lot of joy to our Honorable Chancellor, Dr. Atul Chauhan, sir, who's passionate for holistic development of our students, and he motivates us to excel. Thank you, Kritika. At Amity, there is a commitment to provide opportunities for broadening students' educational experience beyond classrooms. And international conferences on cutting-edge technologies is one such endeavor of ours to give the best learning experience to our students. And we thank our Honorable Vice Chancellor, Madam, for motivating us in this direction. For InCITe 2023, we acknowledge Science and Engineering Research Board, SERB, DST, and Department Defense Research Development Organization, DRDO, for sponsoring the event. And we cherish the long-standing associations with these organizations in the past. We also convey our gratitude to our academic partners, Center for IT and National Development in Africa, University of Cape Town, South Africa, and Clouds Lab, University of Melbourne, Australia, Lawrence Technological University, US, University of Pretoria, and Center for Intelligent Autonomous Manufacturing System, Queen's University, Belfast. We thank our professional partner, Computer Society of India, for support. With utmost gratitude, we thank all our collaborators, our supporters who have joined hands with us to make this event highly engaging and insightful. Technology is expanding at a breathtaking pace. To keep up with this dynamically advancing field, we have to continuously evolve. The conference provided a platform to all of you to discuss significant innovations in the field of decision intelligence that is poised to enhance research and applications in the future. We thank and commend the distinguished scientists, renowned academicians, and leading industry experts from eminent institutions across the globe who associated with InCITe 2023 to begin and foster a beautiful relationship. This conference has provided a platform and impetus to discuss opportunities, endeavors, and directions of innovative research that will benefit industry and the academic community. While we welcome you to the closing ceremony, we also extend gratitude to all the participants, invited speakers, advisory committee members, reviewers, delegates, faculty, and students, most importantly, for making it possible. We thank you all for giving us your best minutes and pivotal support. We hope that each one of us will keep the flame burning and impart one's maximum from what we learned during this international scientific conference. Once again, a very warm welcome to you all to the closing ceremony of InCITe 2023. Thank you so much.
Thank you, ma'am, for the wonderful welcome address. It is a privilege to have with us Professor Dr. Abhay Bansal, sir, Joint Head of Institution, MIT School of Engineering and Technology. Sir is a man of focus and is passionate about internationalization. He is a role model and a source of inspiration to all of us. With this, may I now request sir to please address the attendees.
Thank you. Thank you. On behalf of our most respected founder president, Dr. Ashok K. Chauhan, whom you have heard in inauguration session also, he was available for full session. That shows how much he is interested to see the development of our students, right? So please put your hands together for Honorable Founder President. And also Honorable Chancellor, who is not there, but he has got some meetings. He has sent all the best wishes to all the students and all the delegation for their contributions. Please put your hands together for him also. So on behalf of MIT School of Engineering and Technology, I welcome Professor Zhang from Birmingham University. Please put your hands together for him. And dear student, you could see a different time zone. He is at the moment, it's late in the night, but his presence during valedictory sessions shows that international experts, speakers, how much interest they have, who would like to support MET, who would like to support each one of you, if you are interested. And for your reference, as Dr. Natasha has also mentioned, we have 170-acre campus in US. And Professor, we look forward to have your visit to our US campus, which has been made in Long Island next to New York. And we have another campus in San Francisco also. So thank you very much. I also welcome Dr. Seen, Director, Center for Intelligence and Autonomous Manufacturing System, Queen's University, Belfast. Dear student, we had a lot of discussion with him that how his presence, his motivation, his mentorship can help you to make career in UK. So we have worked out a lot of program with him so that you may get some internship projects, semester, year in UK, by which you can have wonderful career, not only in India, outside India also. So please put your hands together. And I'm sure Professor will look forward many more. Many more of our students could be before next InCITe in UK. I also welcome Dr. Murthy, who is GM project with Nixie CSC Data, and who is also scientist G. Dr. Murthy, we welcome you. Thank you very much for your kind presence. We also have Dr. Ranjana, who is scientist G with DRDO. Thank you, madam, for your kind presence. This conference is also supported by DRDO, and you will be happy to know, please put your hands together for us. You'll be happy to know MET is the first university of the country who started MTech in Defense Technology program. And now we have started MTech. And this is because of blessing of our honorable founder president, because he always say, we must give opportunity and we must support our country so that we can be the strongest country in the world. And we must have very strong defense system, for which this program was launched. And first batch got 100% scholarship by founder president. And we have got very good response. So please put your hands together again for founder who has such a vision for a country. I also welcome Professor K.M. Soni, who is Deputy Dean ENT. Thank you, Professor Soni, to be with us. We also have Professor Schuller from Imperial College London. Thank you, Professor, to be from Imperial College London. Just to mention here, we have around 50 students who are in London, and I'll request them. I have heard your keynote. Even students who are in MET London, they have also heard your talk. They were so happy and they are so interested. I'll try to arrange their meeting. They could visit to you in Imperial campus. And dear student, if any of you are going in a study abroad program, or any program which MET is organizing in London, you must make a plan and visit Imperial College. It has world-class infrastructure, and I'm sure area in which professor is working, it can have a lot of encouragement, support, and guidance for you all. Please put your hands together for him also. And for reference for everyone, dear student, you are also aware that we have offered a lot of honors specialization in cloud computing, computer network, data science, AI, with the purpose that students should be make available. You know, you have heard industry, a lot of demand is coming on disruptive technology, and with these honors specialization, we want each one of you to be industry ready. In inaugural session, you might have heard about Honorable Founder President has also announced one club. I'm sure you all remember that name. What is that name? It is Founder President Club for Aspirational Budding Engineers. You know, and starting this, he has always given us mandate to all of us, so that each student of MET must get more than their dream and desire. So this is something which we want, and if you become member of this club, we will discuss and work with you separately how you can get job into the best company in the world with best salary, which I'm sure you all are looking for, you always aspire for, and with blessing of Honorable Founder President, which himself he has shown a success story where he has gone to Europe with 3 sterling pound, and he was the biggest investor in Europe, and he came back to India, and you could see MET now having 11 campuses in India. Do you find any education grip which has so many campuses? No. And now we are coming up with 1 campus in Hyderabad, another in Bangalore. So 2 more campus, and we are going to have 30+ campus in next 5 years in India. We have 17 global campuses, and this is not end. You may not find any university of Asia, and you all should be proud. And we have a target for next year. Yes. We have got target for next 10 years, 50 more campuses all over the world. So you go anywhere outside India, you don't have to tell what MIT is all about. And it is up to you, I'm sure, with such a learned speakers, which we have got from so many countries, so many researchers. Dear student, it is your responsibility to do networking with them, understand their expectations. And I'm sure if you work, we want to make a difference, because any conference, any activity we do in MIT, we want to see the outcome. And outcome of this conference, we expect that many of you should take advantage of such a learned speaker. And otherwise, if you go and you want to meet Professor Seen, even he was telling, he is getting 500 emails every day from students who are interested to meet him, would like to do project with him. And he said, I don't have a time to see these 500 emails, but I'm sure if you say you are from MIT and if you have his photograph with you, I'm sure he will recall, recognize, and he will reply your mail. Right, Professor? So that is the commitment he has done. So you should establish, so you all should make an established connection on LinkedIn with all the learned speakers and say you are from MIT. I'm sure they all will be your mentor, your guide, and will make difference in your career. And I have seen in past students who have done contact with these professors, it's a life-changing. I have seen professor came from UBC, Toronto, Cornell, and those professor recommendation has made a difference, and they got admission in UBC, Toronto, Cornell, Stanford, which you may be thinking is a dream for you to get an admission, but it has been made possible because of your collaboration with top university professors, and for which we look forward. And congratulations to Dr. Natasha and hardworking team of Department of IT and all student volunteer day and night. Please put your hands together for them. And we all say it is a beginning of our relationship to all professor, industry persons. Many things are there in the times to come, because we are outcome based and we look forward to see many outcomes. And good to see Kritika, our alumni. You know, it's always good. And founder president always says, MITians should show to the whole world they are the best. And I can tell you, you go to any country in the world, you go to Amazon, Google, Microsoft, you say I'm from MIT, you'll find 50 more are there in the same floor, in the same building, and you will always cherish that. That is what MIT is, not only in India, all over the world. And I'm sure, dear students, you all are going to take advantage of that. With this, wish you all the best, and thank you all the professors and industry persons for their contribution. Look forward. Thank you. Thank you.
Thank you, sir, for gracing us with your enlightening words. Now we feel extremely privileged to have with us Professor Dr. K.M. Soni, sir, Deputy Dean, Engineering and Technology, with over 23 years of experience in teaching and academic administration, including roles such as Head of Department, Head of Institution, and currently Deputy Dean of Engineering and Technology. Sir brings a wealth of knowledge and expertise on the table. May I now request sir to kindly address the gathering. Please, sir.
Thank you. A very good afternoon to all of you. Please awake. Persons on the dais, off the dais, eminent speakers, delegates, university officials, HOIs, colleagues, faculty members, alumni, and my dear students. On behalf of our most respected founder president, Dr. Sukhi Chauhan, very dynamic Chancellor and President RBF, Dr. Atul Chauhan, on Vice Chancellor, Dr. Balanda Shukla, and Domain of Engineering and Technology, I welcome you all to this valedictory ceremony of InCITe 2023. It's a privilege to welcome our guest of honor, Dr. Jeng, Dr. Srimati Ranjana, Professor Dr. John B. Solar, Dr. Sheen McLoone, who is also honorary professor at AUP Noida. It's a great pleasure for us to have as our guests. We warmly welcome you and look forward to hear your valedictory session. I also extend a very warm welcome to Honorable Founder President, Honorable Chancellor, and Vice Chancellor Madam, who is watching this session of this event online, and also other officials of the university. Without their constant guidance and support, this international conference would not have been possible. With the blessings of our most respected and beloved Founder President and Chancellor Sir, We Amitians are extremely proud that Amity University in just 17 years has won a deserved place among the top universities in India and abroad. The long list of distinguished speakers from around the world who have been deliberated in this conference is a testimony to our global recognition and rankings. Domain of Engineering Technology is having more than 6,000 students and 300 faculty members, offering programs at UG, PG, and doctorate levels in various core disciplines and specialized areas such as nuclear science, space science, aeronautical engineering, solar and alternate energy, electrical vehicle, drone and defense technologies. And our students and faculty members are doing research in the cutting edge technologies, includes AR, VR, AI, ML, cloud computing, data security, data analytics, image processing, robotics, mechatronics, and so on and so forth. And we are offering minor degrees, honors specialization, and master degrees program in these areas. The engineering technology domain keeps us with the rapidly changing technology by organizing conferences on latest cutting edge technology. InCITe 2023 is one such endeavor where over the last 2 days we have deep insights into the several developments in the areas of IT through various keynote addresses, invited talks, and paper presentations, and have interacted with eminent researchers, scientists, and technocrats from academia and world. I would like to this opportunity to thank our Honorable Founder President Sir, our Honorable Chancellor Sir, and Vice Chancellor Madam for believing in us and giving us this platform for the benefit of one and all. On behalf of Engineering Technology domain, I once again heartily welcome you all to this collective ceremony and thank everyone for their continued support. At last, my heartiest congratulations and appreciation to the organizers, especially Department of IT and team. Thank you.
Thank you, sir, for enlightening us with your words. Now, to unfold the story of success of InCITe 2023, I take this opportunity to invite Professor Sunil Chaudhary, sir, Organizing Secretary, InCITe 2023, to present a brief summary report of the event. Please, sir.
Thank you, dear. Very good.
So, good afternoon, respected dignitaries of the dais, on the dais, dear colleagues, alumni, and dear students. I, Sunil Kumar Chaudhary, the Organizing Secretary of InCITe 2023, hereby presenting the report of InCITe 2023. So, Department of Information Technology, Amity School of Engineering and Technology, Amity University of Uttar Pradesh organized the 3rd International Conference InCITe 2023 on the theme Decision Intelligence, Transform Your World in Hybrid Mode. The 2-day enthralling conference was organized in association with Center for Information Technology and National Development in Africa, Standard University of Cape Town, South Africa, Cloud Computing and Distributed System Lab, University of Melbourne, Australia, Center for Intelligent Autonomous Manufacturing System, Queen's University, Belfast, UK, Lawrence Technological University, USA, and University of Pretoria, South Africa, DRDO, DST as our sponsors. The conference was supported by SERB, DRDO, Government of India's industry partner also, and Springer as our publishing partner. InCITe 2023 has been initiative to ignite young mind and to change of tomorrow as per the vision of our Honorable Founder President, Sir Dr. Ashok K. Chauhan, who himself stands as a visionary leader and inspiration for all Amitians. With high and positive energy, the summit got initiated under the dynamic leadership of Honorable Chancellor AUP Dr. Atul K. Chauhan and boundless support of Professor Dr. Balwinder Shukla, our Honorable Vice Chancellor, Amity University, Uttar Pradesh. The InCITe witnessed more than 50 plus speakers from 18 plus countries across the globe, include world top universities like Carnegie Mellon University, USA, Lawrence Technological University, USA, University of Texas, USA, Binghamton University, USA, Humboldt, Berlin, Queen's University, UK, University of Surrey, UK, Manchester Metropolitan University, UK, Lincoln University, New Zealand, Brandon University, Canada, University of Milan, Italy, to name a few. During inaugural ceremony, honorary professorship was conferred to Dr. Sean McLeod, Director, Center for Intelligent and Autonomous Manufacturing System, Queen's University, Belfast, UK. MIT Young IT Achievers Award was conferred to Ms. Akansha Jain and Mr. Mohit Buddhiraja. There had been an overwhelming response for research paper submission, where 505 research paper submission were received on the conference theme and related domains from faculty members and PhD scholars from across the globe. With staggering review process, only 72 manuscripts that meet stringent requirement of the high scientific quality and significance, originality, and priority were selected for presentation during the 2 days of the conference in various technical sessions. All the papers registered and presented will be submitted to the Springer for publication, and published paper will be indexed in Scopus. The guest of honors for the inaugural session were Dr. Roger B. Dannenberg, Professor Emeritus of Computer Science, Arts and Music, Carnegie Mellon University, USA. Dr. Jean-Paul Van Wille, Professor, Center for IT and National Development in Africa, University of Cape Town, South Africa. Dr. Tariq So, President, Lawrence Technological University, USA. Mr. Rajiv Saraiya, Vice President, Coforce, India. Dr. Shane McLeod, Director, Center for Intelligent Autonomous Manufacturing System, Queen's University, Belfast, UK, deliver address during the inaugural ceremony. Through a range of keynote speeches, there are some special sessions like Women in Engineering, Your Innovative Journey as a Women Technocrat, and various industry sessions on the topic Evolving Future of Work, How to Get Yourself Hired, and ChatGPT, a threat to human jobs for tools towards excellence, along with the project presentations of AI and various poster presentations through which audience witness new ways to deal with the challenges faced in the areas of decision intelligence. So the aura of technological eagerness and curiosity continue to the finale of the conference, keeping the spirit of exploration and research high. So we are honored to have eminent professors and dignitaries, which include Dr. Anne Regina, Scientist G, Directorate of System and Technological Analysis, DSTA, DRDO, Dr. Bond Scheller from Imperial College London, Dr. Zhongfei Zhang from Binghamton University, USA, Dr. Sean McLeod, Director, Center for Intelligent Autonomous Manufacturing System, Queen's University, Belfast, Professor B.K. Murthy, General Manager, NICSI CSE, Data Services, and our alumni, Kritika Goyal. So thank you for gracing the event with your presence. Thank you.
Thank you, sir. That was an excellent recap, and nobody could have done it better. Now, it's an absolute pleasure to have Professor Dr. Zhongfei Mark Zhang with us today. Sir is a distinguished professor at the Computer Science Department of Binghamton University, State University of New York, USA. He holds a PhD in computer science from University of Massachusetts and a BS in electronics engineering and an MS in information sciences from Jinghang University, China. Sir's research interests are diverse and include machine learning, data mining, computer vision, and pattern recognition. His research mainly focuses on multimedia, multimodal data understanding, and mining. We feel honored to have Sir with us join live today and look forward to gaining valuable insights and expertise from his knowledge. Please, sir.
All right. Okay. First of all, I'd like to thank the organizers of this conference to give me this honor as a guest of honor to speak here. It's my great honor and the pleasure to be in this position to talk to the audience at this moment. I'd like to begin with congratulating all the audience on being part of this conference. I hope that you have benefited from attending this conference. You have benefited from learning the state-of-the-art research from the speakers, and you have benefited from the interactions and activities of the conference programs. I was told that the great majority of the audience are students. So I was asked to give some insight or advice to the students. You know what? I'd like to do that as I was a student many years ago, and I have been a university professor working in different universities all across the world for many years in the US, in Europe, and also in Asia, right? So I think to be successful as a college student or as a graduate student, you need to pay attention to several things. First, you want to learn to be well motivated, right? So this is always something that I always ask my student to develop during their tenure in the college, in the graduate schools, right? So you want to learn what you want when you leave the college, when you leave the graduate school in the real world. You want what you want to be and what you want. So this is something very important. With a good motivation, you can achieve your goal. So basically, in the real world, basically we are all doing based on the goal-oriented action, right? So this is something very important. Also, you want to learn to develop your interest and curiosity. So these are the key elements to drive your way for your future career development. Regardless of whether you are going to be in the academic area or you are going to be in the industry or whatever other sectors of the world. Interest and curiosity are always the driving force to lead to a successful career. So this is not only from my personal experience. I have also seen many successful examples from my students, from my colleagues, from my friends. So I also think this is something very important. That is something that you need to develop when you are in college or when you are in the graduate school as a student. So that's when you leave the college or leave the graduate school, you are ready to work on your own as a capacity of the professional in your own job. Finally, you also want to develop the capability to do the self-learning. This is also something very important, in particular in computer science and IT related areas, because in these areas, you all know that technology develops so fast. Whatever you have learned in the courses that you have taken in the campus, after a few years, a lot of them might be gone, all right, that they will become outdated. So you will need to develop the adaptive capabilities to adapt yourself to the new technologies, to the new environment. So this is something also very important to let you not only survive in your job, but also to lead you success in your career development. So I think these are the some of the experiences that I would like to share with you as a former student in college and also in graduate school. All right. Okay. I think that's my few minutes speech. Thank you very much.
Thank you. Thank you so much, Dr. Zhang. And so kind of you that you, adjusted your schedule for us and you gave so much.
It's my pleasure.
And we look forward to have you at our campus in person next time, for sure.
All right. All right. Definitely. Yes. It's my pleasure.
Take care of your mother. Thank you so much.
All right. Okay. Thank you very much. Thanks.
We are extremely grateful to have had the opportunity to hear your valuable insights and expertise. Thank you for sharing your knowledge with us today. We are
Thank you.
privileged to have Dr. N. Ranjana ma'am among us, a distinguished scientist G, who joined DRDO at NSTL Visakhapatnam in 1993 and has since worked on a range of critical projects related to naval systems and weapon software. Ma'am's contribution to AGNI system integration and the establishment of the Software Quality Assurance Division at ASL are remarkable. Ma'am was also appointed as Deputy Technological Director of the Reliability and Quality Assurance Division and successfully led the implementation of enterprise solutions like PLM and the establishment of the ASL data center. In recognition of her contributions, Ma'am was honored with the ASL Technology Group Award in 2012 and was later appointed as the Director for the Directorate of Systems and Technologies Analysis in 2019. We now humbly request Ma'am to please address the gathering. Please, Ma'am.
Very good afternoon to all of you, and very happy to see such a young crowd and the faculty here. So let me start by greeting Dr. Abhay Bansal, Dr. Nitasha, who invited me here, Dr. Manoj Pandey, Dr. K.M. Soni, Dr. Makloon, Dr. Murthy, Professor Schuller, Dr. Zhang, we just heard him. And I also greet Dr. Ashok Chauhan, Dr. Atul Chauhan, and Professor Balvinder Shukla, who have been, I think, behind the scenes with all of you and your energy. And definitely, my dear students, researchers who have taken pains to write these papers, and because of these papers, we are here standing in front of you. Very good job done. And I was just going through the brochure of InCITe, and it is extremely well laid out, excellent quality of papers. The topics that you have selected are extremely good, and congratulations for all of that. And I know it doesn't happen so easily. It's, I think, minimum 8 to 10 months of effort which has gone. And I congratulate each one of you, the entire organizing team, the general chair, the technical chair. I know how the process moves and how difficult it is to get to this level today that we are closing on. But then definitely you must be carrying a lot of experience and memories around this. And I think the wide participation around the world from MIT is something amazing. It's extremely good. And I'm very happy to see how you guys are interacting with a lot of people who are, across the world, that so many topics that you have done. So I was just making some notes when we were talking. I was just going through a particular research report, which has just got released yesterday on the technology. Where does India stand today? And if you see in the field of AI, computing and communications, I don't see there is a little connection, but that's what they're, when we go deeper, there is very little connection. They are only applications of each other, but definitely they are clubbed it, thinking that it is what they want to club it with. So in that, if you see advanced radio frequency communication, India stands 5th. And then artificial intelligence and your advanced optical communication, the research, India stands 4th, 3.8% of the research. So similarly, AI, it is 5th with 3.4% research being published globally by the Indians. And this is not just the national journal we are not taking here. So I can go on, and then, there is another set which they have talked about, which is on the quantum technologies. Now, there are major 4 quantum technologies that are parallelly working on. One is on the quantum cryptography, the other one is on the computing, the other one is on the sensors, and then you have the quantum communication. Can you imagine in the post-quantum cryptography, India stands third in the world. And this is really cutting edge. So I think it's all of us who are doing, some of us who are doing all this job to take our country here. And there are certain things on advanced materials, manufacturing. I think you should go through all these things where you stand. And I would not say India has climbed to the 40th rank in the Global Innovation Index of WIPO, which is a huge leap of 41 places in last 7 years. So from the 81, you have come to 40. So definitely we are making waves. Definitely we are making waves. But then I have few points to only give with the permission of all of you. We have what is required more. So before we say what is required more, there is a new education policy, which all of you know, and which has a lot of thrust on the interdisciplinary research. So when you are doing the interdisciplinary research, break the silos between the departments and work together with the disparate fields where the AI could be applied to any Tom, Dick, and Harry thing. So that becomes a product. If you do just the core research, you remain an academician. If you want to make it a product, you want to become a startup, you want to work for a startup, then you have to break these silos and apply this academic work, whatever you are doing, into some application area. This is something which is very well highlighted in new education policy also. And I think government is bringing out very grand plans to improve and move in this direction, that we do more interdisciplinary thinking ground up from the childhood, from the school children. That is something which a lot of work is going on. I think we all will be keeping tab on that what comes further. There is an ample startup base which is making a vibrant economy. Today, we have more than 1 lakh startups. And there is a difference between a startup and a company or MNC that you're looking at. There's a little bit of informality. There is a high technology. There is less bureaucracy where you can convert all your dreams, all your ideas into a product. Now, that's a very encouraging thing which is coming into the country. But what few points I will make is the long-term research is not very, very prolific in the country. We are doing very short-term research. We are publishing papers, but we are not taking that research that, okay, one student did that, the second student also does that, the third year also a student does that, so that we become masters of that. And that is what we need to go to the next step with the organizations like you. We are doing very short-term research. Whereas across the world, if you see, there are the generations which work on that area. If you see something like CMM level 5 or CMMI, all this has come from the single group, and various generations of these standards that come from the same group. Those students have come and gone. So that culture of long-term research is something that we need to adopt, inculcate, and promote, so that we are masters somewhere. Similarly, converting research to a product, a network between industry and academia. And in this sense, I will just talk about DRDO. We opened few centers of excellence, and previously we were just calling them centers of excellence. And we said, no, that's not enough. Academicians alone will not be able to convert the research into product. So we made DRDO Industry Academia Centers of Excellence, a platform where industry and academicians can work together to solve some critical problems. So that is where we say, okay, let's work out on a problem together with all the systems. Similarly, there is, everybody starts looking for some encouragement, some icons, some examples. So a lot of case studies are required, which are basically successful conversion of an idea into something which is implemented. Now, this is the role that educationists need to play, that they have to document these case studies, which inspire the implementation of these ideas, which get converted into the products. They become niche products, some become prevalent products, some apps Today we have taken, in terms of app, the apps have taken the world by the storm. Anybody can create an app, and any common use app, you never know, it will become like a viral thing for everybody to use. So these are the ideas that you have to nurture, try it. Okay, 10 apps fail, 11th will work. So something, but it is very, very simple observation that what you need to do. These are some of the ideas which I thought that you guys should do. And the other thing, I think I'll be just repeating Professor Zhang, sustain with patience. Nothing happens easily. Lots and lots of hard works. It's days, nights. I remember my days and nights when I was working for Agni program. There were days I used to come at 3 o'clock, 4 o'clock and back to office at 9, because the work was like that, you know. So you make a culture for yourself. And if you are in startup culture, this will be your norm. And don't feel bad about it. Take it up. And that's the energy that you have. So all the best. Very happy to be here. Very, very happy to be invited. And congratulations to all of you.
Thank you, ma'am.
Well, we appreciate the knowledge and expertise you brought to the event, ma'am. You said something that everybody looks for a role model. I'm pretty sure that you are a role model to a lot of women out there, and not just women, to every man sitting in the audience. Thank you, ma'am. We are privileged to have with us today Professor Dr. Bjorn Schuler. Sir is a distinguished academician who earned his diploma, doctorate, habilitation, and adjunct teaching professor appointment in machine intelligence and signal processing from TUM in München, Germany. Dr. Schuler is a renowned scholar with a wealth of experience in the field of digital health and effective computing. He has served as editor-in-chief of IEEE Transactional Effective Computing and has been named one of 40 extraordinary scientists under the age of 40 by World Economic Forum. Dr. Schuler has also played a key role in over 15 European projects and worked as a consultant for major companies such as Barclays, GN, Huawei, Informatics, and Samsung. We are privileged to have Sir live with us today, and I invite him to share his profound knowledge and enlighten us with his insights.
Thank you so much, and thank you so much for having me as a guest today, which is an honor to me, actually. Let me start by congratulating you to this wonderful event, InCITe, which has been the 3rd edition, and to me, also as a series, is more than impressive from the content, but also from the audience and the people involved perspective, which often is the much more important part of it. Let me also look forward to seeing Amity prosper in places around the world. I'm really excited to see some of those places, not only in India, but also outside. And indeed, the motto of this conference, Decision Intelligence, Transforming Your World, couldn't have been chosen more recent than it is, because right about now, we really are undergoing a transformation, in particular in AI, and AI transforming the world, which is a great time to be involved in it. Now, I too was looking forward to motivating students and people who are just about to start in this field. It's a great time indeed. People are often talking about AI winter, but I feel we really are in summer right now more than ever before, and staying in summer because we see the exciting times of general AI slowly evolving. We see the uprise of generative AI. But also from a perspective into going into this whole field of engineering, of computer science, AI in particular, you have so many choices these days. You can be an academic, you can be a researcher, but you can not only be a corporate employee, you can also be a corporate researcher, something that hasn't been so broadly available in the past. And you can start up and you can mix and match. So in my department, I have been teaching deep learning with 2 colleagues. Each of us has a company started. Each of us is a professor at the same time. It's very flexible times. And also, of course, it's great times to be in this field. The World Economic Forum, which has just been mentioned, has been ranking #1 computer and information sciences and #2 engineering as the best degrees for jobs of the future. And I feel that is even more true now. What better than know about AI when AI is transforming the world? Similarly, Glassdoor has been naming the 50 highest paying college majors, computer science and electrical engineering. And we know that some of the most valuable companies in the world are all about this business. The top 10, including Microsoft, Apple, Amazon, Alphabet, Facebook, Alibaba Group, Tencent. So you really are in the right field. But what really makes the difference, of course, is to transform the world for good. So thinking about all the challenges that come with decision intelligence in terms of making the right decisions and not endangering ourselves, but yeah, having a mission to save the world, save ourselves. So for that, trustable solutions, ethically responsible solutions will be more than important than ever. So it's exciting times to be young and uprising in this field, not only to make things work better, but also to make sure they work for the good cause. And there is so much potential for working for the good cause if you think of decision intelligence and climate change, healthcare and well-being, which has been a topic here, of course, as well. The aging society, high-risk use cases and environments like in Fukushima, having robots enter after the catastrophe. We also have other crises coming up, shortages of knowledgeable workers, societal change, of course, largely induced also by our solutions. So there's a lot of work to roll up the sleeves and yeah, get active. And to talk about getting active, I wanted to also share some more concrete steps, what you could be doing. Being active is great, and probably the most important, being brave to be active is also super important. Just try the next steps. Don't wait for something as you approach throughout your career. Try to organize, get involved, reach out to the people. We've heard encouragement for that before, but also be fast because these times are really accelerated development as I haven't seen it before. You have to keep au courant, up to date, on a weekly, if not daily basis, and best invest 1 hour a day to just get au courant and check on archive, check on some news feeds, what's happening in decision intelligence, in artificial intelligence, in engineering. The change has also been happening in how we communicate. Today, unfortunately, I'm not in India, which I would so much have loved to be, but I'm still here online, and that is a good occasion also to reach out to people. People have become less reachable as we've heard with 500 emails a day. I have a similar situation, but also more reachable than before, because even when we're not traveling, we can get the chance to meet at least virtually. And it's a great chance to simply be brave and reach out to the people you want to talk to and yeah, get involved with them. So maybe on the final notion, I want to say, don't forget to dream. And dreaming is the most important ingredient in my eyes. Dream of what you want to do, of a better world and how you want to shape it, and then be fast, brave and active to do that. Thank you so much for having me today and hoping to see you all in the real world.
Thank you. Thank you so much, Dr. Schiller. It's such a great learning from you. And I'm sure everybody sitting in this hall is extremely delighted to hear you talk about mix and match and to hear you talk about never stop dreaming. And that's what the vision of our foundation is and what our Honorable Founder Sir has given us. Never stop dreaming. And as you said, you know, starting up your own companies. So there a target given to us to have 100 startups. So that is what, you know, Amity is driving towards, and we are making progress to it. Last, thank you so much. And as you said, you would have loved to be in India. We would at the same time have loved that you come in person. So not this time, maybe in the next edition of the conference, we would be very, very delighted to have you at our campus. Thank you so much, Dr.
Thank you, Professor Schuller. Even we have 50+ students right now. They're in London and they're requesting me. They would like to meet you personally. Right. And there are many students who are planning in April and summer. They're also requesting to pay their regards and see your lab and wonderful work which you are doing at Imperial College. And I'm sure you will support them and mentor them and guide them in future. Thank you very much.
Thank you. Thank you
Thank
so
you
much.
so much. We really look forward to that. Bye.
Thank you. Thank you. Bye. Take care.
Thank you, sir, for sharing your profound knowledge with all of us. It gives me immense pleasure to introduce our guest, Professor Dr. B.K. Murthy, sir, GM Products, Nixie CSC Data Services Limited. Former CEO of IIT Innovation and Technology Foundation, sir, who holds a PhD degree from IIT Delhi, has made remarkable contributions in the field of technology and education. His research interests include artificial intelligence, knowledge engineering, object-oriented design, and software-defined networking. I would like to express a deep gratitude to Sir for joining us today and bestowing us with his invaluable knowledge and expertise. Due to some unavoidable circumstances, Sir couldn't be here with us today. He has sent his best wishes for the event.
Okay, thank you, Harshita. We are honored to have with us today Dr. Sean McClune, sir, the Director of the Center for Intelligent Autonomous Manufacturing Systems at Queen's University, Belfast, United Kingdom. With his expertise in autonomous robotics and extensive research on intelligent systems, including database modeling and analysis, he has made significant contributions to the field. He has collaborated with various industries and have led practical applications of his research. We invite sir to share his experience of the visit to Amity University. Please, sir.
Thank you. Working okay. So, Vice Chancellor, distinguished guests, and I'm pleased to be able to say colleagues, thanks to the very honor that they bestowed as a professor of Amity, or honorary professor, as an honor that I'm very proud of. And I enjoy being able to say colleague as something that a badge that I will wear proudly into the future. Thank you all for the opportunity to be here today. This is my first visit to India. And I would like to, first of all, extend my thanks to Dr. Natasha Seer for the invitation, and that of her colleagues, Professor Pandey, Bansal and Sony, who their hospitality and grace have been exceptional over the last number of days and have made me feel really welcome. And I'm actually very sorry that I decided to have such a short visit. Unfortunately, I have to return to work on Monday, but I hope to have future opportunities to come back to India so that I can get a much better experience of the warm culture and the friendly people that I've experienced over the last few days. So I was asked to sort of give some of my impressions from my little sampling of India and of Amity and of this conference. And just a few things I would like to sort of highlight that sort of stood out to me. The first thing I guess to say is that I'm really, really impressed by the really strong connection with industry that Amity has. This has been evident in the participation in the conference, and I've also had the opportunity to see some of the laboratories over the last few hours, which really impressed me how strongly industry is linked with Amity. And obviously, it's not a surprise given the founding president has come from industry and has been inspired to set up Amity to have a huge impact in the education sector. So I think that's something that is the end, I would say, be the envy of many universities around the world, that strong and really tangible connection with industry, with real commitment from industry back into the organization. The other observation I would say is that I could see, the passion of the founding president was conveyed in the inaugural session, but that passion is also reflected in the staff of the university and the faculty. And as students, you should be very privileged to have such a passionate and committed faculty, not demonstrated in the least by the fact that this conference that they put on that is particularly targeted at undergraduate students. This is not something I've seen elsewhere, and I can say that one of the reasons for that is that there's a huge effort and time and work involved in organizing such conferences. I have organized a few in the past myself, so I am very, very appreciative of the work that goes on to make it all look so easy on the day. Requires a huge amount of work in the background between front of room people, but also the backroom teams as well. So I commend the staff involved in the conference for a superb conference, very professionally organized. And it's a real demonstration of passion and commitment to the students at the university that they put on this, which I believe is going to be an annual event going forward. It's a real demonstration of commitment to the students, and it's a real value to students as well, because it's giving you an opportunity to see where the state-of-the-art research is and engage with researchers and academics who are working in that state-of-the-art area. And hopefully that will inspire you to do the dreams, as mentioned by some of the distinguished speakers before me, that you should have, and create the opportunities for you to engage in real impactful activities. And you don't have to go down a research career to have impact in society. In fact, most impact in society going forward in the shorter term, your careers will be through the products that you will develop or the companies that you will start up. And I have no doubt that AI will be a huge part of that.
And clearly that has been reflected in this conference. I don't think there was hardly a paper in the conference that had an AI element to it, or even a talk. So I think that's something that has sort of struck me to be highly appropriate in terms of the context, but something very unique that Amity offers. I would also say that it's not just the staff. I mean, I had the opportunity to interact with a number of students over the last few days, and I can see that passion in the students as well. So, I mean, obviously it's coming from the recruitment process. I mean, Amity looks for students that have that passion to learn and wanting to, make something happen for their lives in terms of making a successful company or having an impact on society. So that has come across to me from the various engagements I had with the students over the last few days. And I guess I would say from my experiences, you're a credit to Amity, and I've no doubt that, and clearly the alumni are really evidence of this as well, that Amity produces excellent quality graduates that do have a real impact on society. So again, another message for me that you're very fortunate to be an Amity student, and hopefully in the not too distant an Amity alumni. Final point I'll make is, again, I'm very impressed by the fact that not alone is Amity and its staff and students have a focus on, rightly so, on the nation, on India. I can see there's great pride in the country, and rightly so, but there's also a global outlook in everything you do. And the fact that Amity has campuses around the world is obviously a reflection of that strategy to ensure that students of the university have a global outlook and have global opportunities with their education. And that I would commend the university for doing that. That's an excellent approach and an excellent strategy. And I would say the envy of many institutions around the world. And I guess as a final comment, I would say there was some excellent advice given by the distinguished speakers before me. And I think I just add to that at one point, and that is that the profession that you're in is one that opens the doors in many different directions. So there are many careers and many degrees you can take, but degrees in IT and engineering subjects, the skills you learn there will make you more prepared for the world than many other disciplines, particularly in a changing world. That the reality is we actually do not know what jobs will exist in 10 years' time, what careers do you want to pursue, because AI is going to have such an impact on the types of work in the future. But without a doubt, you're in the right profession to be able to shape that future. And you will be developing the skill sets and the programs that you are undertaking at Amity to place you in the best possible position to continue to learn. It's not what you learn now that's important, it's the learning process that's important. And basically in the world, you're going to have to learn new things all the time. And I think the comment was made by the previous speaker, you should be planning to be learning every day, because that's the only way that you can keep up with the rapid changes that are happening. But you are in the perfect place to learn the skills to be able to do that. So I wish the students in the group all the best for their future careers. And as I think Professor Soni had mentioned, certainly I will try to answer all those emails that I will get. But certainly, I will look forward to engaging with students either by email, and if you ever happen to have an interest in coming to Queen's, please come and see me. I mean, there are many different areas of research and activity in Queen's that you can be involved in. But if you happen to be at the university, please feel free to drop me a note, and I'd be happy to meet with you if you happen to be at Queen's in the future. Thank you for your attention.
Thank you very much, sir. Your contribution to the conference was invaluable, and we would love to have you for the next edition of InCITe. Being acknowledged by a senior leaders and decision makers is a matter of great honor and pride. Such recognition not only validates our hard work and dedication, but also motivates us to continue striving for excellence. It is a testament to our commitment to promoting innovation, entrepreneurship, and economic growth that Shri Bhanu Pratap Singh Verma sir, Honorable Minister of State for Micro, Small and Medium Enterprises, Government of India, has acknowledged and sent his best wishes for InCITe 2023. We are grateful for the opportunity to be acknowledged by sir, and will continue to work tirelessly towards making a meaningful impact on the field of business and industry. Thank you for your best wishes, sir.
At Amity University, we highly value the contributions of our alumni who represent the university's legacy and contribute to its growth and development. The knowledge, skills, and achievements help to build a strong network of professionals and create a positive impact on society.
It is my immense pleasure to introduce Ms. Kritika Goyal, ma'am. She completed her bachelor degree in information technology from Amity University in Noida in 2009 and secured AIR-1 in SSC exam in 2012. It's a really big achievement, everybody. Please give her a big huge round of applause. She joined Narcotics Control Bureau and is currently serving as intelligence officer in NCB headquarters, New Delhi. Amity School of Engineering and Technology is honored to present Ms. Kritika with Amity Alumni Young IT Achiever Award. I request the dignitaries to kindly step forward to present the award.
And all your students, as I already told you, that Kritika is the first batch pass out. That means in 2005-9 of BTech Information Technology. And this batch had 6 students, right, that time, 7 students that time. And she's coming back to her own campus after 14 years to share her experience that how Amity has added value to her entire career. So no better than Kritika, who's, we still remember all the students of her batch, and all the students of the batch still remember all of us who have been here for more than 15 years or 20 years. So please, with a huge round of applause, welcome Miss Kritika, your super, 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 super senior. Thank you.
Even before starting, I would like to thank Natasha's team, ma'am. Ma'am, so privileged, so honored, and most of all, so happy to come back to my own campus and being recognized like this. I was not expecting this at all. I just came to interact with you guys here today, but I feel myself honored to be recognized in this way. So, Honorable Founder President, sir, Chancellor, sir, Vice Chancellor Shukla, ma'am, dignitaries, my faculty members, my dear friends, colleagues, and everyone else who is present in this hall here, I extend very warm greetings to you all. So you all already know that I did BTech in 2009 from Amity. So, you also know my professional credentials today, that I'm working as an intelligence officer with Narcotics Control Bureau under Ministry of Home Affairs. I cleared exam of Staff Selection Commission in 2011 and then thereafter joined in November 2012. But these are my credentials. These are the parts of my success. But I would like to share my failures today with you all, because when I was always a very good student, I topped in 10th boards, I topped in 12th boards, but I come from a very small rural district of Rajasthan, Savai Madhopur. I don't know how many of you know about that district. So I could not clear IIT or any NIT's exam. So that was my first failure. But then how does it matter today? Life didn't end there. Okay, I qualified for Amity and God had some better plans for me. So I pursued my BTech from Amity, and I think that was the best decision my parents and I took for myself, because if you would have had met me 15 years back, you would not have been able to recognize me today. I was a timid introvert girl who came from a rural background, but Amity helped me immensely on improving on my communication skills, public speaking skills, and most of all to present myself well in front of others.
Very good.
Okay, so that is the thing. And also I would like to mention my second failure was that I got placed with Accenture in my third year itself, and I worked briefly with Accenture at Bangalore. But as my father was a public servant, so he motivated me to pursue for UPSC, and I started preparing for UPSC. But after devoting 3 years, I was not able to make it for UPSC. So that was my second failure. But then I managed to get All India Rank 1 in SSC exam 2011 and joined Narcotics Control Bureau as intelligence officer. So the most important fact I would like to share today with you all is that failure is never final until you accept it as one. Okay? Till the time you are trying, you are striving hard, trust me, somewhere or the other, you will find a way. And also, आप में से बहुत सारे लोग सोच रहे होंगे कि इसका थर्ड ईयर में प्लेसमेंट हो गया था, इसलिए बात कर रही है यहाँ पे खड़े होके. But I would like to mention, Amity में जो मेरा बेस्ट फ्रेंड था, उसका प्लेसमेंट नहीं हुआ था throughout the course, and he was like very disappointed. But after completing his graduation, he qualified for GATE. He pursued MTech from IIT Delhi, and today he's working with Big Five. And I think he is earning the most in our whole batch of Amity. So don't ever accept failure as a failure. It's just a roadblock towards the success. So cross it, keep trying, keep striving hard for excellence. And also I would like to say, keep trying and learning from your own mistakes is the only shortcut to success. No matter what others say, no matter who says कि ये course कर लो इससे हो जाएगा, वो course कर लो उससे हो जाएगा definitely, but करना आपको ही पड़ेगा. So never give up, keep trying, and you are at a right platform, you are at a right place, and you are in the right hands, because the one major part of my success belongs to my teachers. They always motivated us so much. We were just 7 students in the batch of IT, and out of 7, we 4 got placed with Accenture in the third year itself. But still, our teachers never said ki ho gaya tumhara placement. They always motivated us to apply further, to sit in more interviews, to apply for more companies. So that's how you should pursue excellence. So on this note, I wish you all a very best of luck for your future endeavors. I really thank from the bottom of my heart to Natasha ma'am and all my faculty members. And I thank Amity to invite me back to my home. Today I feel like जब मुझे अपनी मम्मी के घर जाती हूँ ना अब शादी के बाद, वो जो फीलिंग आती है ना, वही फीलिंग आज मुझे Amity आके आ रही है. Thank you so much.
Thank you, ma'am, for your enlightening words. We are very much inspired by your valuable experience. We are thrilled to announce the winners of the project competition at Amity University. The projects presented by our students were innovative, creative, and showcased their exceptional skills and knowledge. We congratulate all the participants for their hard work and dedication. It gives us immense pleasure to reward the winners. We hope this recognition will inspire and motivate them to continue their pursuit of excellence. I request the dignitaries to please kindly step forward.
Now, dear students, one short announcement. We are right now presenting, in the interest of time. Yes, you can have that. We are right now presenting in the interest of time, just 2 awards, but then this doesn't end up here. Because our honorable guest of honor, Dr. Ranjana, has to leave for another important meeting at her office. So we will do the 2 awards, and then post felicitation, we'll continue with this award ceremony, and there's a lot more to come. This is for your information. Thank you so much.
The first runner-up was a project on plant leaf disease detection using CNNs by Parth Sharma, Dhairya Dhingra, and Ariel Sangyal. Congratulations, guys. And the winning project.
Now, before the winning project is announced, I want to just read out what the jury has given us. I read, it quotes from what the jury has given. Based on the very quick evaluation, I attached the following evaluations. Please note that all the projects were absolutely great. So the lowest score of 10 still represents very good work. And I scored each category with an impression mark on a scale of 0 to 5, and 5 being the maximum score. So this is what the reviewer and the evaluator has to, say about the projects, that even if he has graded very low or she has graded very low, they were still very good.
Thank you, ma'am. Now for the winning project goes to Augmented Reality Integrated Technology by Krishna Pratap Singh, Gunjan Tiwari, and Aman Raj. Congratulations, guys. Lab here is supporting the gifts. As a gesture of our profound gratitude and utmost respect, we would like to offer a small token of appreciation to our esteemed guests for sharing their valuable insights and experiences with us today. Please accept this memento as a symbol of our heartfelt thanks.
I request Professor Dr. Abhay Bansal sir and Professor Dr. Manoj Kumar Pandey sir, joint heads of Elementary School of Engineering and Technology, to present a memento to our guest of honor, Dr. N. Ranjana ma'am, Scientist G, Director, Directorate of Systems and Technology Analysis, DRDO.
I request Professor Dr. K.M. Soni sir, Deputy Dean and Engineering and Technology, to present a memento to our guest, Dr. Sean McLoone sir, Director, Center for Intelligent Autonomous Robotic Systems, Queen's University, Belfast, UK. We are honored to be a part of Amity University, Uttar Pradesh, under the leadership of Honorable Chancellor Sir, Dr. Atul Chauhan. Sir sets an exemplary standard of leadership by his willingness to lend a helping hand and his commitment to creating global citizens. Chancellor Sir has sent his best wishes for the event for InCITe 2023. Please give a huge round of applause. It is with great honor that I introduce our founder president, sir, Dr. Ashok K. Chauhan. His visionary leadership has elevated Amity to unprecedented heights with multiple national and global campuses. Amity has reached new heights. Young minds are empowered to shape their own destinies. Founder, sir, has also sent his best wishes for the event. Thank you, everyone.
Now that we have come towards the end of the successful story of InCITe,
Sorry. So we request Miss Anjali and Miss Anju to please join us on stage. And we request Dr. Wangmai also. Yes. So Miss Anjali and Miss Anju were coordinating the project. So can we please have a huge round of them for all the project evaluations?
All right, so now I request the dignitaries on the dais to please come forward and present the appreciation awards to our participants. So the second runner-up is the 4-paws pet adoption application by Vishesh Verma and Sohana.
Can we request Dr. Madhuri and Dr. Tomar to please join us?
As a token of appreciation to all our participants, I now invite the next project group for analysis of automated music generation using RNN generators by Ruchir Shiromani and Tanisha Mittal. Please come forward. All these gifts that we are presenting to these participants and the winners, they are sponsored by LabCare. So please, a big round of applause to LabCare. Next, I invite the next project, Lit Parking, an Android application for all by Ayush Kumar Saran, Alvin Philip. The next student group for the project is the AMI print application, a campus printing solution by Isra Imtiaz, Hassan Kamal, Sparsh, and Paritosh Mittal. The last, but by no means the least, the last project that we have is IntelliServe, blockchain-powered intelligence system by Siddharth Tuli, Shashwat Sharma, and Rishi Garg. Please come forward. Alvin Philip. The next project group that presented for this project presentation is Hungrish, the food ordering app by Ayush Gupta. A big round of applause, please. Next, I invite the next project, Asta Insurance Conversational Chatbot by Apurv Jain and Rishika Sharma.
Apart from the projects, this conference would not have been possible without some, I'll not say some, but without all of you, right? Without your brilliant students of ours, without our volunteers, without our participants. And now I guess Dr. Wangmei was in charge of all the volunteering team, and she'll read out few names whom we, would like to honor here. But in the paucity of time, if we miss any name, that doesn't mean that student has not contributed. First and foremost, please put your hands together for every volunteer who has been working. Every volunteer.
Let me just call out the names. Ayush Sharan, third year. Alvin, third year. Harivansh, third year. Harivansh, third year. He's not. Akash Tyagi. Rishi. Pallavi. Siddharth Tuli.
Siddharth has managed the entire website of our event. If you see any update being sent, it is being managed by Siddharth.
Siddhi. Siddhi, second year. Hassan, second year. Hassan. Paritosh, second year. Harshita. Siddharth. Danish. Ashman. Ashman, first year is there. Ashman is not here. Yes.
We have for everybody, but for the photographers, right? And Kushagra is from BTech Artificial Intelligence. Can we have a huge round for him? Who's been
So what award is there for the audience, Natasha? What awards for audience who have clapped also? So all participants will get certificate of participation. All.
Ma'am, Ashman is
Put
here.
your hands together for us.
Ashman has been doing is he's been bringing guests from the guest house, and he's been asking them, did you had breakfast, did you had lunch? That is what he was doing, hospitality. We were thinking we are short of time, but our very, very kind and considerate joint heads and deputy dean engineering and technology has given us permission to continue with the award ceremony further. So can we have a huge round of applause for them? They have their other meetings, but they are here with us.
Mehakpreet, Kashish, Shubhangi.
The registration team, right? They were working for the registration at the counters. Very nice. Very quickly, you please announce the names now.
Rishika, Ali, Rupashi, Drishti, yes, Ali, Rupashi, and Drishti. Yashasvi Rai, Arnav Rai, third year. Yashasvi Rai, Arnav Rai. Kumar Arnav, not Arnav Rai, Kumar Arnav. Akansh, Arunav, second year. Soumya, Ishika, second year. Priyal, Sanyam. Priyal, Sanyam, Priyanshi, Alok, Janvi, all from second year. Soumya, Ishika, Priyal, Sanyam, Priyanshi, Alok, Janvi from second year all. Then I'll move forward to first years. Now then first years, Shaurya, Srishti, Vipul, Ishita Dham, Ishita Dhiman, Khushi, Monalisa, Ashwin, Anushka, Anushka Ishi from first year, Ira, Sakshi, Priyankar, Aditri, Aditri, Sharali, Raghav, Prem Ojha, Isra, please join for the photo.
Ashi Dusia, first year. Settle down. Settle down. We are not finished up.
We are just going to close the session very soon. May I request everyone, all students, to please settle down. We are moving towards the closure. Okay. Now, okay. Now see, I hope now when everybody has worked, I request your attention, everybody, at the end. So I know you all are very excited. You all have worked very hard, and at the same time, you all are very tired. Now, with your support, we all were able to work, right? So your contribution has been immense in the last few days, but there have been people who have been working on this conference for the past almost more than 1 year now, right? So this activity or the closure will not be able to be said complete till until we felicitate and appreciate the contribution of all your faculty mentors. What do you say? Yes? So it will not be able to complete, right? So we request your patience for another couple of minutes when we felicitate all your faculty mentors and your guides. So to begin with, I request Dr. Wangmai to please immediately provision. May I request all faculty members of Department of IT to come. I request Miss before yes, we are coming to your program leader. But before that, one second. Dr. Deepti Mehrotra is not able to join us here today. She has been extensively participating in the review. So the technical review committee, she was heading, and along with Dr. Purushottam, we can put our hands together for Dr. Deepti Mehrotra. Okay. Then we had Dr. Saru Dheer, who was working for the abstract book, and she was working for the paper presentation. So I request Dr. Sarudhi to come forward. Okay. So she had an important urgency, so she is not available right now. I request Miss Ritu Punani, who's been working with the supporters, right? So she has coordinated with Lab Care and she is here. Miss Anuranjana, who has been working with the registration team, right? So put your hands together for Miss Anuranjana. Miss Anju Mishra, who's been working with the funding agencies. She's been working with the funding agencies. And Mr. Vivek Jangra, working for the PhD symposium. Dr. Monica Kaushik, whose husband is not well, but she's been working for registration. Then we had Miss Anjali working for funding agencies and PhD symposium. Okay. Yeah. And we have the organizing secretary who was arranging the various venues, Dr. Abhishek Srivastav. And now we have another organizing secretary who was working for the technical review for organizing paper presentations, and he is Dr. Purushottam Sharma. Right. Please join us on stage. And then, last but not the least, we have the organizing secretary who was involved in paper presentation. Right. So I can see all students for whom Mr. Sunil Chaudhary is the program leader. Very nice. Now, I request all faculty to please stand here, and all Dr. Wangmai, please provide their mementos. And Dr. Wangmai has been running around for all the decorations, venues, and the cultural evening that you saw, the beautiful rangoli that you saw, that has been possible because of Dr. Wangmai. And one person I would like to name, without whom this conference probably would not have been possible in terms of printings and certificates, Mr. Preetham Singh. You know, from printing to cultural to organizing, lot of support that Mr. Preetham Singh has provided. And of course, Mr. Rohtas Kumar for checking all the emails on time. And one person who's been running around, whom we all know, and he is Hemant Bhaiya. Without Hemant Bhaiya, we would not have been able to have the conference. And still he is running around. Hemant Bhaiya is still running around. He is not here. And one person who has joined back work after leave is Mr. Anokhe Lal. And he is also here. Thank you for him to coming back. Thank you one and all. And I request all the faculty colleagues to come back for a group photograph. Come on stage for a group photograph. All the faculty colleagues. Please put your hands together for all faculty members and we can have a group photograph.
With this, we come to an end of the enthralling session and this two-day conference. I hereby take this opportunity to thank all the distinguished guests, respected Founder President Sir, Honorable Chancellor Sir, Honorable Vice Chancellor Ma'am, dignitaries and all the participants for the presence and kind contribution towards the success of InCITe 2023. We look forward to seeing you all in the 4th edition of InCITe next year. Please, I welcome Purushottam Sir to kindly give the vote of thanks.
Thank you, Harshita. Thank you. A very good afternoon, one and all present here. It is really a great privilege that 3rd International Conference InCITe 2023 is being organized by Department of ITSS, Amity University, Uttar Pradesh. I, Dr. Purushottam Sharma, on behalf of Department of IT, would like to express our respect and gratitude to our own founder, President Sir, Dr. Ashok K. Chauhan, for his blessing, encouragement, and inspiration. We humbly thank our Chancellor, Sir, Dr. Atul Chauhan, who inspires us to achieve excellence in such activities. I would like to express our gratitude to our Honorable Vice Chancellor, Madam Dr. Balvinder Shukla, for her constant guidance and leadership. I sincerely thank our guest of honors for accepting our invitation to grace the occasions. I sincerely thanks to all distinguished speakers who have presented and talked about the technicality of this conference. InCITe 2023 is supported by SERB, DST, and DRDO, and in the association with the Sitanda, University of Cape Town, Cloud Labs, University of Melbourne, and University of Pretoria as the academic partners. And thanks to LabCare, to our industry partner, and Springer as our publishing partner. I would like to thank Dr. Salva Murthy sir, President, MIT Science, Technology and Innovation Foundation, for his word and encouragement to this conference. My sincere thanks goes to our joint directors, Professor Dr. Abhay Bansal and Dr. M.K. Pandey sir, for their active supports and guidance. Many thanks to Professor Dr. K.M. Soni, Deputy Dean Engineering and Technology, for his constant support towards the InCITe 2023. We are thankful to Springer for this continuous support and advice which greatly helped in organizing the conference. We are thankful to all those who have attended the conference yesterday and today, all the keynote speaker participants as author, delegate, and session chairs. My sincere thanks goes to Deputy Director Asset and Head Department of IT, Dr. Natasha Hasteen, for her constant motivation and rigorous guidance to the organizing team. I must congratulate the organizing team who have worked really hard to organizing this event. I also thank all the faculty and staff of Department of Asset. Last but not the least, my sincere thanks to the department, team IT supports, managed the event in a wonderful way, and all students, volunteers, and attendees for this InCITe 2023. Hoping this event will be a great learning experience for you all. Thank you so much. Thank you.